React India. React India. React. 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 React. React India. React India. 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 React. React. React India. React India. React React India. 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 React India.
Ankit, we are late.
React
you are going to have,
all the conversations you do,
and all the talks that our amazing speakers are going to deliver to you all. So, I mean, let's get them ready.
So how's the feeling, everybody? Are you all ready? I can't hear you. Did only I have the breakfast? Okay, cool. Welcome, everyone. Let's get started.
Okay, so I can see that the room now is full of energy, and you have my attention. I'll try to assume that it's undivided. So there are a few important things to talk about, so I'll talk about them. Okay, so we have a strict code of conduct. You might have already gone through them, but I wanted to stress that it's there. Just go and have a look at it. We'll also share the slides so that you have access to all the links present in the slide. We also have a strict anti-harassment policy, so we don't tolerate any kind of harassment, so we are not defining it even. If you want to see the details, here's a link. But if you find that there's anything troubling, please meet us. Please meet people in black T-shirts with React India team written over there. So they'll try to help you the best they can. If you want to do anonymous reports, this is the link. As I said, we'll share the slides so you have access to all the links just after this. If you want to make a personal report, there are various methods. You can contact a staff member. You can identify them their staff badges. If you're far away, black T-shirt, that's it. And you can email us at report@gigabyte.info. For any other info, just go through docs.reactindia.io. It has everything from map to all these policies. So yeah, this will be the T-shirt that everyone here from the React India team is wearing, if you want to identify them. And this is the map. So I'll wait for a while. If you want to take a picture, you can. But as I said, you'll have access to all these maps. Food will be served at Planet Dailies and Flame. So I think you might have already seen both of them. But beside the swimming pool, there's Flame. And beside the reception, there's Planet Dailies. Okay, so for whoever is staying in this hotel, the lunch, breakfast, and dinner will be served at Planet Dailies. And for anyone staying at Royal Orchid or Kenilworth, breakfast and dinner from 7 a.m. Will be served at hotels. Okay. Then you might have gotten these bands. Make sure that you wear them. And this is very important. Okay, so we have toilet areas near the pool and spa center area. And we also have portable toilets backstage. So you can check that out. Okay, so we have Megha here who will be in the pre-function area for face painting and some fun activities. So make sure you check that out. This is a bit creative and this is a bit different, so you might want to try this out for sure. So please do that whenever you get a break. We also have a photo booth. Kind of feels like an amusement park thing, but we also have that here. So if you want to get your pictures clicked, please go ahead and do that. And yes, we have a React Chai Wala. So yeah, I mean, you won't be missing chai here for sure. Okay, and please make sure you tweet your experience, all the pictures at React India. Make sure you add the hashtag React India 2022. And yeah, that's it. Thanks a lot. Now, I won't confuse you a lot. I'll welcome Ankit to take you over for the first half. I'll see you after lunch.
Thank you,
okay,
Ritesh.
Then have a good day, everyone.
Thank you, Ritesh. So I think everybody is ready and getting started. So before we just get there, I just have few questions to ask you. Like, have you ever come across somebody who has already figured out what you would want to read 2 months down the line and has 3 blogs, 2 podcasts, and 1 live screen video ready to go? Have you ever come across somebody whose code has been used by everyone who makes the software in the recommended way, that is with tests? I'm not getting anything. And have you ever come across with somebody who listens to podcasts routinely, not at 1.5x, not at 2x, but at 3x? Okay, so I don't think our keynote speaker needs any introduction at all. I would like to welcome the terrific Ken C. Dodds. Please welcome him with a huge round of applause. Yay!
React India. React India.
I think it was connected. No, I think it was working. They just hadn't pulled it up. Because my computer.
React India. React. React India. React India. React India. React India. React. React India. React India. React India. React India.
I can see it down there now, so that's good. So once we get this up, that'd be great. So, holy smokes. Oh my goodness. This is the furthest east I've ever been. I've never been in India before. The last champion was Israel for me, so we keep on going. Hey, there it is. Thank you. My name is Kent Seedodds, and I am in India, and I'm so excited to be here. Yeah. Woo! So this talk is titled The Web's Next Transformation. I'm going to talk about the history of how we've built apps for the web and talk about the next transformation that we have in front of us. If you have heard of me, then you probably know about Epic React and testingjavascript.com. And yeah, raise your hand if you've used either of those. Wow. Thank you. Oh my goodness. You all are great. I'm so happy, and because you're cheering, that's actually really good, so you liked it, so that's good. I'm working on something new. So I am working on epicweb.dev, where I'm going to take everything that's in my brain and put it on a course. So if you thought Epic React was big, like this is enormous. And it's going to take a long time, and I'm live streaming the whole thing. So you go to my YouTube channel, you can watch me build everything. Which will be probably a little boring sometimes, but I'm really excited about it. So before we get too far into things, I always like to start my talks off with getting us moving, because I think that's important to get oxygen into the brain. But I'm looking at you all, and you're like pretty close to each other, and so doing my regular air squats is not going to work here. So what we're going to do instead is we're going to do the wave, right? But you're not going to stand up, because I don't want anybody getting hurt. So just your arms, and we're going to start here, and then we'll go this way, and then I'll have you come back this way, and that's it, okay? Ready? Go! Woo! And on the way back. Woo! All right, there we go. Hopefully that got a little bit of blood going into your veins. Thank you. Okay, so that is the wrong slide. Here we go. This talk is heavily influenced by my friend Ryan Florence, who gave a talk at Render ATL called What the Form. It was a really good talk, and I believe that he's planning on writing a blog post about it soon as well, so you can go reference that in the future. It's a journey through the time as a web developer. How many of you have been doing this web development stuff for over a decade? Yeah. Okay, so this will be like kind of a walk down memory lane for some of you. I'm sorry for whatever pain you feel, because it used to be different. It wasn't necessarily harder, but it was quite different. Yeah, we're going to look at lots of code. I was planning on live coding a lot of this, but there's just way too much. So we're going to just explore pre-written code, and we'll talk about it. And we're not going to be comprehensive at all because there's just too much. So we're going to summarize here a bit. So this is the journey. This is over a decade ago from the time, ever since form was invented, we've been building web applications. And when we first got started, we were building multi-page apps. That's MPAs. And then, around 2003, somebody came up with the idea of progressive enhancement. And we progressively enhanced our applications to make them better. And we'll look at what that looks like. We lovingly refer to that as JavaScript sprinkles. We sprinkled JavaScript on top of what our server rendered so that we could give the user a nicer experience. And then we went into the single-page app era, which is where we are now, primarily. Most of us are working on single-page apps. How many of you would describe the app you're working on as a single-page app? OK, like client-side routing. If you're using React, you're probably talking about a single-page app. So that's the era that we're in right now, and we're entering a new transition, a new phase of web development, and we're going to look at what that phase is. So we're going to play a little game called Follow the Code, because in every single one of these transitions, every single one of these phases, we're going to take a single app and have it re-implemented in each one of these phases. So for those use cases to be supported, that code has to exist somewhere. Somebody wrote the code to make that thing happen. And so we're going to be looking at who wrote the code, where it's written, and where it's run. Okay? So from like where it's written as far as like what file it's in and where it's run. Okay, so with that, I've got our first implementation of this app. How many of you recognize this app? Yeah, To Do MVC. Thank you for helping me see that React is better than Angular. No, just kidding. But that's really what it was about. That's what we got To Do MVC for, was to compare these different frameworks. And now I'm using it to compare these different implementations of how we used to build web applications. So one thing, I'm going to turn us on a fast 3G connection so we can see a little bit of network latency, but not a lot. Well, actually, first I'm just going to say speak at React India. So the app does like what you would expect. I can check off these. I can toggle them all off. I can see the active ones and the completed ones and all of that. And this is the way that it works for all of our implementations. So this is a multi-page app. And so what that means is that the server sends HTML, and it renders forms, and then the user does its interactions. And those forms actually are a full-page reload. And so when I'm on a fast 3G connection, you'll notice the favicon up here is spinning, and I get a full-page refresh for any of these mutations. So you don't actually need any client-side JavaScript here. If I filter this down to JS files, yeah, no JavaScript being loaded on this page, because in the early days of the web, we didn't really have or think or care much about client-side JavaScript. And so the entire application works without that. And the browser is able to take these changes, eat lunches, if that's a thing. It's able to take these changes and serialize the form that is submitting this data into a payload, and that payload is sent off to the server, where the server can do something and then send the user somewhere else or to the page they came from, and it renders new HTML. So the way that this is implemented for our first app here, so we have this server.js. And actually, I'm going to stick this down here so we can keep track of what we're keeping track of. So we're first looking for our data persistence. So for this implementation, the data persistence lives in db.js. And you could imagine this is an actual database, but to simplify things, I just put it all in memory. So we just export a bunch of async functions, and this would be your ORM. How many of you are using Prisma? Anybody using Prisma? I love Prisma. It's an amazing ORM. Highly recommend it. And so this, for me, would all just be like Prisma interactions. It could also be other requests to like downstream services too. So you could be calling into. When I was at PayPal, we had our our backend was kind of like a backend for the front end, and then we just called other services to persist and things. But it all lives here. It's all on the server in this db.js file. OK, so for our routes, if we come down here, this is an Express app. And so we have our routes all defined right here. So we have get route for the to-dos page, and then a to-do/filter, because when I switch between these different pages, my URL route up here gets changed for that. And it actually doesn't make too much of a difference because we have logic in our render app function that determines which to-dos should be shown. And then we also are accepting post requests at both of those URLs because we have forms. And when the user submits the form, it's going to make a post request. We've set that to method post. And then we just redirect everything else to to-dos because this app is kind of small. So that's our routes for data fetching. If we go into this render app, we've got our to-dos right there. So this render app actually kind of looks sort of like a React component. You've got your function here, your props-ish, and then you're returning your HTML. In this case, I've got this handy little extension that'll turn this block of template literal into HTML. It formats it and everything. It's amazing. But there's nothing special here. It's literally just a template string. Back in the day, we used to use, I used Jade, which is now Pug. How many people use Jade back in the day? Yeah, good old Jade. There's also Mustache and various other template libraries. And often, especially over a decade ago, we didn't use JavaScript on the server, at least not for this sort of use case. We would use just about anything else. A lot of people were just like, anything but JavaScript, please. Now these days, we're all looking, how can I use more JavaScript in my life? Now, with modern JavaScript, we got these template literals, and so I don't need a template library. It's actually quite nice. And then inside of here, for my mutation logic, I've got forms. So here's this form. Its method is put or post. Fun fact, the browser does not support anything other than get or post in a form method. You can't put delete, you can't put post or put or any patch or options. Like, what would it do with options? I don't know. So you can't put those different methods. It's only get and post. So we've got our post here for this form. This is for creating a new one. When you hit enter, it submits the form. And you'll notice also we have a hidden input in here. Hidden inputs were a lot more common than they are now back in those days, where you would have some mechanism to send additional data other than what the user has typed. And so for us, we're using this intent value to tell our backend what we're actually trying to accomplish, because all of these forms are posting to the same URL. So we need to disambiguate. You might also instead say action equals some URL, and then you could just have each one handle its own, be its own route. But in this case, I actually really like this, because it means that I can have all the logic for this particular page inside of this handle form post. So when there's a post request, then I'm going to get my form body. This is serialized as a URL encoded string, and I'm using the Express middleware to turn that into this body. And then based on the intent, I know what to do. And so this is where the mutation is happening. So again, all of this is happening on the server. There is mutation stuff happening on the client, and that code lives inside the browser. The browser is the one serializing the form when the user submits the data. So we didn't have to write that code. That code was written by browser implementers, but we are writing the code for handling this form post, as well as all of the other requests that our server is getting. And then finally, for our rendering logic, we've got that hanging out in here as well, again on the server, where we determine, okay, which to-dos should we have displayed, and are they all complete, so I can determine whether to, or how many posts to show and that sort of thing. So that is our MPA. That's how that's all implemented. So there are a couple problems with this that motivated the next transition to the next wave of how we built web apps. One problem with this is every time I make a new to-do, or do any sort of mutation of any kind, we're actually adding an entry into the history stack. So if I click and hold here, I could hit back. Like, I mean, is that a feature or a bug? I don't know. Like, maybe it's cool that I can see what did my to-dos used to look like at some point, but I don't know. That's probably not the best user experience for something like this. The other thing is a full page refresh. Can you imagine if you had a full page refresh every time you favorited a tweet or like retweeted something, or like, what nonsense is that? Nobody wants that. And so, yeah, full page refresh is not going to work for a lot of use cases. And then also, the pending UI for this is not great. I check on this, and then if I'm just looking at the app, I'm not seeing what's going on, right? I have to look up at the favicon to see, oh, it is responding to me. So there was a lot of motivation for us to make the user experience a bit better. Also, like focus management, animations, animated transitions, stuff like that, all motivated our move to the next phase. So this is what I lovingly call the PEMPA. I made that up. I don't think anybody's ever called it a PEMPA, but that's what we're going with. It's a progressively enhanced multi-page app. And so actually the server is almost identical to our previous server because it is progressively enhanced. It is not, so like it works. The baseline, what progressive enhancement means is the baseline is functionality, like it works. And then the enhancement piece is like make it better, okay? So what we've done to make it better is down here in our template we have a script for good old jQuery. Thank you, jQuery. How many have used jQuery? Yeah. Well, thank you, jQuery. Just helped us a lot. And then this todos.js. And that lives here. We have this todos.js. And this, I should have the number of lines in here, but it's like maybe 200 lines of code, is here to make our experience using the app a little better. So let's observe. So everything still works, hooray. So that's good. But you'll notice that we are no longer getting a favicon spinner. Instead, what we're getting is some inline feedback that stuff is going on, new to do. So you could have designed this better than me to have like maybe there's a little spinner that goes in there or something. But the point is that this is one of the reasons why we were motivated to move to progressive enhancement. Is now we can get rid of full page refreshes, we can have inline spinners and all of that to make it that much better. But there were some trade-offs that are associated to this change. For one, holy smokes. This was really hard to write, folks. And when I found bugs and stuff, I ended up writing tests for my demo. So that shows you that. So let's follow the route or follow the code here. So our data persistence for this app, we still have the db.js. That has not changed. So that lives on the server. We're still responsible for writing that. Our routes still configured inside of our server.js. But because we don't want full page refreshes, this is not only configured in our server.js, it's also, oh, actually, this is the wrong server.js. Here we go. It's not only configured in this server.js, but it's also configured in our todos.js, where we have, where is it? Nope. Isn't this like totally the way that it is, though? Like, where is that? Oh, shoot, I don't know. Here we are. My UL filters on click. We're going to prevent default. We're going to do a push state to their href path name. And then I'm going to update the UI because this is an important thing that happens when I change routes, is this active filter. Yeah. So we've got some duplication there. OK, what about our data fetching for our reads? So because we're still server rendering, it's still important that this works without this enhanced JavaScript. All of that data fetching is still in our server code here. So that is unchanged. However, one other thing that when it comes to data mutations, is we're like sort of fetching here when we make these mutations, because we make this fetch request to make the perform the request, so that we're not getting the full page refresh. but it's going to send us back the updated to-do so we can update our UI. So that's like sort of a mix of fetching because we're getting some data back from the server. And so yeah, as far as our data mutations, like all of this stuff exists. And like, look at this. Is this like bringing nightmares back to anybody else? Like, what? Holy smokes. Like, it wasn't long before frameworks like Backbone and stuff started showing up because like this was not fun at all. And the reason that we had to have all of this code is because of this. Event prevent default. So this code existed in our MPA. It did. We just didn't have to write it. It all lived inside the browser. The browser handled all this stuff, and it did it way better than we're doing. Like, way better. Because we're not handling form resubmissions. So if like I change it and then I change it again, or like there are race conditions, like there are so many, like please nobody show this to David Khorshid of XState because he would just like cry tears of sadness of how error prone this code is. And this is like totally resembles the kind of code that I wrote during this phase of application development. I showed up right toward the end of this phase. So that's when I started in web development, was toward the end of this phase of web development. So yeah, that was a pain. And then our rendering logic is also spread across multiple places. So of course, we still have our HTML in here. And you notice we actually have this little utility function called render list item, and we have some utility functions for our icons. But our to-dos.js also has that exact same code. So this is another thing that we had to do a lot in this day was duplicate templates. And often our templates, again, were not written in JavaScript. They were written in some other completely different language. And we had to figure out how to, you know, when you create a new item, you got to have the HTML that you're going to use to generate that on the client. And so, yeah, this was there were a lot of challenges with this phase. And so that's why it wasn't too long before Backbone came out, and then AngularJS and Ember and React. And that's where we got into the SPA phase, single-page apps. Because it was such a pain, we're like, you know, forget this. I'm just going to go full-on, everything is in the client. And this is where we kicked progressive enhancement to the curb. So if I disable JavaScript, then I get this little message, you need to enable JavaScript to run this app. Probably crying emoji or something. So we decided, you know what, it's complicated enough, let's just put everything over on the client. Now, again, like, nobody's going to disable their JavaScript, so like it was pretty okay, but there were a lot of other problems that are associated to your app not being progressively enhanced. And we'll talk about those a little bit. So let's continue with our game of follow the code. Whoops, I messed up. And we'll bring up our Create React app. How many of you are using Create React app in production right now? Yeah, a number of you. No shame, it's fine. Yeah, I hate creating my own Webpack config too. Okay, so we do still have a server, so we're not getting rid of the server. If you're going to have, like, our persistence is still server-side. You know, if you've got a database, you've got to have some way to talk to the server. Even if the app that you're building, you're using third-party services, guess where their code is running? That's running on the server too. So like, you're not going to get away from server-side stuff unless you're building an in-browser game or something like that, which most of us are not. But in this case, now we have this CORS middleware. Yeah, welcome to the world of sadness. So we've got our CORS. We've got our body parser for JSON, because now we're submitting JSON. We have put for to-dos and delete and gets and all. Like, we've got our API routes now. This is completely, actually, this was necessary for our Pempa as well. I didn't show that, but it was because if you're going to be doing fetches, then you need to have API routes for those fetches. So we've got those, but we no longer have any rendering happening on the server. It's all happening on the client. And then we have our source directory. We have our app. This is where our routes are, all configured with React Router. Quick raise of hands. How many people are using React Router right now? Yeah, that looks about right. It's about 70% of apps that are using React are using React Router. And that seems consistent here. We have our icons. These are the components now, so that's nice. And then our routes. And this is cool. We got a co-location of our CSS and our JavaScript. There were like a bunch of really cool things that we got out of this, this transition. We did lose a lot of things too, though. But let's take a look at, wow, what is this nonsense? That is something we did not have to do before. We didn't see it in our Pempa, but it was there. We did have state. We just relied on it in the DOM, and we just like queried the DOM to know what the state of things are. There's actually a framework now called Quick that is actually kind of bringing that idea back, but in a good way. It was not a good way with Pempas. So now we're the ones managing the state for all of the stuff that the browser used to do for us. Here's where we're doing our data fetching. Yeah, this is not good, right? A use effect that just does a fetch and just like forgets about it. Where's the error handling? We do have some pending states, so that's nice. So if you watch this closely, then you'll see it has an initial state that's opaque or opacity of 0.5 or something, just to show some sort of feedback to the user. So that's nice. Although the initial HTML, this should be kind of familiar for folks. There's nothing here. So the user, what they're looking at is just a white screen until our JavaScript loads. But that's OK. We're behind a login screen or something, so no big deal. Or we're not, and we just don't care about SEO for some reason. So yeah, we lost a couple of things in this transition, but we got a lot. Like this is way, way simpler than our Pempas of the past. The JavaScript sprinkles, way, way easier. OK, so let's look also for our data mutations. We do still have forms. We continue to use forms, but we also continue to prevent defaults. So we're not using the forms as they are intended because, again, we don't want a full page refresh. We want to control pending states. And so now we're doing these fetches, again, not handling errors at all. Like this code would kind of explode if we started properly handling errors. But this is especially early days of React and all the frameworks. This is kind of how we did it, except we used XHR. So I cheated and used fetch and promises and stuff. And then and these just make fetch requests, method post, application JSON, sending the JSON. And then for our rendering logic, that all lives here as well. So all of the code still exists, and each phase we're taking more and more of what the browser does onto ourselves and doing it worse than the browser did, which is a shame. But again, there was motivation. There was a reason we decided we wanted to do this. OK, so I want to show a couple of other like iterative steps that were not like full-on transitions, but are like improvement. Oh, yeah. The other thing I wanted to mention about this, well, yeah, this kind of goes into that, is none of us are writing, well, most of us, hopefully, are not writing our code quite like this, right? We're probably using something like React Query or use SWR or something like that, because it like drastically simplifies this. So you're like, Kent, you're saying this is so hard, but it's not. I just use React Query, and now it's all fine. Well, that's great. I also recommend React Query. I think it's awesome. At the same time, that code does still exist, and it is still in the browser, and it is something that we have to think about as web developers. And so in this next example, this is not a transition, but it is a slight change. With React Router version 6.4, you have this create browser router, which is a data router. And it handles not only routing, but also data and like loading of data. And so now with that, we have this loader that's responsible for loading our data. Now errors are actually properly handled and race conditions and all of that stuff. We have our action right here. This actually should resemble something we've seen before, right? This actually looks a lot like the backend code that we had in our initial implementation of the MPA, except we still were having to do this fetch request and everything. But a lot of this is pretty similar to what we had before. So this still exists on the client. We're still responsible for it. Pretty much everything from here on down is, is using React routers, use fetchers and stuff, so we can have a better experience for showing pending states and stuff like that. It's like way easier. And also, I even added error states, because why not? It was a lot easier with the way that this is implemented. So that was an iterative change. And then this next one I want to show is nothing like what we've done before. Nobody is doing this as far as I'm aware. But it actually gets us pretty close to what this next transition is. So this is almost the same, like everything below here is the same as the last one, but the action has changed. And all this action is doing is it's saying, hey, I want you to take the form that is being submitted and just send it along. Like, just keep it going. This is where it's going to go to my API route. And so now my server is over here, and it has this handle form post again. So we're right back to our MPA. We just have this exact same MPA route, because our client has now decided to do what the browser would have done if it hadn't prevented default. Our client is now emulating the browser. It's doing what the browser would have done. And so we can handle that. And it's, like, of course, slightly different, but the idea is that we get this progressively enhanced behavior without having to completely change our mental model for how this works. This phase of SPA, a lot of people who've been doing web for a really long time really struggle with it, because they're like, this used to be so easy. Like, it was not that hard. I mean, we couldn't do all the really cool, fancy things we can do now with SPAs, but like, as far as building it and getting something, and like being productive, getting something shipped, that was way easier. And now we have state management, and state management is what makes shipping SPAs so difficult. So our next transition is what I like to call the PESPA. It sounds like Vespa from Luca. How many of you have seen Luca? Yeah, I love Luca. Luca's great. So in Luca, the villain has this Vespa, and the kids really, really want to get a Vespa. So that's what I think of when I think of PESPA. So it's a progressively enhanced single-page app. And what defines a PESPA is the functionality is a baseline. So no longer is it okay for us to say, hey, you need to enable JavaScript, or here's your white screen, or maybe if we thought about it like a loading spinner until the data shows up. We're going to say, no, the app works. The browser knows how to do all this stuff. We may be taking responsibilities on ourselves, but the browser is helping us to do this, or we're just implementing what the browser has done on top of what the browser does already. Lazy loading and intelligent prefetching. So we're going to, this is another important aspect to this, because we do want to bring in our JavaScript, but we don't want it to take over the entire user's network, right? And our apps are quite large, so we're going to lazy load and but also prefetch, so it feels like the entire application has been downloaded already. It moves code over to the server as much as possible. Anything that can be on the server should be. No manual duplication of UI code like we had in our Pempa stage, and transparent browser emulation. So as far as I'm concerned, I should feel like I'm relying on the browser. I shouldn't feel like I have to write code that the browser does for me. And that can happen with a library. A library can do that. Like, somebody's got to write that code. But I should feel like, as the developer, that I don't have to manage that. And for both my front-end and back-end code, it should feel, I should have the mental model of a multi-page app. So I am actually out of time, so I'm going to go through this pretty quickly. This actually isn't all super important, the rest of this, because all I want to talk about is the fact that we are entering a new phase. So this is the way that it looks like. I'm showing you this with Remix, because I love Remix and it's amazing. Anybody here deploying an app with Remix, like a production app? Okay, a couple of you. How many are working on it? Okay, a couple more. This is good. How many people are interested in it? A lot more. That's even better. Great. So Remix is the only framework that I'm aware of that can do or implements the ideas of what I'm calling a PESPA. But there are other frameworks that are following along. So SvelteKit is also implementing these concepts, as well as Solid Start, and others I'm sure are going to follow soon, because it's really, really solid concepts. So data, I've only been showing you this because I'm trying to illustrate that data never changes. You are always going to have data persistence happening on the server. You cannot avoid that. I don't care how much you're like, well, I want to be able to scale or whatever. You're always going to have stuff running on the server. Okay? So we're going to have our data there. Our icons server, we've got our client, we've got our route right here. But there's no configuration of routes, because in Remix it's convention-based routing. That is not important for the PESPA, but the routing still exists. It's just in convention. And then our to-dos here. We still have that loader, but this only runs on the server. Okay, so no more are we doing like a fetch request to an API route. Those API routes are gone. No more API routes. Hooray! So that's our loader, and this is our action. It looks very familiar to what we had before. And again, this is only on the server. No client-side code for this action. And then our to-dos route. In fact, everything else is the same as it was with our React router implementation of this, because it's just the same. Except I forgot, this should actually be way better if we do that. Yeah, that's nice. So we get nice type safety front to back, all the way from the database to the UI, which is really awesome. Remix is going to manage the code splitting for us. It's going to manage the network requests for us. And our mental model is still like we're building an MPA. That's how it feels. And it's that simple and straightforward, and that's what makes it so great. And then we get to progressively enhance with JavaScript. So we still have pending UI and stuff like that. And that is our PESPA. So to wrap things up, because I'm already over time and I apologize in advance for that, transitions involve both the front end and the back end. And it's primarily revolves around the code and where it lives, who wrote it, and who maintains that, and where it's running. Every transition had motivation, so we shouldn't look at old transitions and be like, oh, that was garbage, like we didn't know anything. We actually don't know anything about the future either, so that's another thing, is every transition comes with trade-offs, and we're often unaware of how, like we know what the trade-offs are often, but we are unaware of how big the impact will be. So we're still learning stuff. We're still kind of in the honeymoon phase of progressively enhanced single-page apps. But I can tell you that this improves UX and DX at the same time, and it's brilliant. The last thing I want to say to you is, you're amazing. Thank you very much.
Thank you so much, Kent. That was an amazing talk. I hope you all loved it as much as I did. Yeah. One more round of applause. Yeah. Now the applause isn't stopping. Okay. So our next speaker is not someone who just builds communities. What do we do with software? Do we build software, or we scale software? So he scales communities, and his community, GDG Cloud Ahmedabad, just hit 3,500 members last week. And doing this, he has figured out how stuff works. Like why you always use only some of the apps on your phone and not the others. And he's here to tell us and demystify that how you can start building those delightful experiences starting today. So please put together your hands for our next speaker, Harsh Shah. Harsh.
React India. React. React. React India. React India. React. React India. 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 React India.
Hello. Yeah. Ooh. So like after a lot of hustle, we finally have the slides on. So yeah, today I'm going to talk about micro interactions. So anybody's heard about what is micro interactions? Like, can you? Oh, okay, like very few people. So yeah, so I'm talking about micro interaction. Like my slide name is like perfect bow to the arrow to modern web development. So I'm only talking about like how you can implement micro interaction to your like web app or mobile app. Okay, so like I don't know. Lot of technical issues. No worry. Okay, yeah. So let's like a little bit talk about me. So I'm a CTO at a company called PaddleServe. We are a blockchain studio. I'm also a Polygon advocate, two-time GSoccer. I work with MIT Media Lab as a fellow. Yeah, I work with a lot of organizations all around the world. I'm a community guy. I handle two community. I build communities like 0 to, as Ankit say, like 3,500 people. Yeah. So I'm also a speaker, mentor. So this quote inspired me a lot. Like Emma Boston is a Spotify program manager, like project manager. So she always told like, I wish I knew how to add animation to any kind of applications. Okay, and yeah. So let's talk about micro interactions. Okay, so micro interactions take your application to ordinary to extraordinary. Okay, so do you see the simple examples? Okay, when you like do a payment or any kind of things, this little like animation, little pop-ups excite you to do like use app more. And as a human, we love the animation, we love the interaction with the apps. Yeah. So micro interactions are the events which has only one main task, okay, and a single person. They follow all over your devices and apps. And the purpose is simple, very simple, to create a moment, engaging moment with your app for user to app or user to web app. And welcome to as a human. Yeah. So these are the two examples, which is I think very much familiar. Like most of our once in a while use the Facebook Messenger, right? And when you like click on any icon, it's like pop up a big way. Yeah. And this is one of the example, which is like my company website. So we implemented this smaller like micro interaction. When you click on to any kind of information, it's simply go to parking lot to another lot, and it's give you the information. This smaller animation help us to like gain more audience to our website, like more followers to our website, and we grow as a business also. So how you create a loop, okay? How you create a micro interactions? Like we talk about you can add animation or anything, but how you can create the loop, how you create the habit to the people. So that's the basic 3 steps. You need to queue, like you need to trigger the actions. The routine, okay, you need to add routine, how the interaction like responds to your performance. And you need to give a rewards, okay. So giving the rewards in the sense, you need to benefit, like after completing all the animation, you need to give reward to your user, okay. What the final touch. And this creating a loop habit, create a more good animation and good micro interaction to your app. So how you can do that? So simply you can do that like that's the 4th step, trigger, rule, feedback, and you can again loop all the modes, okay. So let's talk about micro interaction UX, okay. So UX is a very important part of any kind of web application, mobile application, anything like website building or any building. Okay, without user interaction, you can't like engage more audience to your app or anything. Okay. So this is like, why do they matter? Okay, like you are thinking like you are come here and why do I'm talking about micro interaction? Why do they matter? Okay, why motion for emotion? Okay, so if micro interactions are only tiny design, so why we create them? Okay, why we not create simple UI and give it to the people? Why emotions are very important to your app? Okay, so let's take an example. We are all using Twitter, right? Yes or no? Yeah. So when you like any tweet, like small heart, okay, pop-ups, right? That give you the like feeling, oh, I like the post, right? But think, like, is simply you click the button, is change the color. So do you like that? Or do you like it's pop up and like give you the feeling, oh, I liked this post, right? So that kind of small elements which you add into your app, it enhance your user experience and it help you to engage your user to your app more. Okay, you don't want like user only open your app once in a while. You want your like users regularly use your app and engage with your app, because how you make your profits, how you make your audience, right? So let's talk about some statistics, like why micro interactions are important. Okay, so I work with a lot of companies. I work with the like big names in India, like Jio. We also work with the Google. Okay, like a lot of Web3 startups like Bikeonomy, Ethereum Foundation. Myself, I work with the Polygon. So when I pitch them why this kind of elements of this kind of UX is important, so we see immense growth in a customer engagement or customer and revenue also. So if like customers are 10 in before without any kind of animation or interaction or better UX, it's grow to ultimately like every time it's grow like more than a 20 to 30%. So let's talk about a research or like study with like I also involved in this study. So what we do, we come to the go to the company come to us, and it's like first revenue is like not more than $1,000. We eventually grow their revenue to $14,000, and like after a lot of brainstorming and everything, we add a lot of UX to their app, because UX is very complicated to their apps and users are not very familiar. We add a lot of micro interaction, and they grow like 66% after like adding all the animations and all the user experience. So this is like immense growth to them, and we make that business to like more than 100x, and now their revenue is more than 100 million. So this is how we are building micro interaction to companies. Okay, sorry. Okay, so why micro interaction rocks? Okay, so it's always improve your website navigation. It makes easier user to interact with your application or website. It's provide instant feedback, okay, and complete all the actions to the users. User experience are more rewarding than the normal user experience, okay. Then encourages liking, commenting your content or sharing your content, okay. And it finally just makes site very emotional, okay, very attachable. And yeah, so when to use them, it's very important to when to use them. You can't use animation anywhere, okay. If I use animation on my like a landing screen, sometimes it's like, why is take more than 5 or 6 seconds? Okay, it irritate me as a user. Okay, I don't want the animation pops up and to my face and like, oh, it's like I need to wait for 5-6 seconds. Okay, that's why it's very understand to how to use them and when to use them. Okay, so when to use them, you can use them as a, like these are some examples which I eventually figure out from like researching and talking to a lot of product companies and all. You can use as a like swipe, like data inputs, okay, like in current system status, like smaller animations, like call of actions. Okay, these are some examples you can, like where you can place your micro interaction or smaller animations. Okay, so let's talk about like how you can build your micro interactions. So first, you need to put yourself in your user's shoes. Okay, first you need to understand what user want. Okay, don't try to implement what I want as a product or what I want as a client. Just try to understand what user wants. Okay, because ultimately user is your primary goal, not like my satisfaction. Okay, create a proper functions, like proper animation, which is not like more a complex one, but is a very easy to understand one. Try to have a fun with your user. Okay, it's definitely need a proper emotion to connect with your user first, and try to have a fun with the user. Don't be annoying, because I already told, like, if you pop up, come to my face or anything, I don't like it. I need to be a like very smaller one or very elegant one. And like always try to be in human language, because not all users are technical users. Most of the like 80% of audience are not technical users. Okay, so as much simple, as much human language based animations. Okay, and for building any kind of micro interactions, you have like basically a 3-state. You need 2 interactions, state and animation. These are the basic 3 steps you need to use any kind of building a micro interactions. Okay, so animations, yeah, like how you can add animations. So animation, you need to first check like accessibility, okay, like human behavior, like reliability, how reliable your animations are. You need to check performance, because before that, like now we have a more powerful phones or more powerful computers, but before that we have like only 1 GB of RAM in mobile and very limited storage, okay, very limited like processors power and all, GPU powers and all. But nowadays you have a power within your palm, you have a powerful CPUs, GPUs. So you need to understand how you build your animations, and performance is very important, because if lagging your any kind of animation don't attract your user. And it need to be purposeful. Don't force the animation to your users. Okay, if we talk about Twitter, the simple like is purposeful. Okay, they are not forcing us to praise that a like button or heart button. That is very important. Okay, so let's talk about what tools you can use to design a micro interaction. I hope everybody know about what is SVG. Okay, yeah or no? Yeah. So yeah, so you can use SVG, you can use simple HTML, CSS, and there are a lot of JavaScript libraries on modern web APIs available, which you can use as a tool, and you can create your micro interactions. So let's little bit understand about what is SVGs. Okay, I know you all know, but let's go through a minute. So SVG is basically scalable vector graphics, and when we use SVG vector-based graphic on a web, even on the mobile, most of we use a JSON file or Lottie file. So every SVG has every element, like group by group, and it supports most of the browsers nowadays. They serve on HTTP request, and it's make life easier to any kind of animations. Okay. So these are some SVG library, which is my favorites. Okay, so most of the time I use a GreenShock. Okay, GreenShock and React Spring is one of my favorite libraries, which I use all the time for all the clients, even my personal projects. For React Native, I use personally first my preference is like native APIs, because native APIs have a good performance scope. Or if I don't find any kind of animation in native APIs, I use React Animatable. That's one of the best library available in the market, and is like very good open source and contributed. Yeah, so this is the example. So yeah, let's go to the example simple. So I'm just animating a slide, okay, slide up and down. If I simply go to the code, is like simply you need a one library, simple called React Native Animatable, and I'm just simply creating a class. Okay, I'm not using the hooks on this code, but you can also use the hooks. React hooks are also available in this. And I simply use the like area, and simply just passing down the animations props like animate, slide in, slide down, interaction count, like how much time I need to like slide up or slide down my animation. And this is simply like 6 or 7 line of code. You can simply like create any kind of animation. Yeah, so I think that's it. Yeah, so you can contact me. This is my.
Thanks, Harsh, for the amazing talk. I loved how he makes his users fall in love with the apps. I also need a similar strategy for my social media because every time I post, I lose 10 followers. So Harsh will sidebar.
Yeah.
Thank you so much.
Thank you. Thank you so much.
Cool, cool. So, okay. So our next speaker is someone who's naturally creative, just like me. So, I mean, a lot better. And she's someone who picked up drawing in school with sketch pens, which now continues on code pens. And I'm also told that she makes the absolute beautiful doodles, but they're never selected by Google. So it's only fitting that she comes here today and tells us not just the story about how to build beautiful design systems, but builders for them. So please put your hands together for the very talented Minu Makkar.
React, React, React.
For your beautiful words, but you're funny. It didn't get selected because I have not submitted it to Google. So yeah.
React, React India. Yeah.
Sorry, actually I have split the notes and I want different screens to be presented, like to show here and
Oh, this is a Mac.
React India. React, React.
Hello. While we are having some technical problems, I want to show some people problems. I'll just locate somebody and ask some rapid fire questions that should have only one answer. What's your favorite framework? Answer is?
React.
React. That's right. I am now, excuse me. Who's your favorite MC? Answer is?
you.
She said my name. Okay, we are still not done on the first. Let me go to that row. How are you feeling today?
Really good.
I did not hear you.
I'm feeling really good.
Are you all feeling good? Cool. Okay, I think I have to keep on with my creativity. Who's looking sleepy here? Who's on their phones and not following me? Excuse me, what's your name? Akshay. Is that the right answer? Okay, you win. What's your name?
Srishti.
Your name is Srishti. Is that the right answer? Okay, good. Well, I think we are good. Have fun, everyone.
Good morning, Goa. It feels great to fight the pandemic and stand here talking to you all in person. So, I am Meenu. Okay. I am Meenu. I work as a software developer at Geeky Ants. Currently, I am working on native-based ecosystem to bring design and development closer. For those who don't know what native-based is, native-based gives you beautifully curated low-level React and React Native components for rapid app development. It has more than 18,000 stars on GitHub. It is open source. Apart from work, I sometimes spend my time in doodling, and that's my sum of works. You can follow me on Twitter. I go by the handle Makkar_Meenu. And that's me, because my friends canceled the Goa trip for the 8th time, and I was filling the React India CFP just after that, just to come to the Goa. Okay, now keeping that friends betrayal aside, let's address why, the second reason why I am here for, and that is how we build a design system builder. Before we dig deep into the topic, just a disclaimer, I'm not an expert, just sharing my learnings over here. Okay, so before we dig and start experimenting with the tool and explaining the tool, we need to know what is a design system. A design system is an enormous term. There are a lot of definitions, perspectives established around design systems. One of them that was stuck with me was given by my friend Tanisha. She is the mind behind all the designs around native base. She gave a talk about busting myths around design system, in which she told design system, she gave a very well-defined, summarized definition of design system, in which she told design system is a principle, collection, pattern, building blocks, set, documentation, standard that helps us in managing design, reducing redundancy, tying the whole product together, and accelerate the design process, which includes reusable components, UI patterns, style guide, voice, tone, technical documentation to provide shared language, visual consistency, standardization, better organization, rapid product development. I guess no one can remember this definition, but this is a good cheat sheet if you want to look for what is a design system. Now that we know what a design system is, let's see how building a design system process looks like. So there are certain steps that we usually follow to build a design system. To try this and understand this process better, we will try to take an example of a brand. Any suggestions? Oh, someone said Coca-Cola. Obviously, that was scripted. Moving ahead, and that's my friend. Moving ahead with some assumptions about the brand and the design processes, let's try to build a design system for Coca-Cola and manifest free supplies for the lifetime. Okay, the first step is analyzing your design process. Here are some questions that we need to ask the company, like what is the design process of the company follows? What does the company follows in internally? What tools do they use? I'm not sure about what Coca-Cola uses, but let's just assume that they use Figma and move ahead to the next step, and that is recognizing the brand's alphabet. Brand's alphabet is basically recognizing the brand's identity, that is product values and the brand type, whether it is a professional brand or a modern brand, what kind of mood it wants to depict to the user. It also includes identifying the brand languages like colors, etc., that should be used in everything in terms of design that is user-facing. If we talk in terms of Coca-Cola, this is a company best known for the used at the time of happiness, joy, and good experience. The color red in the marketing portrays power, excitement, energy, and passion. It also stimulates the appetite, which makes it a good choice to choose a red color, like while branding a food or a drink. Then comes UI auditing. UI auditing includes identifying various statistics about the product pages in terms of design, which is finding the inconsistencies that the website and the product has, and identifying the most important and most used components in the website, and make a component out of it further. On a side note, I found a really cool tool to do that, csstats.com. This does this very nicely. It shows the colors used and the fonts used in a website in a very graphical and put together manner. Let's explore this tool and analyze what Coca-Cola website has and see what it generates. So this is how it shows. Coca-Cola uses a lot of red color, and they might have inconsistencies in terms of shades of red. So we have to find those inconsistencies and get along with the process of building a design system. We start with defining things like after analyzing, and it starts with defining design principles. Decide design-related principles such as brand identity and values that are depicted using design. A good way is to use a mood board and start jotting down what feels like, what describes the brand. If we build a design system for Coca-Cola, design principles can be real, bold, the power of red, and be familiar yet surprising. Next is building a component library. Yeah, it consists of all the styled and designed parts of a website or a software to help designers and developers work consistently and reduce the repetitive work that goes behind. I think the tech part of a design system starts with component library. In the website, these buttons, if we see, have same styles across the website. They have same border radius and uppercase text, I mean, even the color, somewhat. Like similarly, the products, cards, etc. have same buttons in the merchandise shop. These rounded buttons must definitely be defined as a component. Next is defining rules around design system. Defining rules about what is allowed by the team and what is not while extending a design system, and use it in a most creative way possible. The objective is to not lock the designer in a particular direction and yet not divert him from the design system. So designers and developers should follow a particular process while introducing something new or new components or new tokens. Let's see how rules are kept in mind in this banner. So Coca-Cola, while introducing different flavors, which didn't have red branding in them, but that depicted the flavor color of the drink, made banners that go really well with those, like the CTA button is really going well with those buttons and fonts. And I feel the mix and match of everything is very creative, and yet it is feeling very authentic. It is giving a very fresh feel to the new launch. And after this, we have come to governance strategy. After building a design system, we should have a way to govern that also. So there are 3 models of governance strategy. First is solitary, centralized, and then federated. Solitary is basically in which one person decides and approves the rules around design system and other people follows that. Centralized is the one where there's a team of design system and everybody follows those rules which are made by those team. And the last one is the federated model. Federated one is where several people from several teams are in charge of the design system. I'm not sure again what model does Coca-Cola uses, but they have different brands under the Coca-Cola company. So they must be using a same common design system for the whole company, and there must be a separated one for each brand that they have. Let me know your opinions about the same. Now the last one comes, which is very important too, and that is document and communicate the design system that is built. If teams start to use a design system, it is very important to communicate the changes to the teams, to update their process as well. So the documentation comes very handy in such cases. I think Coca-Cola has the internal documentation. By the way, we will also try to make one documentation for them. Like we are building a design system builder, we have all the processes set. So we will try to make one documentation for Coca-Cola brand. Our solution of building a design system builder is currently solving few parts of this entire flow, and that is in currently development phase. So how we got the idea of building a design system builder? Definitely by failing, learning from our mistakes, trying different solutions, giving it time to mature. And yes, we at Geeky Ends were always into building design tools and libraries to bridge the gap between designers and developers. It all started with Native.js version 1. That was a very simple component library which didn't have any theming or any option to customize the components. Then came V2 with the main focus that components are easy to theme with very few modifications. Then comes BuilderX, which was a design to code tool that generates React and React Native code for you. So there are a lot of features which we could easily build production ready apps. But due to absence of design system, we could not extend this tool to its full potential and appeal to larger masses. After that, Native.js got released. It is accessible, highly customizable, universal. We also changed our APIs to utility-first approach. So we already had a solid component library backing us. So we thought of using it to create a visual coding tool that can use its full potential to make production-ready apps. This is in development state right now, but again, as BuilderX, this also needed a design system. Now that we have Native.js, we felt it was very easy to be created. We also have a component library, and it was fully customizable. So we have a part of design system which could be inbuilt in this Native.js builder. So we embarked the journey of creating a design system builder that can be used in isolation for creating design system and can be incorporated with design system builder, or the app builder that we were talking about. So we broke the design system builder in smaller services that are provided by different modules. So the services includes generating a theme that can be used in Native.js, Chakra, and Tailwind, which mostly people use these days. Creating a component library, using these libraries with the themes inbuilt. Building a documentation website that includes all the in-depth knowledge about the particular design system. And then generating and publishing the Figma component library of the design system. So we have a bunch of modules that are used to provide these services, and these includes theme editor, asset management system, content management system, and the Figma plugin that we were talking about, which generates the component library for Figma. Let's see how and where these modules fit into this picture to help with these services. I'll explain one by one. Let's see how we are creating a theme on top of a library through this visual editor. We created a visual feedback tool to manipulate native-based foundation and component theme, which will help users to create a customized component library for themselves according to the brand requirements. Users can customize the color palette, typography, and all the foundation level theme properties available by the native base. We can also customize components base style, the variants, and change how component will behave in different states, like in hover, focus, press, etc. in different modes and platforms. We call this theme editor. After changing theme to their own values, then they can export the JSON file of the extended theme, which they can use directly in their native base apps. This is the theme JSON file that is exported from the DSX editor. We can directly extend the default theme of the native base with the JSON exported from this editor. Next, what we need was component library. So we had a theme and the native base library already built. We have to just click on the component library download button from this editor, and you get a component library zip file with the storybook in it to use by the developers directly. You just need to install the packages and your storybook runs. So the major part of design system was solved by this. And then comes the documentation that plays a very important role in maintaining a design system on a larger scale. To solve this problem, we also have a way to generate a brand website specifically for the brand. Then comes the documentation. Okay. With all the documentation about how and when to use a design system. So this is how the documentation looks like. Oh, we didn't realize that it looks like Coca-Cola. Yeah. So every brand design system have few assets, like logos of different contrasts and illustrations, or any other files like font files that they want to keep in the design system asset. We have a asset management system to handle those cases. We realized that few things in terms of content that needs to be highlighted and like design principles that need to be mentioned in the documentation website that follows like a design system. To keep track of those things and mention those in the website, like, so we have a separate module for that, that is content management system, like to keep all the content related to the design system. We have almost covered all the part of design system for developers, but designers also need the component library to remain consistent across their designs of screens. So if developers and designers will use the same component library from the same source of truth, there will be no chances, like very little chances of inconsistency across design and development. For this, we are publishing the Figma component library. So keeping storybook that developers use as a source of truth, we have all the combination of props and the components that are being possible using storybook controls. So how does all this flow works with Figma? Like how does this get auto-generated? We have a storybook and a component library for the developers to work on and add the custom components as well. To create a Figma component library out of it, we should have all the visual variants of all the components. We are creating HTML pages for that, or all the variants, and then we have a plugin in Figma which takes all the inputs from that HTML page and all the variants from that hosted HTML pages and map all the properties to make a Figma component library. The example that you see right here is a Figma component library automatically generated from that Figma plugin. The entire flow that we discussed is now complete. This solves a major part of design system, I would say. Like, there are a lot of advantages of building it in the first place and then scale. Few of those are, like, we can manage the design system from one platform. There is design to code consistency because the source of truth is single. And we get a auto-generated component library. You don't have to create from scratch. It's just we are giving a boilerplate for that. There is no need to develop component library from scratch. And yes, developers and designers will use the tool they are comfortable with. They don't need to switch the coding thing and the Figma thing they are comfortable with. Yeah, that's all. So this whole talk was our native-based team effort. So huge shout out to them. They always say hoga hoga, which means it will happen, and finally ho gaya. Thank you.
Thank you, Meenu, for such a wonderful talk. And I really loved her message that, hey, if you want a design system, don't build it from scratch, use hers. So excellent self-promotion. Thank you, Meenu. Okay, so up next we have a very exciting section. We have a 25 minutes break where you could grab tea or coffee. So all of this is, excuse me, wait a second. Do you know where that is? So please wait till the end before you click subscribe, like, and whatever. So you should head towards Cinema Paradiso. So you would have seen the place where you would gotten your badges registration desk. Left side of that, Cinema Paradiso, there are 3 things there. First is job board. If any of you are hiring, I am hiring by the way. So please put your jobs on the job board. Second is, do not forget to have your tea, coffee. There's a dedicated tea stall, React Chai Wala. And for those of you who are standing at the back, because this is so full, because we have an excellent conference, there's a community hall wherein we are live streaming all of this, so you could sit there and watch from the comforts of chair. But if you still want to stand here, you all are our guest. Okay, thank you everyone. See you at the coffee break. Do not just go on your phones. Please use this opportunity to talk to speakers, all the attendees, and just get some networking done. Thank you.
React India. React. React India. React India. React. React India. React India. React. React India. 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 React, React, React. React, React, React India. React India. React, React. 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 React India. React, React, React.
React India.
React India. React, React, React.
React India.
React India. React, React, React.
React India.
React India. React, React.
React India.
React India. React, React.
React India.
React, React, React. React India. React India. 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 React, React. React India. React, React, React.
React India.
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 React India. React, React.
React India.
React India. React. React India. React India. React. React India. 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 React. React India. React India. React. React India. React India. React India. React India. React India. React India.
So, Nishtha, come here. So, is this your first time in React India? Yeah. If she would have come last time, she would not have come. Okay, so what have you liked so far here?
The complete atmosphere is really good. I got to meet new people here, making new friends. Yeah, apart from that, I just attended one session so far.
You shouldn't say that. You should say I attended all the sessions.
No, I'm just speaking the truth. So yeah, I attended one, but yeah, that was good. I got to learn something new. So.
Thank you so much, Nishtha. Please, a round of applause for Nishtha. Make sure that you find her network. Okay, I see that the crowd is filling up. I would want to call somebody who's looking very fun. Okay, one who's very enthusiastic, please come onto the stage. You do not know what's going to happen to you right now. Okay, what's your name?
I'm Yash.
Okay, he doesn't.
I'm Yash Gupta. Yash Gupta.
Okay, Yash Gupta, what do you do?
I'm a student as well as I'm a developer. So I work as a contractor.
How old are you?
I'm 19.
I think he just peaked 10 years before me. Cool. So why do you like React so much?
I mean, because
You would need experience. Thank you. Good, Yash. Thank you so much. I see audience again filling up. Who wants to go next? No. Okay. Okay, come on. He's very enthusiastic. Any audience questions that you would want me to ask him? Should we roast him right here? Okay. What's your name?
Rakesh Purohit.
Rakesh Purohit. What do you do?
I'm a React developer and developer advocate.
Okay, so you just tell people what to be done and you never do anything?
As I said, I'm a React.js developer and developer advocate. So both are there.
Okay, he's playing it safe. And where do you work?
At The Wise in Surat.
Okay. What's the speciality of your city?
Food, especially any kind of food. You come to city and you will lost in the food.
So I have heard that, what is one delicacy that you would want all of us to go and eat there?
It's locho.
Locho, okay. I have to do a bit of socho for this. Cool. Thank you for being a great sport.
Thank you for roasting me.
This was not roast at all. I'm being nice. Okay. How's everybody doing? Can you please call all your friends back because I have to do this. I have to really crack my brains up to be creative. I'm not. Anybody who would want to come and take my interview? Let's flip it. You have a question for me. I hope it's easy.
I did.
What's your name first?
My name is Apoorv Khare. So I work as SDC at Adobe. So I have a question for you that I applied for a lot of talks, like 4 or 5 talks for this year, but none of them got selected. And so
Same as me.
So like I wanted to know what is it like? What do you apply? Or like how do you apply so that you get selected? And what sort of experience is required? How do you get shortlisted?
Okay, I think this is a great question for speakers. So here he's asking that he has applied for a lot of talks. He submitted a lot of ideas, but none of them got selected, just like me. So I had to find myself another job as MC. So this is a question for all the speakers here. Can we have a show of hands? Who's a speaker sitting here? And he wants to know, what is the secret of getting selected in the talk?
The secret to getting selected is the talk abstract and title has to be something that people are going to be like, oh, I want to learn that. It could be, like my talk that I'm doing now is not...
No spoilers, please.
Yeah, it's not even that special, but people want to learn how I learn because I'm just learning stuff with hacks, right? And that's why they come. So think about, at least since you asked for advice, think about like, what would someone want to learn? And if you know that, that's a great place to start. So.
And it's not sunny here. You are wearing exquisite shades. Okay. We have another enthusiast who would want to ask a question. Yes. What's your name?
Surender. I was just answering his question in the fun fact. If you don't have, like a very good agenda, then ask your company to sponsor the event, and then you'll anyway get selected as a speaker.
Okay. I would neither deny nor say yes to that fact. I'm not allowed to say anything officially. Okay. I would just now ask one of our international speakers that, hey, how are you feeling?
Amazing.
Okay, that's the vibe we are looking for. Okay, I still see people trickling in. They need to be like very die-hard chai lovers because who drinks 7 cups? Folks, why are you so late? Please take your seats. Okay, who wants to go next? Okay. I think we'll just take 2 more minutes. I see a lot of people coming in, and then we'll get into it.
React India. React. React India.
Question, and I want a very loud answer, right? I would not want a meek answer. So what's that one random fact that all of you remember from your cell biology lessons? What is that one lesson? What? Dash is the? Can you all please stand up and say it? I can't hear it. So mitochondria is the powerhouse of the cell, right? And do you know why you remember this so clearly? Duh, because power, right? And our next speaker is no different, right? So, and he is here to light us up and razzle-dazzle us, and he will make learning fun with hacks. So please everyone, please put your hands together for the powerhouse Tejas in the house. Whoa!
Give me more, man. It's like you're sleeping here. You had 7 cups of chai and you have no energy. Let me hear it as loud as you can. Hey, that's what I'm talking about. Huh? Hey, it's really good to be here, and I have a lot of content. Ah, the clock's not going down. Ah, now it's going down. There's a big clock here. I'm going to try to ignore it because I just want to talk to you. So, hi, how are you? Excellent. My name, I'm so happy to be here in India, my home, where I was born. Let's give it up for India. It's huge. It's a huge deal. You know why? Because I speak at a lot of conferences, and usually they're in like white people countries. It's fine. It's okay, but my name is Tejas, right? And I often introduce myself like this. Hi, I'm Tejas. Hey, wait, I don't have slides? We need to fix this. It's a very important. There we go. So I say my name is Tejas, like contagious, for the people to understand. I could say this until 2020, and then being contagious was a very bad thing. And so then I had to change it, right? To say, hey, I'm Tejas, like advantageous. But this feels dishonest because I don't know if I'm an advantage. How can this like, check me out, I'm advantageous, you know? But thankfully, React India 2022, I get to just be myself and tell everyone, hey, I'm Tejas. So, it's just good, it's just good. I can just be myself, Tejas. In fact, let me quickly introduce myself and we'll get started with the actual content. I work at a company called Zeta that is a sponsor, thankfully. We're thankful to be able to sponsor this conference. Our logo is over there, under the bronze thing, so we're not cool like Push Owl or anything, but still, yeah, it's nice. And I'm the director of developer relations. So really my job is to manage relationships and make sure all of you get a good time, but also, get some education, okay? We're here to talk about today understanding concurrent React with hacks. Understanding concurrent React with hacks. How many of you have heard of concurrent features in React? Okay, that's good. This number will go up, hopefully, by the end. Suspense has been around for a while. Suspense for data fetching is out, but kind of they tell you to use it in libraries and so on. We'll get into all of that good stuff later. But first, I need to acknowledge some stuff, okay? Because, listen, this conference is very special. Do you feel like this conference is special? Yes. It's really special to me because Manjula, and Sahil live in, the organizers, they live in Berlin, and we meet up sometimes and talk. And we were at another conference. We were at JSConf Budapest. And Manjula, I was the MC there, so I was Ankit of JSConf Budapest. And it's a stressful job, And so Manjula said, hey, do you need anything? She was there, do you need anything? I was like, I have no energy. Next thing I know, she goes somewhere, brings me a cup of coffee. This is the mindset of, this is the way they work so hard to give you all a great time. So I want to say and acknowledge, thank you, Manjula and team. Give them, it's huge. It's huge. But there's another reason the conference is very special to me. This one specifically, because 9 years ago, I feel old, 9 years ago was my first talk ever. And my father was there. It was a TEDx event, TEDx Youth at Doha, and that's my dad. If you see him, he's here somewhere. He's actually right there. And my dad is here today as well. He's right there. So it's really special. It's really, really special. And so I just want to say thank you, React India. It's a phenomenal experience. And to think all of this is just for the community and for love. So appreciate it. Anyway, we're here to talk about understanding concurrent React with hacks. But this slide, it looks too serious, It's like formal. It has like a suit and tie and stuff. So let's use some Comic Sans and some internet nostalgia. Hacksaws. Anyone was around at this time, or am I just old? Yeah, okay, I'm just old. There's one guy in the back. I'm ashamed, I'm 30. Let's add some color. Let's have some fun. Learning is fun when it's fun. And nobody likes going to school because your teachers sometimes yell at you, right? But let's make it fun. In fact, this is React India. And listen, I'm all about being true to roots and localness. So instead, we can just go full on. Hacks ke saath concurrent React ko samajhna. And it's React India. I might just do all the slides in Hindi. And I know there's multiple languages, and I should do them in Konkani, but listen, give me at least some leeway, Before we move on with the talk, just a warning, these are hacks. If you want to use React properly, you're clapping for hacks, awesome. Read the docs. The documentation is the source of truth, okay? We're trying to understand some stuff, but I'm not here to tell you, use this in your day job in production. But I do believe if you understand the underlying stuff, you can be more effective at your job, okay? So this is meant to complement the docs. It's not the truth, the whole truth, and nothing but the truth. So with that, I want to get into this. And sabse pehle ek chitra, okay? Why are you laughing? I'm Indian, like in the airport in immigration, I came here, right? This guy takes my passport, Indian passport, and he's like, so actually where are you from? And I'm like, I'm Indian. People don't believe anyway. I want to talk about the backend specifically, because with concurrent React, it makes the user experience around data fetching, around I/O, input-output at the network, much more comfortable. And that's React's job, to give you a good user experience with I/O and CPU. Okay, we're talking about the I/O side, the network side. So I want to draw a diagram about backend complexity and show you how that can conflate or inflate your UI. And this is important because a lot of this talk is data fetching, so it's important for you to understand. So if we go over to my browser here, and there's a great tool, it's called Excalidraw. Anyone know Excalidraw? Yeah, a lot of people. Viju, great author. So what I want to do is draw a diagram for you of why concurrent React is needed. It's needed, again, for rendering large sets of things, but it's also needed for I/O, network input-output, okay? So what we want to do is draw a diagram of back-end to front-end communication. In a very basic sense, why is this a dashed line? I want this. So in a very basic sense, we have a UI, that's usually a React app. We have this UI talks to
an API that's maybe distributed. This is very basic, right? And then this talks to a database, which is maybe, actually, we'll get to that later. So this is the standard, overly simplified application. This is the layers of communication across the stack. What happens, though, is scale. And Concurrent React really solves the use case of scale on multiple levels. So let's talk about that. How does this infrastructure scale? You have a distributed API, that's cool, but you have a single database. As your database needs grow and start to maybe overwhelm the system, you need to start scaling your database. Now, traditionally, with relational databases, you would scale them vertically. So you would add like memory, you would add disk space, you would add resources, right? And this only goes so far. After this point, you build a supercomputer. Your database machine becomes like this massive, beefy thing. It starts costing money, maintenance time, and infrastructure costs, like electricity and stuff like this. If you want to scale more than that without building like a massive, like, Intel Xeon gaming whatever, you scale horizontally. So you add multiple database servers, and you have some type of primary and replicas, right? So the primary database will receive all the write operations and then save them to the replicas. This is kind of getting to scale already on the back-end side. But notice the UI is just the UI. And it's already a bit disproportionate. This will work quite well, but at some point it's going to get slow. Can someone tell me why this would get slow? That's why I'm giving this talk. So it would get slow because databases read and write to and from disks. And disks are usually slow. They're not the fastest. What is faster than disks? SSDs. What is faster than SSDs? RAM, random access memory. It's just by design, it's meant to be fast. The data structures, everything's optimized for speed. So what you'll do is, in your data infrastructure, you will add, maybe somewhere here, you'll add a in-memory cache, something like this. That's also going to be distributed, and so how it will work is, if you get a request to your API, it will check the cache. If the cache doesn't have it, then it will get it from the database once. It'll be slow, but it'll store it in the cache, and then it's going to be fast. Always, right? So that's already an optimization. And let's just make this distributed, and then we're good, right? This will scale. Actually, a lot of companies just have this, and it works pretty well. But over time, you accumulate what? You accumulate data volume. You just get loads and loads. Your terabytes become petabytes, you get a lot of stuff. And if it's a social app like TikTok, Instagram, anything with a lot of, like Reddit, anything with a lot of content, you have just tons and tons of posts. What do you need? You need a way to find what you're looking for. You need a search engine. So okay, let's add this at scale. So let's go here, and we'll do, let's do a search engine. And that's also going to be a distributed system. And, ooh, look how complex. And so now, your database needs to save itself into your search engine, which is another database. And your app needs to know, like, when to talk to what. And this is data infrastructure at scale. Pretty much every application on the web that is at any amount of scale will have some variant of this. Keep in mind, this is oversimplified because it's React, right? Notice, what do you notice here? What I notice is that everything has scaled except the UI. Like, the UI has just been this thing sitting there. This is why we need Concurrent React, right? Because the backend and the frontend both need to handle the growth of companies, the growth of complexity, the growth of data volume. So Concurrent React solves the problem of CPU-bound work by being able to pause rendering and pick it up asynchronously, concurrently, some would say, and also solves the problem of network stuff, so data fetching specifically. In this talk, we will cover not the CPU stuff, but instead we will cover data fetching. We'll talk about data with Concurrent React. This is, I think, probably my last slide in English. In fact, you know what? Let's do this. I don't know the Hindi word for data, if this is wrong. It's literally just data in Hindi. React mein data lane ke 3 tarike. I'm Indian, you don't have to do that. But thank you, I appreciate it. I want to talk about 3 ways to fetch data in React. How do we do this? There's multiple ways. So, typically in React apps, probably the most common pattern to data fetch, which is not a problem for small use cases, is, number one, you render your component appears on the screen, then you fetch, right? If you've written this, you've probably written this code. You have a React component, and you're like const data, set data, use state, null. And then use effect, you fetch dot then, set data. And you will never do dot catch, dot then, set error. You know, forget the error handling. That's most of us, if we're being honest. Come on, it's about hacks. Yeah, you're laughing because he caught me. Render then fetch, it's really common. But there's another use case for fetch then render. How many of you use this in production apps? Like no one, like 3, 4 people out of this whole room. This is a bit of an edge use case, I would say, and it's maybe used more in server rendering. But the idea here is you don't fetch inside your component body, you fetch in module scope. So as soon as you import something, you start fetching there, and then when that promise resolves, you set state inside the component. It's a rare pattern. It does provide some benefits. For example, if you start fetching on the server, maybe the networking is better and so on. But in cases where it matters, it does help. But generally, it's just harder to reason about. And since so many people have not seen this pattern, maybe teaching it can be hard. The premier way to work with this in React 18 with concurrent features is render as you fetch. It's cool. So React will render your component tree. You have, let's use the example of a Facebook post, what's on your mind, right? You have this, or timeline even, better. So how it will work is it will fetch the timeline elements and then come to some place where it needs to lazy load a component or do some data fetching. It can pause rendering, fetch something from the network, and continue, like in that spot. That is, you render and then pause and fetch, so you render as you fetch. It's excellent for performance and usability and UX. This is pretty much my last slide, and the rest we're just going to code some stuff. I want to show you these examples in practice, like with a React app. And so let's just write some code. Let's exit out of this. I'm going to quit. You know what? I don't want to click this. If I open Signal, you see my personal texts. I should have quit that. Can I quit it? Anyway. What we have localhost 3000, which is not running. So let's start by running that. We'll do yarn parcel source index.html. So I'm just going to start a dev server, and it should be 1234 is the port. So what we have is a jokes app. Okay. Anyone know Shruti Kapoor, this developer? Wow, fan club, awesome. Yeah, Shruti used to work at PayPal and really genius React developer. Can recommend. She has a great talk also on Concurrent React. She also has a GitHub repo of developer jokes. And I want to make how many of you know this repo? So many of you are nodding. Wow, okay, yeah. So what I want to do is build a UI around this and show these jokes, okay? So how do we do that? And I want to make this fetching thing show you Concurrent React. So I took Shruti's jokes, and I put them in a database on my favorite database platform's data. And so this is what it looks like. So we have a blank screen. Let's reload, and hopefully the internet works. Okay, so we have this collection of databases, and my dev jokes is here, right? So I'll click this, and these are all of the jokes in the database. There's a lot of them, and I can just scroll and scroll and scroll, but I really just want to query this in my React app, and I want to render then fetch, fetch then render, and then render. I want to fetch these jokes specifically, okay? So what I'm going to do is I'll get a code snippet here. JavaScript fetch is what I want. And I'll include a temporary authentication thing just so I can fetch quickly. And my goal is to get jokes here. So I will just, what will I do? I will render then fetch. So if I open my terminal, and let's do VS Code, just open the editor, and let's just write some code. So I will quickly run the dev server again. And this is the component, by the way. So we have an app, and what you can see is, in our React component, let me minimize this, we have h1, the jokes, that's this thing. We have an input for search, that's this thing. And we have a paragraph, and then a jokes component. And the jokes is a thing that maps over jokes and renders a joke, right? This should be familiar to you if you've used React. What I want to do is fetch this. Why is this empty? This is empty because set jokes is never called. It's just the initial value, which is an empty array. It's just like nothing. So let's render. So this component is rendering, but it's not fetching. So we'll do that. We'll do render then fetch. We'll use effect. Remember, all of this is hacks. This is not supposed to be good code. And we'll paste that code snippet. And instead of console logging the response, we'll set jokes to response.records. And I think this should be enough. Let's save that. Let's reload. And I think that should be good. Am I making a network request? That's the other thing. It's in fetch. I'm not making a network request. Why? Am I? I am. OK, great. I just needed to hard reload. It was cache. You know parcel? Anyone use parcel? Yeah, good. Don't use it. The cache will kill you. OK, anyway. Sorry. I feel bad for doing that on stage. But Vite. Vite is great. I should have used Vite. Anyway, OK, so these are the jokes. I'm querying the database. They're working. It's great. I don't have search, though, because, well, you know, I can type like wife. There's a good joke about that. But I don't find it. So what I can do is run this effect every time search changes, right? And then in query params, instead of just page, I could do something like, why is this? Let's make this clean. We'll do JSON.stringify. Yeah, let's do it like this. And we'll say, you know, if I, All right, we'll say if I have search, then include a search. Otherwise, give me the results without a search. And here I can say, you know, filter where joke contains search. It's just a substring match, nothing fancy. So now, now it works. So married life of a developer, wife, write 100%. That's so this kind of works, right? So profan console. So okay, so we have this app, and we are now doing render then fetch. The React component renders, we fetch, and then the data appears. Okay. In fact, what we can do is we can throttle this network request a bit to make it look slow, because unfortunately Zeta is way too fast. Anyway, 1 second. And so now what we'll see is ugly UX. So if I reload this, you see that? That's nasty. It's called FAUC, flash of unstyled content. Blech. You ever load a website and like stuff appears and layout shift and it moves? Yuck. We can do better. In fact, this is why React exists. Because like, let's make this even worse. Let's do like 1.6 seconds, right? Look at that, nasty. So how can we improve this? Will fetch then render help? Probably not, but let's try, just to be on the same page. So let's take this render then fetch and move it to fetch then render. What we do is we just copy everything before the set joke. So we copy this actual fetch call here, and we move it out into module scope. So this is the React component that's actually rendering like jokes. When we import this, let's fetch then, okay? So let's do something like, we'll fetch here before anything, before the function is defined. We'll say const promise is this. We'll fetch that, serialize it to JSON. We can also copy our options out of here, why not? But notice we actually lose something when we do this. We lose search because search is a prop. We can use like xstate or some global state management, import search from there, whatever. But that's not the point of this demo, so I'm happy to just kind of get rid of search. So we have options. We're fetching in module scope. And what we'll do is when the promise resolves, we'll just do that, right? So we're fetching early, super early. And then inside the component, whenever, we'll just set state. Does that make sense? That's fetch, then render. So let's save this. I told you it was going to be hacked. So let's save this, reload. Yeah, OK, we still have the FAUC. We still have the flash of unstyled content. But generally, as a best practice, right, it's a good idea to fetch as early as you can. Because you want that data to be ready when people are around. And also, if you're doing server-side rendering, this is actually pretty viable. The problem, though, the big danger, is if you fetch in module scope on the server side, and you have different users doing different stateful things on the same server, you can understand how things get out of sync. And this is a huge pitfall. So you'll want to be careful with this. That is fetch, then render. Just to recap the code, we do fetch here in module scope. We assign the promise to something. And then inside the React component, whenever that resolves, we go about setting state. OK. Let's spend some time talking about render as you fetch, concurrent React. Before I do this, I need to give you a disclaimer. I already gave you a warning earlier. You remember what that was? This is hacks. Do not use it in production. But so I believe that when you understand the reason why things are the way they are, you become more fluent in a tool. You understand React more. And when you understand React more, you can write code that works with React more as opposed to against React. Okay, that's the goal here. So let's look at render as you fetch. But before we do that, we need to look in the React blog. And what does it say? In React 18, you can start using suspense for data fetching in opinionated frameworks like Relay, Next.js, Hydrogen, or Remix. Ad hoc data fetching with suspense is technically possible, but not recommended as a general strategy. So I read this, right, and I'm like, okay, I shouldn't, but it's technically possible, though. Let's try. This is what the libraries do under the hood, but they handle more edge cases for you, which is why it is a good idea to use them. But let's understand what they do under the hood for learning and hacks. So what I want to do is render as I fetch. And that will also then give me the ability to pause rendering wherever I want and give me more fine-grained control of my user interface. Okay? So let's do that. Let's open the editor. The fundamental primitive of a React suspender that enables render as you fetch is called a resource. It's not called a resource, but this was all in the earlier demos and discussions. So what we need is a factory. We need const create resource. And what is this going to do? Is that text big enough, by the way? Can you read it? Yes? Okay, cool. I love it. It's India, so everyone's like, it's the, you know. So we'll create a resource. What is a resource? A resource is something that does something asynchronously and then returns an object that React can read and understand, okay? So wow, GitHub Copilot writing code for me. That's cool. We'll pretend that didn't happen. We'll write it ourselves. Or I can just press tab. Okay, done. No, we're not doing that. So the resource gets as an argument something that returns a promise. Okay, so as an argument, we'll say thing that returns a promise. And that's the type. It returns a promise of anything for now. This should be a generic type, but these are hacks for like the third time. So we'll use a lot of any in TypeScript, which, by the way, I don't even need. If I wanted real hacks, I wouldn't even use TypeScript. Anyway, so now what does this thing do? First, we say const promise, and we just call the function that returns a promise. Boom. Done. Okay? Now, we need some state variables. We'll do status. Status is a good one. And it's pending by default. It's loading because it's like, this hasn't resolved, so it's loading. We'll also let result be null in the beginning, but when the promise resolves, we'll just set this to whatever the value is, okay? Now we need to return something to React that React knows how to work with. And then we just hand it off to React. What do? We first do promise.then. And when the promise resolves, we get something, and we'll do the following. We'll do status equals done, result equals something, right? This is kind of what you do. We're just setting these things here. Let's be nice people and also catch some error, and we'll just set the result to that, and we'll say status is error, okay? Great. So now we're setting our internal state for our suspender. What do? Let's now return to React something it can work with. So we'll go here, and we'll return an object that has a read function. And this is going to do some stuff, exactly this. I prefer switch case, to be honest, for this because it's nice. So we look at the status of this thing, okay? And in case the status is done, right, we just return the result. Now, in case the status is error, we throw the result. And lastly, in case it's pending, we need some way to signal to React, hey, wait, pause rendering. We're not done yet. In case the status is pending, we actually throw the promise, right? In JavaScript, it doesn't care. You can throw whatever you want. You can throw your laptop. Just take it in, you know? I can throw a pack of stickers. Who wants stickers? I have stickers. You want? There. So, see? JavaScript. You can throw anything. So this is how it works. When you throw a promise, React, your suspense component, anywhere in the deeply nested tree will be able to catch it and just pause rendering at that point. That is why. suspense in React works exactly like try-catch. Have you ever thought about this? Like, try-catch, no matter how deep your code is, no matter how deep your call stack is, wherever you are, you can catch anything thrown from anywhere. Suspense is the same. So this is our suspender now. We do this, and it's great. So now we just need to create a resource. Resources are usually created as early as possible, so module scope. They're not created inside your React component because your React component re-renders a lot. And so you don't want to recreate your resource like a ton of times. You'll end up with some type of infinite request loop if you do that. So just to be safe, we'll do const, let's say joke resource, right? And we'll just say create resource of what though? We need something that returns a promise. Thankfully, we have this thing over here. So we'll just copy all of this. I might keep the options global and just copy the promise thing. And in create resource, we need to give it a function that returns a promise. So we'll start with function. And we can just actually just return here. Return, done. So this returns a promise of JSON. In fact, we can do a .then and return the actual records as well. Why not? OK, so we have this, and it looks good. It returns a promise. Let's use this thing. So what we want is, promise is no longer, we don't need use state. We don't need use effects. All of this goes away. And instead of jokes, which is no longer defined, we can do joke resource.read. We get back the array. It tells me it's null or undefined. Remember how this is all about hacks? So yeah, it's better. Wait for Brandon's talk after lunch. He's going to talk such nasty things about me. Anyway, it's hacks. This is how we learn. As if you never like console logged to just see your errors. Come on, judging me, everybody. He's taking a picture. He's like, anyway, okay, so he'll put me in his slide. Anyway, look, it works. So if I reload, it's instant. And you'll notice we still have some flash of unstyled content, but it's in front of the search. But we still see the jokes UI. What's with that? That doesn't go away. So our flash of unstyled content is now localized somehow. How can this be? Let's take a look at what's happening under the hood. Let's go here and go to our app, right? And you'll notice we have no suspense components anywhere at all. So let's start with that. Let's go here, and just like at the root of our React app, we'll just do like suspense. It's telling me it's undefined. Is it? Oh no, I import it. Cool. So now it's doing what it should. But what if I want to keep even this stuff and only make this go away when I reload the page, right? I should be able to do that by adding suspense around the joke component just here. So if I add a suspense component here, I should be able to, if I reload, look at that. So because what React is doing is it's rendering all of this, pausing to fetch jokes, and then filling the hole later. And I can even do a fallback. I can say fallback, sorry, wrong component. Fallback is wait, jokes are coming. You tell I have some Tamil in my, anyway, okay, so, oof, that's not good. Why did that happen? That happened because my temporary API key expired. I will get a new one. There we go, okay. And I will just, let me just reload this actually, get a code snippet, get a new token, copy my options. You see nothing. The API keys live forever. Actually, they shouldn't, because by design, we want them to expire. Anyhow, paste that. We don't need the fetch, we just need the options. And the new API key. All right, let's try. So we're back, and it says, wait, jokes are coming. Now you can imagine if this request takes really long, right? Let's go to our jokes component and actually throttle this, like super long. So let's return throttle, and we'll throttle this fetch for like 2 seconds, okay? So now we just sit there and wait for 2 seconds, and we just get this fallback. The cool thing about this is I can selectively choose what parts of my UI I want to hide and what I want to show, because suspense is able to pause rendering where I tell it, at the suspense boundary it's called. How I can do that is, if we go to VS Code, this suspense thing, if I take it just up the tree to hide the paragraph, okay? And if I save now and reload, notice the paragraph is gone, right? So I can selectively choose, do I want to present things all at once? Or do I want to present just some stuff before. I could even hide, look, question for you, true or false. Does it make sense to show a search field while I have no data? You're saying no, some of you are saying yes. It's a divisive question. Some will say yes because maybe I want to pre-filter. Right? Maybe I just want my job already. Maybe I come from a request query params. Some say yes. Some say no because it doesn't make sense because there's nothing to search on. I agree. But if we wanted to hide it, we can. So we just move the suspense higher up. And now, you know, and we could even hide literally everything and present stuff all at once. We have this control with render as you fetch because it's literally rendering, pausing, fetching, continuing. Okay? This does present a bit of a UX problem though if we have search. So notice the search doesn't work, right? So let's go implement that. This isn't really that hard, thankfully. So what we can do is we can say our read method accepts an argument, search, which is a string. Okay? Actually, wrong place. We can do it here. So create resource. We give it a thing that returns a promise, but we can also give it another argument, search, as a string. And now thanks to TypeScript, it's just telling me everything's wrong where I'm using it. So what I want to do is where I create resource, let's make search optional even. So let's do this. Ooh, our thing that returns a promise could even, okay. Let's do it like this. We have search. This is the beauty of JavaScript. You can put whatever you want anywhere. So this is an optional string. And when we fetch, I'm trying to think where's the best, anyone have a suggestion where's the best place to put this? We're just hacking right now. Maybe we can put it in create resource somewhere here. Let's do it like this. So we have this function, search, but this is never called. I don't know, I'm confused. I got it. Let's put it in read. That's probably the best place. So let's say this gets search as an optional string. Let's leave it empty here, but you know, search. Why are you complaining? Oh, search is not defined? But search is defined. Wait, search, string. Don't you just love hacks? Okay. There, this is perfect. We can give thing that returns a promise also a search string. Perfect, this is fine. And so now we create the resource, and I think we can give it search here, right? This function accepts search. TypeScript, I would be nowhere without TypeScript. Cool, and so now we can include in the options, which is global, some query params. So we'll do ... options, and then what is it? Body, right? So we'll do body, instead of just page this, we'll say if we have a search, JSON.stringify, and instead of doing a string, we'll do this. Otherwise, we'll just keep it like this. And in the search ternary branch, we'll add search, it's filter, joke, contains search. Perfect. Good. This kind of works. So now we can create this resource here with this function. But now if we want to respond to this prop, how do we do it? We keep the resource in state. So we'll say joke R for joke resource, set joke R. It's not joker. And we use state, and we'll keep the initial resource as joke resource, just like that. Joke resource. But joke resource is not a function. What? Joke resource, like that. Perfect. We get back a resource. Now, when search changes, we want to recompute that. So we'll do search when it changes. And we'll set joke R to, remember how this is a hack? So we should be dry, as in don't repeat yourself. But, you know, just boom. It's the same resource, but with search. And so we're just resetting the resource here, okay? I don't know if this is going to work, to be completely honest with you. It maybe won't. But we'll cross that bridge when we come to it. Thing that returns a promise is not a function. Excellent. Because it's true. Because the signature changed. So create resource gets search first, which is here. I have questions about my hack right now, but we'll keep going. Look, this doesn't make any sense. You see this? What in the world am I doing? Gosh. Okay, wait, the other jokes are coming. They're probably, oh, they still come. Wow. Wife, does that work? Yeah, that's what I thought. How do I improve this? That's the question. Anyone have any ideas? Create resource. Do I do something like this? What I want is oh, I got it. Someone's saying something. What are you saying? Nothing? Okay. Well, I have a few minutes, so I'm literally just going to debug here. And you're welcome to shout out suggestions. But I won't spend too long because I don't want to bore you. I think this signature is wrong, first of all, right? This does get a thing that returns a promise, and so on. Why are you complaining? Search is undefined. But we can make it optional. Perfect. Create resource can be this. This is great. This function accepts search, and it uses search. This is perfect. I think this should work. Lastly, in our use effect, should be good. Okay. Does it work? Wife? No? What? Oh, okay, yeah, oh yeah, thanks. I give it up for that guy. I'm not using my joke R from state. Fantastic. Show me. Okay. Oh, it works. Give it one more time. This guy. I was using it from state. Okay, so now I have this UI, but look, it's kind of lame because on every keystroke, hey. What about, okay. Wait. So if I want to type wife, are yaar, like, what is, so I have to like type one key and then wait. It's the worst UX ever. Yes? No, you like it? We need more talks about UX. Anyway, so this is clearly not good, and this is kind of against the problem that suspense for data fetching solves, right? I don't like that. I don't like hiding that. Now we can obviously solve this by just moving the suspense boundary under the input, but I still don't like this very much because it's still a bit jumpy. What if there was another way? So part of Concurrent React is the ability to signal to React what updates are high priority and what updates are low priority. Okay? There's an excellent talk later today by Mateusz about the details of this. We won't spend time there because we've already spent quite a bit of time exploring here. But what I want to show you is how you can signal to React, hey, this update I'm trying to make is a lower priority update. Prioritize that thing. In this context, what should be the higher priority update? Text input, exactly. Exactly. When you type, it has to update. You have to see the text input update. Because if you imagine you press a key and then like 2 seconds until the text update changes. So what we'll do is we'll tell React that this wait da jokes are coming, this refetching. We'll say this is a low priority update. And we can do that using a hook called use transition. This is new in React 18. And this is how we use it. So we say const, we get is transitioning and start transition. We get a tuple, and we get a tuple from this use transition hook. And instead of just setting the state directly, we start a transition to set the state. And this will tell React, okay, whatever's about to happen in here can take as long as you need, but there's higher priority stuff. So we'll wrap this in start transition like this, save, and now wait da jokes are coming, but as I type, nothing jumps. Even with a 2-second delay, nothing jumps. It will go, it will refetch, and it will update whenever. But notice, as I type text, this is what I want to show you. As I type text, I can type anything I want. I can type, and my UI is responsive. In fact, if we now remove the throttle of 2 seconds and make it like 600 or 500 milliseconds, right? Now if we reload this, what we'll see is, wait da jokes are coming, and after like about half a second, we'll get jokes. And this should be way faster. So it doesn't interrupt the UI. Does that make sense? We could even hide now. We could put the suspense boundary and hide the text input. And this will not interrupt anything because it's a lower priority update. So we'll say, look at this. It's just easily updating. You see that? It's phenomenal. Let's go and remove that throttle as well. OK, we did. What if we remove the throttle completely? Just go away entirely. Oh, did I bring myself into callback hell here? Do I? Curly? No. Something else? Oh, I returned here. What? So return. Okay. So now, we're not throttled, but it's still slow. Isn't that weird? The first one is slow because there's two. But this is, yeah, this is much faster. So there we go. So that's just a little deep dive. So this is how you understand why they say use a library. They say use a library because what we just did was understand what libraries do. Libraries like React Query, like Remix, like Hydrate, Hygen, whatever, sorry. These libraries build suspenders like that under the hood. They have a throw promise. They have the things that we did. They just do them really, really, really well. They handle edge cases that we don't handle. And this is why the React team says it's technically possible to do this, but it's going to cost you a lot of time and money. Instead, use a library. Now that we understand the underlying stuff, though, we understand how we can work with these libraries, right, to create better React apps, to create React in a more fluent way. Okay? Let's return to the presentation. So let's recap, right? I'm just getting rid of English completely now. Whatever. Humne kya sikha? What do we learn? We learned the level under libraries. We learned how you build a suspender. We learned when you use Concurrent React. We learned how Suspense can tell React when to pause rendering, when to fetch, so on and so forth. In summary, we learned how we can fluently work with React Suspense. The next question, how many people don't understand Hindi here? Am I just doing a bad? Yes! Good. It's all the white people. I'm joking. This means how do we use this stuff? As I said, we use it safely. We use hacking for learning. We do not use hacking, and I don't mean like stealing passwords hacking. That's not what I mean, like building nonsense, right? We do that for learning, but not in production. And in production, what do? We read the docs, and we rely on libraries and the React core team, okay? That's really important. With that, React India 2022, shukriya.
Thank you, Tejas, for that electrifying talk. Yeah. Okay, how did you like that talk? Whoa, whoa. I loved it. I loved it. I never get this much applause, whatever I say. Okay. So what I'm going to do is, like, how many of you have tweeted today about React India? How many of you have tweeted more than 5 tweets? Okay, so you know you need to do better in that department. How many of you have written code today? Yesterday? Okay. And how many of you wrote tests yesterday? Oh, not at all. I hope your managers are not seeing this. Cool. But worry not. I have the best person here who would not only tell you that, hey, how to write tests, but how to do it in an enjoyable manner so that it doesn't slow you down. So everyone, please put your hands together for the fantastic Daniel Afonso.
React India. React India.
applause for MC. Yeah, amazing. So this is going to be a difficult talk to follow up, but from Tejas, I mean. So it was a great job that he did, but yeah, let's learn about testing. So how many of you have used the React testing library? Okay, cool. So my talk will pretty much touch a bit on that focus, but before anything else, let me introduce myself. My name is Daniel Afonso. I'm working as a developer advocate at OLX Group. I'm an Auth0 ambassador, and I'm an AGED instructor. You can find me on Twitter and pretty much any social network at the handle Daniel JC Afonso. And yeah, in the main ecosystem and stuff that I've been interested in the last couple of years, it's been React, JavaScript, and the testing library. So let's start about your agenda for this talk, what it is about. So this talk tells a story about the migration to React hooks that show us that our tests were not being done the way we wanted them to do it. In this process, we got to know the React testing library and did a migration from Enzyme to the React testing library. Yeah, so after this, I'll be pretty much showing you a guide of everything that, well, in my perspective, you need for using the React testing library, and some of the common issues that I found in the last couple of years of using it. So let's start with some context. We were in mid-2019, and we had a fairly new React Redux project. The project was around 4 months at that time, and hooks came around. And, well, at our team we said, let's migrate to React hooks. Let's just do it. They are feeling stable. We have a bunch of reasons to use them, like there was more code readability. Everything since the introduction of use effects made us easier to write and group the logic together. After that, we have much more code reusability because with the introduction of hooks, now we have a stateful way to share state. And at a team I was working at the time, we would be soon onboarding some new junior developers. So we wanted their experience to be much more easier about learning React. And from our perspective, through hooks, we took a lot of complexity out of it. So yeah, we started working. You can see us here furiously typing and migrating our code base to starting using hooks. Well, the migration was successful, at least from our perspective. Everything seemed to be working okay. We had much less lines of code than previously. And yeah, everything was cool. Until someone remembered, hey, have you checked our tests? And yeah, this was what happened. Almost half of the lines of the tests that we had were failing. So you could probably imagine that this was our reaction at the time. We were left to wonder, what's happening? This is not working. The tests are not working, but the implementation changed, okay, but the way that the user interacts with the stuff, it's the same. Everything seems to be the same. So what happened to our tests? And we did some research, and we came to the conclusion that there was only one guilty party in here. And that guilty party was testing implementation details. Now you might wonder, what are implementation details? Well, as someone that's around this conference somewhere, Kenzie Dot said, implementation details are the things which users of your code will not typically use, see, or even know about. And putting this in perspective, implementation details can be things like, well, the component state, the props that we were sending to our components. And yeah, our tests were filled with these things. Our tests were tied to our state. We were not focusing on the user, to be honest. So yeah, from this process, we started to figure out a new way to handle this, to make it better, a better experience for development. And it was pretty clear to us, very straightforward, that we had to get out of Enzyme and start using the React testing library. Now, don't get me wrong, Enzyme is super great. It's a great tool, it's super powerful. The thing is, if you don't use it in the right way, to be honest, it might give you some issues. So here are a couple of examples of things that I personally don't like by using Enzyme. First things first is shallow rendering. So for those of you who don't know, shallow rendering are the way that we can render our tests, but only the shallow part. What I mean by this is, if our component doesn't have any children, that does have children, they won't be rendered. And by doing this, by rendering only the shallow part of our component, we are not testing our stuff the same way that our user interacts with our components. The second thing is find. So find it's the way that Enzyme offers you to query the DOM for stuff. The thing is, it's super great, but it also allows you to test and search for stuff using your component name. Well, a component name is an implementation detail, because if this changes, then your test will break because, well, it's not how the user works for stuff. The user doesn't care what the component name is. And then, probably the biggest implementation detail, the component state. Our tests at that time were deeply, deeply tied to state. This is a simple example, but this is an experience of stuff we had. Our tests were tied to the component state. We were checking and asserting if the component state were X or Y. And putting this in perspective, the user, once again, doesn't care what the component state is. The user cares if he clicks on a button, something pops up. Or if something, it doesn't care about the state. So, yeah, we did our migration, we got out of Enzyme, and we started using React Testing Library from the Testing Library family. And with it comes its main guideline, which is the more your tests resemble the way your software is used, the more confidence they can give you. So, once again, this is a quote by Ken Sidotz, who actually is the creator of the testing library. So, thanks to him for making our lives much easier by creating this. So, strap on, because now we're going to get pretty much a guide of everything that you need to write your tests. So this might seem like a simple example, and it's very simple, but this is how a test can be normally structured. First things first, we have we destructure the stuff that we need, and we describe our test. Then we do a couple of things. First things first, we render the component that we want to use. In this scenario, we are using the render function and passing it my component. Then, once we render it, we need to find a way to query the DOM for stuff. So what we do is we destructure our query. In this scenario, we are getting a query called getBy variant with the label change. Then we do our query. In this scenario, we are trying to find a label that has the text a label. And afterwards, we do some action. We do an event firing. We are firing a change event. In this scenario, we are firing an event to change the text of our input. Then we do our assertion. This is pretty much following the pattern of the AAA. So arrange, act, and assert. So let's get a bit more deep into this type of things. So let's start by render. Render is a function that will pick up your component, render it into a container, and this container will afterwards be appended to a document body. Besides doing this, this function also gives you a couple of utilities. It gives you the container where your component was rendered. It gives you a debug function that you can use to check the state of how your component looks, and gives you functions like unmount to trigger unmount events and re-render to trigger re-render events. And yeah, this is pretty much the first step that you're probably going to do when writing a test, which is rendering your component. Then often afterwards, we need to do some querying. We need to search for stuff on the DOM. So queries work in this way in the React testing library. All queries have a variant, and then afterwards they are appended by something. So there are three types of variants in the testing library ecosystem. We have the query by, the get by, and the find by. So the query by, it's a query that will find the first matching node that you're looking for, but if it doesn't find it, it will return null. So you look for something, if it doesn't exist, no problem, it returns null. Then we have the get by query, which works much like the query by, with the exception if it doesn't find the first matching node you're looking, it will throw an error. So just to recap, query by will return null, get by will throw an error when it doesn't find what you're looking for. And all these queries are synchronous, so you don't need to wait for them. But if for some reason you need to wait for something that might pop up, you can use a find by variant. So this find by variant will return a promise that will resolve when it finds what you're looking for. If it doesn't, then it will reject it. So, like I said, all these variants will only return you the first matching node. If for some reason you want to get an array of all the things you're looking for, then you can use an all by variant. So the process will be query all by, get all by, and find all by. This will pretty much return you an array with all the stuff that you're looking for. So these are the variants, but these variants are appended with something that belong to the query family. So Now, one question that I often hear is, okay, but Daniel, what query should I use? What's the variant I should pick up? How should I query pretty much? So my answer and the recommended approach is you should always focus on queries that mostly reflect the user experience. So here we have the query families. So we have the queries that are accessible to everyone, which are pretty much the queries that mostly reflect the experience of users. Then we have semantic queries, test ID queries, which start to reflect some implementation details, but it's a controlled one. And then our escape hatch, which are manual queries, and you should probably never use them, but I'll show them either way so you're aware. So let's start by the queries accessible to everyone. Like I said, these are the queries that mostly reflect the experience of visual, mouse, and assistive technology users. So how would you use this query? Pretty much you get your variant and then you append it either by label text, by placeholder test, by role, by display value, or by text. This will pretty much find the stuff you're looking for following this criteria. And then we have the semantic queries, which should be your second option. So these are queries that make use of HTML5 and area compliance selectors, but in certain cases don't fully respect the accessibility type of things. So the queries that belong to this family are the by alt text and the by title. So let's look at some examples. Here we have an example of a query that's accessible to everyone. In this scenario, we have a label and we have an input. Our input is assigned to our label by using the area labeled by. And how would we go to get this input from querying? So first things first, we need to render our component. After your component is rendered, what you do is you destructure your query. So in this scenario, we are getting a get by variant, which will return the first node, or throw error if it doesn't find it, and the label text, which belongs to the queries accessible to everyone. So how do you do it? You pretty much say, I want to get by label text the username. So this will look into your DOM. It will find where the username is. It will find, is this label assigned to anything? And it will see, okay, it's assigned to our input through the area labeled by attribute. And yeah, this is pretty much an example of how to using a query accessible to everyone. So speaking of semantic queries, here we have an example of using the title attribute. In this scenario, we have a span which has the title delete. And the process is very similar. We render our component, we get our variant and family. In this scenario, get by title, and we call our query. In this scenario, the query will pick up on the DOM attribute which has the attribute title. In this scenario, it will find this span and return it so you can do anything with it. Like I said, semantic queries don't fully respect accessibility patterns. For instance, as the title attribute is not consistently read in screen readers. So this is why you should only pick up these queries as a second option. Well, if for some reason none of these queries work, then you can resort to these ones. But as a last resort, I guess. So the first one is the test IDs. Pretty much what this happens is you attribute the test ID to your component and you can query by it. So you can query or get find by test ID. This is an implementation detail, but it's a controlled one. So it makes sure that, well, in scenarios that you have to focus on an implementation detail, at least you have something that you can control. If for some reason, and this, I only had to use this like one time in over 4 years of using the testing library, none of these queries work, then you can follow up with a manual query. This is actually not a query belonging to the testing library. It's actually the query selector DOM API. So looking at examples, the process is very simple. Again, we have our div with our data test ID attributed. Now you might ask, okay, but what scenarios should we use test IDs? Well, let's imagine that the content of this div is always changing and you have no way to find it. Well, in this scenario, you can assign it a test ID. The process is very simple. You render a component, you destructure the query, get by test ID, and you query the DOM for it. And yeah, this is pretty much the process like other queries. For manual queries, it doesn't work quite the same, because like I said, this is not a query for the React testing library. What you have to do in this scenario is you have to destructure the container that you get from the render. Remember, I told you that the component, when it renders on a container. You have to get access to that container and pretty much just call the query selector API. So in this scenario, we call the container.querySelector and we pass the selector of the stuff we are looking for. Like I said, this is an escape hatch, so use it carefully because once again, this teaches or focuses on on an implementation details pattern, and this is not what the testing library encourages you to do. If for some reason none of these queries work, you can also try and create your own queries. I'm not going to review all this code because we'll stay here until tomorrow. But pretty much what we want to do in here is create your own queries that fit your needs. So in this scenario, we have a query for testing using I18 translations. So you can do this by using the build queries helper. It's important that if you decide to follow this approach and build your own queries, you do so in a way that focuses, once again, on the user implementation perspective and not on the implementation details. So yeah, we've seen rendering, we've seen querying. Now we can start by going into actions and performing stuff. So there are two ways of firing events in the testing library ecosystem. One is by using the fire event, which actually comes with the testing library by itself, or by using a parallel or a library that you can install as well, called the user event library. So what's the difference, you might ask? Fire event will do only one thing, which is fire a single event. Now, once again, that's not the experience of how the user interacts with your components. What the user does, for instance, is when clicking on a button, he puts his mouse over the button, he clicks it, and probably will do something else. So there are a couple events that are associated with this. So mouse over, mouse down, all these events are things that the user focuses on. So user event library was created so that you can focus and do exactly the same events that the user does when interacting with a component. The process is pretty much the same for both of them. You either, for fire event, you call fire event, you say the event that you want to do, and you pass it the node where you want to do that event. In this scenario, we're firing a click on a button which has the name save associated to it. With the user library, the process is the same. You click, you specify where you want to click. One thing that it's important to mention, and some of you might wonder where's there an await here. So since the latest release of the user event library, all the events started being asynchronous. So before they were not. So if you are out on the internet and starting seeing examples with await or without await, it's important to check what's the version of the user event library you're using. So yeah, we know how to fire events, you know how to render, you know how to query, pretty much we have all the things that you might need. But let's picture a scenario that you need to wait for something. For instance, as you click on a button and you need to wait for a model, something to show up, or a progress bar. To do this, we can use the wait for utilities. This is pretty much a function that's asynchronous, so you have to wait for it. And pretty much what it does is it will await for whatever it's inside of it. So in this scenario, we are passing it an assertion. And pretty much what it will do is it will loop the code inside until this assertion passes. This has a defined time, so if it doesn't pass over a certain time, it will throw an error. In for scenario, you want to wait for something to disappear from the DOM, you can use wait for element to be removed, which can work the same way as wait for, but it's more useful because all you have to do is pass it your component, and it pretty much will wait until that component disappears from the DOM. And yeah, we are pretty much done. Let's just review some helpers that can help you in your day-to-day. The first one is within. So imagine for some reason you want to perform a query only inside of a specific component that you queried before. So you might have a div and you want to query only inside of that div. Within is pretty much a function that you can use, pass it the component you want to perform your query inside, and then perform your query. Here we can see that we are getting our input nodes by using the get by test ID query. Doing within that input node, I want to query to get by text some text. And screen. Screen is super helpful. Why? Because it gives you the ability and takes the need to destructure queries from render. So screen pretty much has an attachment to the container. So everything that you can use with screen, it's like you would be destructuring from render. So instead of doing that, as you can see in the example below, we render a component and we say screen.getByTestID, and the query will be pretty much the same process. The final helper, it's debug. So debug just allows you to see the current aspect of your component. You can destructure it from render. You can use it with screen. If you don't pass any parameters to it, it will show the entire state of your of your DOM. If you pass it a component or an array of components, it will show the current state, the current way it works of those components. So, yeah, I've been using the testing library for around four years by now. I'm super happy with it. Like the tests are right, can survive any, well, non-feature altering refactor because, well, the user experience becomes the same, continues to be the same, and yeah, it's super, super great. I really like it. So I like to thank Ken for creating it. Before wrapping up this talk, there's just a couple of things that I want to show you, which are mistakes I've seen around these years. So let's start with the first one, using ACT. So for those of you who don't know, when performing interactions with the user interface, there are things that are called units of interaction with the user interface. These can be things like rendering a component, firing an event, or clicking on something. And pretty much ACT is an util that React created so that it can make sure that all your actions are deployed to the DOM before you proceed. So putting that in perspective, it might make sense. Okay, let's wrap or render with ACT. Let's wrap or firing events with ACT. The thing is, we don't need it. Why? Because the React testing library automatically wraps everything that's going to be doing a unit of interaction with the UI with ACT by itself. Using getBy, we expect not to be in a document. So, like I said, getBy is a query that will throw an error when it doesn't find what it's looking for. And expect not to be in a document is pretty much an assertion that JS DOM exports that will make sure that the thing you're looking for doesn't exist on the DOM. So, if you're trying to query for something, that will throw an error that when it doesn't exist, so this test will always fail. So, in this scenario, what you should use, it's a query by variant, because if it doesn't find what it's looking for, it will return null. Another error, using wait with fire event or non-asynchronous queries. So I've seen some patterns like this, like waiting for a getBy variant to be found, waiting for a firing event to be triggered. Thing is, we don't need these types of things because all these types of things are synchronous. So instead, just remove the wait and only use the wait if you're using a find by variant for the queries or an asynchronous util. Using a wait with wait for with an empty callback inside. So it's pretty much this thing that we can see in here. Now, you might be wondering, why would I wait for something that's just an empty callback? Well, I've seen this pattern to deal with an issue that I'll show you right after this section. But it's pretty much what this will do, it will wait for the next tick of your test. And once it's finished, then it will proceed to your assertion. The thing is, while this might work sometimes, it doesn't guarantee it to you that when you get to the part of expect, your test will pass. So instead, what you should do, it's pass your assertion to inside of wait for, and it will loop the assertion until it evaluates to true, and the test passes. Using cleanup. So cleanup is pretty much a function that will clean up your DOM, your container, after your test ends, or whenever you want it. The thing is, okay, it might make sense. So I want to, after each my test, I want to run cleanup just to make sure everything is clean and okay. Well, the thing is, if we are using a framework that supports the after each global, like Jest, you don't need to do this because the React testing library will run this automatically for you. So thanks for that. Using a wait for with synchronous queries. So I've seen this pattern quite a long time. So pretty much what people do here is pass the getBy variant inside of a wait for. Well, it's not necessary because we have a find by variant that you can await, and you don't need to make your code more unreadable than already it is in certain cases. Using side effects inside of wait for. So this is something that I've seen people do, like, well, I click on a button, then I try to make an assertion, and for some reason the assertion didn't pass. Let's just put my clicking inside of the assertion. Well, it's not necessary, and this might be even more bad for you in this scenario, because pretty much, like I said, wait for will loop the code inside of it. So this does not guarantee it that, first things first, your assertion is going to pass, and it might also do more harm because you're triggering the user event click in this scenario, your side effect, every time it loops. So instead, what you should do, it's, oops, I came up. So what you should do, it's pass your user event and your action before your wait for, and then do your assertion inside of the wait for. And yeah, with all these mistakes, here's a thing that really helped catch some of them. The ESWint plugin for testing library has pretty much most of these use cases there, so it can warn you when you're doing something that you shouldn't. And before wrapping up my talk, so we have in the last 5 minutes, so this is pretty much the most common error that I've seen while using the React testing library, and it's probably the most Googled one, which is warning an update to your app inside the test was not wrapped in Act. So you might be wondering, why is this error? Didn't you just say you probably don't never need to use Act? Yes, I did, but let's look at an example. So we have this function here, which is a component that has it's called display Pokemon. This component will get a function for doing a fetch request, in this scenario, getting our Pokemon data. We have a use state hook, which has loading and set loading, and then we have a function that will do a couple of things. First things first, it will set loading as true whenever you first call it. Then it will try and get your data by calling get Pokemon data with the Pokemon name that you pass it. Then, whenever that data comes back, it will set loading as false. Or if there's an error, it will set loading as false. Then what we do, we have a button that whenever we click on it, it's going to call this function with the name Pikachu. And then we show our loading state. Now, how might we test for this? Well, this is an example that I probably would have written a couple of months ago or years ago. So, first things first, I describe my test. I mock my get Pokemon data function with a jestfn, and then I render my component and pass it my mocked function as the get Pokemon parameter. Okay, then what I do, I await for a user click event. I click on the button that has the name Pikachu, so I'm using a get by role query, which will look for a button in this scenario with the name Pikachu on it. I click on it, and then I do some assertions, and then I expect my get Pokemon data to be called with Pikachu. Okay, so this is an assertion. The thing is, if I run this test, it is the dreaded error that none of us like. An update to display Pokemon inside of a test was not wrapped in Act. So this error comes up because, like I said, it's expected when you're writing a test that all the actions and all the things that are called units of interaction with the user interface are flushed out to the DOM. So this error pretty much is telling us, hey, look, there's something happening after your test ends that you're not looking for. There's an error there. There's an action that you're not contemplating on your test. So first things first, I want to thank React for thinking of that and letting us know, hey, look, something is wrong there. Now, putting this in perspective, can anyone try to guess what might be the thing we are forgetting in our test? Okay, so it's this, pretty much, which is the set is loading. So for some reason, we are clicking on a button, we are asserting that the call was done, but we are forgetting that we are setting loading as false. So there's a state update that's being triggered after our test ends. And pretty much this error is React way of telling us, you're not testing everything, you forgot some scenario. So how do we fix this? By doing the following. We either await for the loading to disappear from the DOM because it's being rendered, or we wait for them to be removed. So we can use wait for with a query and an assertion not to be in the document, or we can wait for element to be removed. And yeah, this is pretty much the most common error with the React testing library, and it's important that you're aware that you probably don't need Act. So if you see this error, try to think, what am I forgetting in my test? And yeah, that's my time. Thanks, everyone. I'm Daniel Afonso. You can follow me on Twitter, on any social media, and thank you for your time.
Thank you, Daniel, for the amazing talk. I hope now you have gotten some motivation and you will go and write unit tests. I'm not hearing anything. Will you go and write unit tests? Yes, I am hearing yes. I am a positive person today. And if you think that writing just unit tests will save you, how many of you think that just writing unit tests will be enough? Okay, nobody thinks that good. So unit tests only cover one part of the way. You have a different type of tests, which will be a surprise. I'm putting that as a surprise on the next speaker. And on that note, our next speaker is very special. Do you know why he is special? There are two reasons. First is that he is called Bruce Wayne at his office. Not because his profile pic is of Bruce Wayne, which is true, but he then saves all of them by writing some great tests. And second, he works at Rippling, which is our platinum sponsor. Whoa! So thank you for that. Otherwise, this would not have been possible. We would not be here. So I would like this a moment to call upon Anup Ravindran on the stage and tell us how to pull up Batman in modern front-end world.
React India. React India. React. React India. React India.
I'm Balram, and before Anoop's talk, I'll be just walking you through quickly of the scale of problems we are solving at Rippling and how this end-to-end setup, which we have done recently, is helping us scale all this testing across our 30+ products and 600+ engineers globally. So I'll be walking you through the journey so far and then like all the new things which we are trying to do. So yeah, at Rippling we are trying to solve a $100 billion plus problem. Sounds like a lot, but this is something like we really feel like we'll be achieving in another like few years. So what is that problem looks like? So the problem is all about like all the administrative work at a company like which happens. Usually the people who do this work end up spending 60% of their time doing all the manual repetitive work all day in the office, and 40% of the time they just work on the strategic work which is actually needed to kind of like run the company forward. So what Rippling is trying to solve is like cut that 60% of the time to zero, so that like everything when you run a office, all this employee data, everything runs automatically, and you just bring your 40% to 100% so that in your company you can be more productive in terms of like how you build strategies for your future. So yeah, the root of this problem we have discovered, that is every system which is tied to employee data runs on like few of the like key elements like employee's name, address, his salary, and all these components. Now the problem in today's system is like in your offices you might be using like a lot of systems for it. Like you might be using one software to kind of do the payroll, one software to do the insurance.
Now your salary is in one system, your insurance data in another system, and your employee data is in a third, maybe like something like greenhouse or something. Now what happens is like at the end of the day, all these tools create like a huge ecosystem in your company which someone has to manage. And this becomes like much more problematic when a title changes. Like say you get promoted, you get transferred between departments, then someone has to do all those transfers manually. Like if you are transferring from front-end engineering to back-end engineering or turning a full stack, you definitely need like access to much more repos, something like AWS. All those things are taken care by like Rippling software like automatically. So when we say like what's Rippling, it connects everything to one single source of truth for your company. So all your company's admin needs to do is like go to Rippling. We have all these 500 connections available at their like you can say disposal, and through which like they can run the whole operations automatically. And we have automation in place for everything so that all these repetitive work you do once and next time it's going to happen automatically. Now I'll talk a little bit about where Rippling sits in this whole ecosystem. So for every company to function, there are three major components. One is customer, second is operations, and third is employee set of data. So if you talk about these data, Salesforce has solved this problem for your customer system of record, like all this marketing, all this data is centrally tied in a Salesforce DB. Operations, SAP is solving it. And for employee system of record, there is nothing exists today in the market, and Rippling is trying to bridge that gap. And yeah, like we have built the system and did great so far. So if you compare like in terms of like, it's not a comparison between two platforms, but showing how Rippling platform at the end works. So we have a employee database which is central. Now we have a outer layer to it which is called Unity platform. So all your automations, all your permissioning, you have multiple kind of people in your org which need different level of accesses. All these are controlled centrally here. And then the outside of it, what exists is our internally built products, which are like currently hovering around 35 in numbers, and we are building many more. So this ecosystem you can consume is like whenever you buy an iPhone, you get a phone, and around which you get like some native applications installed with it, and then you will always need like third-party apps. So that comes as a third layer, that we also have very deep integrations with all these platforms which are available. So once you get hired, like say for an example GitHub, it will automatically provision you to GitHub, and then it will automatically like provision you also to Asana. Now if you are changing team in Asana, your team needs to be changed. All these things are really well mapped in Rippling itself. So your admin just need to set up this automation that if department do this, all those things happen magically. So yeah, that's the beauty of the platform. So just in summary, like it starts from employee graph, have a Rippling Unity platform, and then we have three major clouds, HR, IT, and finance. Rippling is trying to cover all of them, so companies don't have to go anywhere else to manage their employees. And just quickly, I'll talk another minute about our engineering. So this is another like one crazy story. So Silicon Valley has this doctrine that you focus on one product. If you don't focus on it, you will fail. But Rippling is from the day zero, we are running on a different path. We know we are going to be a company which is building many more products. And the platform, the central core of engineering is built around that. So anytime we launch a new product, we have like this central DB available. We have this central Unity platform available. So building apps on top of it is really easy. So for an example, like recently we launched spend management, which is like your corporate car management. So Brex is a company which is doing it from years. In Rippling, we took almost just 1 year to build it out. So that's the beauty of the Unity platform centrally. And yeah, it's a engineering first company. This is very rare to see only company which has like 50% of the workforce consists of engineers. And globally it's SF based. We have beautiful office in Bangalore as well. And yeah, the problems which I'm going to talk and which will further link to our tech talk is now building these products single-handedly is very easy. You focus on one problem, you build it, you test it well. But building these 30 products which also talks to each other, it makes the problem really hard. You change something in payroll systems, now your insurance systems has to be updated. So that way the problem is really challenging, and that also comes to the testing part of it as well. And the scale is like, for an example, one of our product out of 30 payroll, we are right now processing yearly payments of $10 billion, and this year end, I think we'll reach around $30 billion like processing the payroll. So yeah, coming to our front-end engineers specifically, like why we are here. So our tech stack right now is in React. We are using React Native for our mobile applications. We are early adopters of React Native as well. We are using it from day zero and working out great for us. We have a beautiful design system. Soon we are planning to also make it open source. And in terms of open source, yesterday is the first plugin we have made open source. It has like thousands of weekly downloads now. So Anup would be talking about it further, that how it can help you, like you can say, centralize your Playwright test reports later on. And yeah, some of our colleagues are here. If later on, if you want to talk to some of these and want to get to know more about rippling and our systems, just talk to us. And yeah, I'll be passing on to Anup, who will be like talking more about the E2E framework we have.
कौन सा click करें? Next.
ये next होता है, ये previous होता है.
Yep. Am I audible? Awesome. Yeah. So let's talk about more testing. So the primary purpose of this talk is to walk you through the journey that Rippling had, adopting Playwright, Microsoft's Playwright for our end-to-end testing workflow. Now we're going to talk about a lot about testing. We're going to talk about the problems that we face and how we actually solve them, and then how all of this actually comes into our CI subsystem, right? So yeah, I'm Anup Ravindran, and for the people who are looking at this, this is Baga Beach at Goa. Parasailing, highly recommended. It's a one-time thing. Yeah, and I work in a team called Front-End Platform. What that team does is primarily has one purpose. It is to make the web ecosystem at Rippling much better, right? And we do that by improving two things. One is UX, and the second one is DX, right? And so we have a very mature design system which is powering our product experiences. And for the DX part, we work on all things which enable us to take one line of code from which the developer writes to the end user, right? Which would be bundling, deployment strategies, diagnostic systems like linting, type checks, unit tests, and then end-to-end tests, right? Yeah, so we look at the different sections of what this talk is supposed to be. First, we'll talk why, right? I mean, end-to-end testing is from unit testing is the next level of testing. How does end-to-end testing enable us to write better code, sleep better at night, right? That's the best part of it. And then we'll talk about why Playwright, right? Because it plugs in exactly to our workflow in a DX methodology, which is extremely easy to follow. And then the second one is we look at the DX part of it in the phases of test, right? The first thing you would do is author a test. The second thing is execution. The third is debugging. And the fourth is actually reporting around testing, right? So we'll approach DX in that way. Now we do seeding via APIs, but we migrated that to debugging via data snapshots. So seeding is like, let's say you are writing a test to check if order cancellation flow is working perfectly or not, right? But for that you have to first have a customer signed in, create an order, and then only you can actually run that test, right? So those prerequisites are what seeding refers to. And the last part would be the open source part of it, right? We wanted to actually give back. We had so much fun working on this, building this, that we wanted to actually give back in any way that we can. So we found a problem, we solved it, and we actually open sourced it out, right? It's been around the ecosystem for some time, so we'll talk a little bit more about it. Right, so this is the development workflow, branching methodology that we have at Rippling. So we follow a trunk-based approach. What that means is, whatever is in master is expected to be stable and ready to go to prod at a moment's notice, right? What that means is we need very good levels of diagnostic systems, gatekeep whatever goes into master, right? So for that, we make sure we have, as I said, unit testing and then high degrees of end-to-end testing. So we have about 600 press developers across 6+ time zones contributing to it. So yeah, it's a highly fast-paced environment when it comes to code, right? So yeah, why Playwright? As I said, we were actually starting to do with Selenium, but then we did an analysis in terms of scale, and then we actually wanted to migrate to Playwright. We'll talk a lot more about details. And then one thing I wanted to be very clear is, we're not doing a comparison study between different frameworks. This is not a framework war kind of a thing. We're just going to say how this plugs into our ecosystem, and it was perfect for us. Right? So to tell you a little bit about the reasons, right? I didn't want to have like a lot of lines of features and stuff like that. What I did was I created a word cloud, and based on the size, you can actually detect that how important it is, how impactful it is, and based on the feedback we got from the developers, right? So the first thing you can see is auto wait, which means no more timeouts. You don't write any more timeouts, just like in Selenium where you wait for 500 milliseconds for something to come out and hope it comes up. No. So you actually wait for an element to be on the screen, and then it actually provides, right? So by default, it actually does that with auto-wait and web assertions. Then we'll talk about the crown jewel here, which is the trace file, which we'll cover in a later slide, which is, I would say, one of the best things about Playwright when it comes to debugging. Then yeah, obviously we have documentation. It's very good documentation, but yeah, the community is still growing. We have screenshot testing, yeah, out-of-the-box TypeScript support, and then we have the browser installations and the setup, right? It's extremely easy. So we'll talk a little bit more about those. So we'll start with the first test, right? The first phase is actually authoring a test, right? How do you actually run it? Write a test. So, and the biggest problem with E2E tests is when a new developer actually comes in, they may not have experience writing an end-to-end test, or they don't have very much knowledge about the syntax of Playwright test, right? So the cold start to adoption would be a little high. So one of the things that Playwright actually provides us is a code gen. What happens is the first thing we ask the developer to do is run this code, run this line of code on the web app, right? What this does is it opens an inspector for you and a browser instance. Just go there, just do whatever you have to, and then you would see at the right side the code actually getting generated, right? So the developer is able to see, okay, there's a one-to-one mapping between the interaction that I'm doing on the browser, and this is how the syntax actually works, right? So navigation, clicks, all those things, they're able to understand it very perfectly, right? Now the next part is VS Code comes with, Playwright team has built a beautiful VS Code plugin, which right now is getting more and more features, and now it's at a level where you don't need the command line at all to run the test, debug the test, nothing of that sort, right? So again, the VS Code plugin has the record new feature by which you can do the same thing on the plugin itself, right? Now we all face this issue where a component is actually breaking the CSS, and the product is the user is not able to actually go into the product, interact with it because of some CSS issues, or CSS not even loading, right? You just see the HTML and the syntax, but the tests actually pass because there is no visual testing, nothing of that sort. So what we do here is we have a screenshot testing framework within Playwright, and you have this, when you write this line of code in the test, what happens is it generates a screenshot, and then every future executions just compares with that, right, at a pixel level. And then Playwright not only supports screenshots, but it supports binary data, text files, everything, right? So it's able to compare anything that you have to. And at the same time, we use the officially supported Docker image, which is version, right? So what that means is, if you're using 1.26.0, you use the same image in Docker, and then when you have to upgrade, just upgrade this. It takes care of system dependencies, it takes care of the browsers to download everything. So in 2 steps, you are able to completely build the whole, upgrade the whole system. Right? Now let's look at the second phase, which is the execution of test. Now execution is a bit more trickier because you have local execution and then you have the CI execution. Both levels of debugging is there. So we'll start with the browser support, right? Where to actually execute. So again, Playwright has this covered here. We just have to run npx playwright install. It downloads the correct browser binaries that we need based on the version of Playwright you have, and it just installs it and it's ready to run, right? So when you upgrade it, run this again, and it actually detects again and downloads the new binaries for you. So now because you have multiple browsers and it's already supported, you can actually put in your Playwright config saying that, okay, I want to run it both on Chromium and WebKit, and by default it actually runs it. And you can provide in the CLI command line again that I only want to run it on Chromium, so you have that option also, right? Now the next part is actually running the test. So it's a single command. It's like npm playwright test, and then you have flavors to it where you provide headed, then a Chrome, then a browser instance is opened, and you are able to see what that test actually does. And then you have other flavors like debug, and then you can run one single test, a folder of tests, all those things. It's the same command. And again, the VS Code plugin comes in, and you get a beautiful UI, interactive UI, where you can see the different tests. You can just press that play button. The first one is for running, and the second one is to trigger debugging. Right? So we'll talk about debugging a little later. Now, one of the biggest problems that we were facing when we were actually scaling, right? We had multiple products, was, let's say there is an insurance test which was failing, and then payroll PRs were getting blocked. Right? It's not because of the code that you have in the PR, but it's because of something else. Right? So we wanted to build a system where we don't block the PR, unless and until it's because of your code. Right? So we had two specifications on this. One, we needed developers to be able to map that between the source file and the test. And the second one is we wanted to detect the relevant tests on CI itself and run only those tests. Right? So based on that, we actually built a system where the first step is actually detecting which are the files changed compared to master. So we know exactly which files. The second one is just the mapping JSON which the developers maintain. So based on this, we know the only changes that has run is the payroll test. So we detect and list down the payroll test. Now that we have a list of tests to run, next part is actually executing it across, right? So yeah. So at a scale, let's say about 500 tests or something, you will not be running these tests in one machine. You will be running this across multiple machines, right? So when that happens, Playwright provides a sharding mechanism where you can actually say, okay, 1/3 of the tests run on this machine, the second third, and the third in some other machines, right? So the problem here is, let's say there is a group of tests which are extremely fast, and there are a group of other tests which are extremely slow, right? So let's say in this case, batch 0 takes about 3 minutes to execute, and batch 1 takes 10 minutes to execute, right? The overall step actually takes 10 minutes to execute, right? It's not efficient enough. Unless and until we have that data on how much duration a test takes, we won't be able to kind of batch it in a proper way. So what we did was, we actually built a custom pipeline based on bin packing algorithm, where we took the execution time of the previous test, and based on that we bin packed it in an efficient way for parallelly executing these tests. For example, in this case we have 3 tests, right? The first test takes 5 minutes, and we know this because of the previous run, and the second test takes 3 minutes, and the third test takes 1 minute, right? So if we batch it in this way, which is the sequential way, the overall time is actually 8 minutes, right? But when we actually do a bin packing based on the data we have, we are able to actually reduce the time by more than to 5 minutes, right? Now let's go to the third part, which is again debugging, which also has 2 aspects, which is local and CI. So in debugging tests, there are majorly 3 ways in local. One, you actually provide the flag, which is PW debug or the debug flag. What happens is a Playwright inspector actually pops up, which is very similar to your code gen, which actually pops up, right? And it actually stops at that particular line of code, and you are able to debug why this is happening on the browser, right? You have the same thing. And then what happens is you can use it like the debugger, the JavaScript debugger that we have. Line by line, you are able to traverse through the test, and then you are able to see the updates on the Chrome itself, right? So, and the third part is await page.pause, which is like execute till then and just stop and just open the browser for me. We'll actually proceed from there, right? Now, on CI, we have this beautiful HTML report which comes in, which is generated by Playwright for us, which has 3 major things here. One is the screenshot of exactly when the test actually failed. Second one is trace, which we'll go into a little deeper next. And then third is the video itself, the video playback of the whole test. And then if you have any console messages in your test, they actually show up here also, right? So this is a use case where it's happening on the CI and you need a report. This actually gives you everything, right? Now this is the crown jewel, I would say, of Playwright, which is the trace, where on the left side you see every single step that has happened on the test. On the top you see a film strip of all the screenshots that's happening over the test. And on the right you have console, the browser console, you have the network tab, and the source is the source code of the test itself, right? And in the network tab you are able to see all the headers. It handles CORS, it handles HTTPS, so you're able to see all the headers. It's much easier to debug. And in the center, it's just not an image, it's a DOM snapshot. So you're able to interact with it. You can actually go to the debugger and look at it mostly in the case of when you wanted better selectors testing about that, right? Now we go to the final part, which is the most overlooked part, I would say, is reporting. Right? How does a developer actually reach from a bug to the reason of the bug, right? So something broke on CI. Does the developer have to go to the Jenkins pipeline, scrounge through the logs? How does it actually translate to that, right? So that's something that we wanted to really minimize the number of hops between that. So we started with, we put the HTML report on S3 and we started sending links to it. So that step is not there where you have to go to the pipeline, nothing of that sort, it's a direct thing, right? And we also started adding documentation about the pipeline and debugging, particularly this step. on the GitHub comment itself, right? But then we wanted to also notify the user that something has broken. So we send a Slack message with the direct reports again. So only on failure you get a Slack message, and you are able to directly go to that report and debug. And then we also have this automatic detection of the DRI. So if a test fails on master, we actually tag the right person in here, and we are able to actually take it from there. Now we have videos, we have this video generated screenshot and everything. Now one of the things that we can do with it is we can actually share it with people who are non-engineering also, right? Because onboarding a customer to payroll is the same, right? So what we have done is we've created a dashboard over the data that we have from Playwright, and we have put all the videos in the retools dashboard. So they can actually share this to people to onboard faster. Right? How does a payroll customer get onboarded? We can just share this video, and they will have to slow it down because Playwright becomes extremely fast when it comes to this. And this is a dashboard that we had built. So the overall pipeline looks something like this, right? We check out the code, we deploy front end and back end, and then we have a DB, right, which is connected to it. We select the test efficiently, we batch the test for parallel execution, and then we run it in Docker. Right? We can do using the official Docker image for Playwright. When we analyze the reports to detect if there are failures, we send Slack messages, we send the report links directly, and then we close the PR itself. Right? So yeah, so the last so the last part of the efficiency section is this. We actually started seeding the test using database snapshots. Now this actually allowed us to reduce our test durations by more than 40%. So let's say a test takes about 4 minutes. The first 2 minutes is actually just setting up the data, and then the last 2 minutes is actually running the data, right? So we removed the part where we needed to set up the data before the test, and we moved it to a database level. We'll talk about that a little bit more. So this is the exact pipeline which generates that snapshot for us. So we've just taken a snapshot of that. Now, so previously we had API seeding. What we did was we actually moved to database seeding. How we did that was we had custom helpers built in the backend where you could run it at an interval, right? About 2 hours, 3 hours and stuff like that. And then it actually generated all the test data that was required, database data that was required, right? So let's say you need to test if a person has admin privileges. First thing, you would create a company, would onboard an employee to it, and then give admin privileges. Now, with this, you already have that set stored in the database, just like in the pipeline. So you can actually go back. You can actually just have to sign in and execute that test. Everything else is set up for you directly. Right? So looking at this pipeline back, so we have the deploy test environment, and then we have the DB snapshot reset just before the test so that we are able to execute it completely. Now we go into the last part, which is the rippling OSS. We had so much fun working with this. We were able to build exactly what we wanted, that we wanted to actually give back, and we were looking at problems that were not too big for us to, that we had to spend a lot of time, and not too small that did not have an impact. So we found a problem where when you actually run it parallelly across machines, they created different reports. There is no single report which actually comes to you. So we wanted to actually build a solution. We looked at how Playwright worked, and we found that what they do is they have a JSON in every index.html file. They gzip it, they change it to base64 URL, base64 encoding, and then send it across. So what we did was we took every report, converted it back to the JSON, wrote a custom logic to merge the whole JSON, and then created a new index.html and embedded the new JSON into it. So and then we open sourced it. It was mostly over a weekend. We just built it, and we are, and then it started gaining traction. Now we have Elasticsearch and Vercel actually using it, and we are committed to actually supporting the next versions of this thing also. Yeah, thank you. That's my place from my side.
Thank you so much, Anup. It was fantastic. Excuse me, people who are going out, there are some instructions there that I want to pass it on, which is very good information.
Hey. Hi, Ankit.
Hey.
I've been having a great time, and I hope all of you have as well.
I wanted to check with you and the audience about how many people attended the live streams.
I
and
attended the
workshops.
live stream. And it was fantastic, wasn't it? Yes, I think you are saying yes. And I just had this question, like we integrated that live stream inside React India website. I also have a blog, and I think after today there will be a lot of hits, at least 10, 20 more. Can I put that integration into my website so that people could talk to me?
Most definitely. So we at Diet provide real-time audio-video SDKs to embed such calls in your platform. And you can get started in less than 10 minutes and go live.
Wow, wow. What more could I have asked for?
I have something for you.
Okay. Whoa, folks. There's swags and goodies at the Diet booth. And there's a challenge wherein you have to show your creative self, just like me. And the prizes are AirPods. So if you scream a lot in front of Zoom screen, you should go to the Diet booth, register, and start building that challenge.
Come say hi.
Thanks, Abhishek. Bye-bye. Now, there's two more announcements. First, there's also React India swags that are getting distributed near the Cinema Paradiso. There's a fantastic artist sitting there, Megha Sachdev. So if you are feeling up to it, you can go for face painting, and she's very talented, right? Now to the main stuff, lunch. I know everybody is hungry. I need my energy boost too. So people who have red or pink bands, so you all folks have your lunch arranged at Fame Restaurant. People who have black bands, you have to go to Planet Daily. The food is same, it's just that because of so many people, we are just distributing. So don't worry, you're not missing out anything. Cool? Have fun, folks. I'll see you during lunch and maybe after that if you're not bored. Bye-bye.
React India. React. React India. 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 React India. React. React. React India. React India. 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 React. React. React India. React India. 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 React. React. React India. React India. 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 React. React. React India. React India. 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 React. React. React India. React India. 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 React. React. React India. React India. 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 React. React. React India. React India. 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 React. React. React India. React India. React India. React. 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 React. React India. React. React India. React India. React India.
In Expedia, we believe in new changes and new approaches are generated from the differences we have.
The way that you do work may not necessarily be the way that other people do work, and that's absolutely okay.
Authenticity and being your full self and bringing your personality, your experience, and your thoughts to the table.
When I'm me completely, I work to the best of my ability. I can really relax and give my best to the job that I'm paid to do.
Because we have a team that has different perspectives and different makeups and come from different backgrounds, I think it's super powerful.
People often spend more time with their coworkers than they do their own families. We need to make sure that people feel celebrated for who they are when they show up to work. The Resources Guide project was an initiative to make people feel empowered that they could take on self-education about different identity groups. We want to make sure we're always engaging with people where they are in their learning journey, rather than forcing them to move faster or maybe feel like we're slowing them down in some of these conversations.
As a Black woman, I don't have the choice to ignore the way in which I show up differently in the world and the way in which I'm treated differently because of the color of my skin and who I am and things that are not explicitly within my control. I am a perfectionist and I want it to be absolutely perfect, and the reality is people are not looking for perfection. It can be really challenging when you feel like you're speaking for or representing all Black people or all Black women. I do my best not to allow, the weight of everyone that looks like me to fall on my shoulders every day.
Prior to Expedia, I was nuclear submarine officer in the United States Navy, and definitely had some fearful moments or deer in the headlights moments around showing up to these meetings and being like, which side of the table should I sit on, and do I stand up when my boss comes into the room? When I joined the veterans group 3 years ago, they had a board that was all straight, white American men who had been in military service a long time ago. Now we have military spouses on the board. We have diversity represented that is more reflective of our workforce. The age range has been totally redefined as far as people who just came from the military like myself versus people who served in the military 30 and 40 years ago.
I've been now at Expedia for 8 years, and it's been a true breath of fresh air. In my previous employment, for nearly 7 years, I could not be me, because as much as coming out as queer was not even an option. And it never felt safe to be me when I was there. None of us are just one thing. I'm not just transgender, I'm also disabled because I'm deaf. And that's also an element of who I am. I never really felt like I had to hesitate if any incident happened, like for example, somebody actually misgendering me or using the wrong pronouns talking about me. Knowing the atmosphere, knowing the inclusivity at Expedia Group, knowing I'm surrounded by true allies, I knew with confidence that it was an accident.
Inclusion, I think, is not just an abstract concept. It's a framework that we need for good mental health. So when I lost my sister, I was really depressed. It's like a taboo in Japan to talk about your mental health. Management and my teammates really helped me open up and gradually talk about my feelings.
I think people are people largely, whether they're in an office building in downtown or buried underwater in a submarine.
Not only do people need to be empowered to speak, but their perspectives need to be respected.
We have an approach of always going one step further, rather than just it's good enough. Now, good enough is not good enough. The better is always better.
You don't have to be in the impacted population to be frustrated, outraged, or to just want to be a part of positive momentum and change moving forward.
That's the magic that is happening. Inclusivity in a word. Okay, hang on.
Curiosity is the word I imagine for inclusion.
Can I use more than one word?
Proximity was officially set up in 2019, but most of the foundational work actually happened in the 2 years preceding it. I've been running remote product engineering and design teams for the past 5 years across continents and time zones, and most of the asynchronous workflows followed at Proximity are a result of years of experiments and learning. Our workflows and processes are constantly evolving and getting better to this day. Proximity lies at the intersection of growth and speed, and we've been a 100% remote company from day one. Our specialty lies in tackling complex engineering and design challenges for scale-ups and enterprise companies related to performance, scale, and UX. Why performance, scale, and UX? Well, once a company achieves product market fit and now needs to scale to multiple countries, it reaches an inflection point where the successful MVP's tech is no longer useful. This is the time where the architecture needs to be reimagined for scale. Proximity's team bridges that exact gap to help build a highly performant and scalable product. Proximity was born with the mission to bring together the brightest minds from around the world, regardless of where they lived and worked. Our team is comprised of former startup founders, core team engineers, and designers who have witnessed and solved these challenges of performance, scale, and UX in the past, and they thrive in a culture of complexity and innovation. Proximity's engineering teams work as an extension of our customers' top 1% engineering teams. Today's companies are looking for more than a software solution. They are looking for a trusted, long-term relationship from a global partner like Proximity to help solve their long-term engineering problems and their challenges of performance and scale. In just a span of 2 years, Proximity has worked with some of the biggest names across the globe. It feels amazing to see the impact of our work in the real world, with over 55,000 hours spent on delivering long-lasting value and substantial results for our customers.
In Expedia, we believe in new changes and new approaches are generated from the differences we have.
The way that you do work may not necessarily be the way that other people do work, and that's absolutely okay.
Authenticity and being your full self and bringing your personality, your experience, and your thoughts to the table.
When I'm me completely, I work to the best of my ability. I can really relax and give my best to the job that I'm paid to do.
Because we have a team that has different perspectives and different makeups and come from different backgrounds, I think it's super powerful.
People often spend more time with their coworkers than they do their own families. We need to make sure that people feel celebrated for who they are when they show up to work. The Resources Guide project was an initiative to make people feel empowered that they could take on self-education about different identity groups. We want to make sure we're always engaging with people where they are in their learning journey, rather than forcing them to move faster or maybe feel like we're slowing them down in some of these conversations.
As a Black woman, I don't have the choice to ignore the way in which I show up differently in the world and the way in which I'm treated differently because of the color of my skin and who I am and things that are not explicitly within my control. I am a perfectionist and I want it to be absolutely perfect, and the reality is people are not looking for perfection. It can be really challenging when you feel like you're speaking for or representing all Black people or all Black women. I do my best not to allow, the weight of everyone that looks like me to fall on my shoulders every day.
Prior to Expedia, I was a nuclear submarine officer in the United States Navy, and definitely had some fearful moments or deer in the headlights moments around showing up to these meetings and being like, which side of the table should I sit on, and do I stand up when my boss comes into the room? When I joined the veterans group 3 years ago, they had a board that was all straight, white American men who had been in military service a long time ago. Now we have military spouses on the board. We have diversity represented that is more reflective of our workforce. The age range has been totally redefined as far as people who just came from the military like myself versus people who served in the military 30 and 40 years ago.
I've been now at Expedia for 8 years, and it's been a true breath of fresh air. In my previous employment, for nearly 7 years, I could not be me, because as much as coming out as queer was not even an option. And it never felt safe to be me when I was there. None of us are just one thing. I'm not just transgender, I'm also disabled because I'm deaf. And that's also an element of who I am. I never really felt like I had to hesitate if any incident happened, like for example, somebody actually misgendering me or using the wrong pronouns talking about me. Knowing the atmosphere, knowing the inclusivity at Expedia Group, knowing I'm surrounded by true allies, I knew with confidence that it was an accident.
Inclusion, I think, is not just an abstract concept. It's a framework that we need for good mental health. So when I lost my sister, I was really depressed. It's like a taboo in Japan to talk about your mental health. Management and my teammates really helped me open up and gradually talk about my feelings.
I think people are people, largely, whether they're in an office building in downtown or buried underwater in a submarine.
Not only do people need to be empowered to speak, but their perspectives need to be respected.
We have an approach of always going one step further, rather than just it's good enough. Now, good enough is not good enough. The better is always better.
You don't have to be in the impacted population to be frustrated, outraged, or to just want to be a part of positive momentum and change moving forward.
That's the magic that is happening. Inclusivity in a word. Okay, hang on.
Curiosity is the word I imagined for inclusion.
Can I use more than one word?
In this area, who would like to answer that?
Who's next for this question?
Sure.
Rite?
What's your name?
My name is Smile.
Okay.
So I hate OKR planning. So why do you have to plan for next quarter? Maybe, there could be spillovers. There could be, things that got off the table. What's the even point of spending?
Does your manager know this?
Yeah.
Okay. Is there anyone else? Sure. What's your name?
My name is Himadri.
Okay.
I hate retrospective meetings. I mean, what went good, what went bad, who cares? Just move on.
Okay, we have some pretty strong opinions here.
You don't want to know what went bad?
No.
Okay, who was next?
Great.
Who wanted? 1 second.
Yeah, there's one here.
Hello, I hate stand-ups.
Okay, and does your manager know this?
No.
No?
He will now.
No, I don't think this part is getting recorded, so, you can just say anything you want.
Okay, so I think with stand-ups, I too agree that I have to always think what I did. Anybody else agrees with stand-ups are the worst? Yeah. Okay.
Who does asynchronous stand-ups?
My
in
opinion is
Slack?
also the same. You can't stand a stand-up.
Okay, pretty nice. He's very intellectual, into joke making. Cool.
Was
Okay.
that a roast?
No. Okay, I'm now going to choose somebody who's not looking very interested to answer. Okay, I think I found my person. What is the one meeting that you can't stand? Don't say this.
Sorry, so long stand-up meetings. Like, I love like if it is 15 minutes, but not more than 30 minutes.
Okay. She's okay if it's just 15
Very
minutes.
serious answer.
Very serious. She's totally politically correct.
Okay, so who was here in last version of React India? Like, which was held here? No one? Wow, we have a lot of fresh faces this time. I didn't expect that.
Okay,
See, they wasted one of my questions.
And my entire entry was based on like if people would have seen me in first edition.
Exactly.
Okay. I don't seem so cool now. Okay. Cool.
Okay.
So next question is, what is the one thing that you absolutely love about front end?
No one? No one loves front end? Is it like that?
Ritesh, you should just pick somebody, and I think there we have an enthusiast.
Fine. There we have one.
So what I love is...
What's your name first?
My name is Dinesh Kathuria.
Okay.
So what I love is when you type a single letter and you see it on web browser.
Great.
Immediately.
So this was a serious one, right?
Yeah.
Okay, there was someone in this area?
To play with inspect element.
Okay.
Okay. So I'm choosing here two women who are in black. They're matching together. What's your favorite thing about front end?
I think that it's not backend. That's good. But other than that, I think, yeah, the user interactivity, like whatever you're typing, you can see whatever change. I think JavaScript is great, so that is one thing I really like about front end.
Thank you. Thank you.
Okay, I have one here.
Yeah, so my name is Mohit. So I love that we eventually become the face of the app.
Okay.
Like, so yeah, that's what.
So recognition, right?
Yeah, right.
The manager sees that.
Okay. Meanwhile, please text your friends that, hey, please come back. We are going to do some epic sessions. And everybody's pumped up. Cool. I think next question, Ritesh, is my favorite. And I'm very interested to know what people think about it. So according to you, what's the most annoying thing engineering managers say? What is the most annoying thing engineering managers say and they just can't stop?
Good. Yes.
It's about front end.
Okay. What exactly?
Like they say, it's just a front end. You can do it.
Okay, it's
very
easy.
easily. It's easy.
Okay, fine. Invite him here next time.
Okay, so I'm assuming your engineering manager hasn't written front-end code.
So here's one engineering manager who writes front-end code.
But my problem is like my team doesn't take me seriously at all. Like they always feel I'm joking.
So who here takes him seriously? There's one person.
Okay, he thinks
it's not
I'm
a team
serious.
problem.
Okay, okay. What else? This is a very, this should relate with you, right? I think everybody hates engineering managers except me. So what is that one thing that you make fun of in a good way? Okay, he's here.
Yeah. Can I get a status update?
Why don't you look at Jira?
Is anyone here like who is an engineering manager or like team lead or something? Again, there's one. Okay, there's one.
He's all in one.
Okay, I have a question for you then. What's the most annoying thing you say?
It's on the same lines. Where's the daily update?
Okay. Same. There's one hand there.
Okay, 1 second. Okay, she's pumped up. Good.
I think the most annoying thing is like after a party when a manager says that the next day you have to come on time and be present in the office. That is the most annoying thing about a manager.
Thank you. What's your name, by the way? Okay, she's Shonali. Do you also have something to say?
We are in the same team, so I would agree to her. Yeah.
Okay. So nobody in this area? Yes, great.
You said annoying thing, right?
Yeah.
I think my team is not there.
No.
And we are telling everyone that this is not getting recorded. We have no idea. But anyways.
Cool. Be free, everyone. This is no pressure. This is not getting recorded. We are just having fun.
I think
we have 2-3 more minutes.
It is like, ये कब तक हो जाएगा?
Yeah.
React India. React. React India. React India.
I went a bit emotional there, sorry. I went out of my character of comedy. Cool. Anybody else? Because we are starting to fill up and we want to start our next talk. Can we have some music, please, to pump up the crowd? And our next speaker is raring to go. Do you like the React India opening theme song? React India.
Okay, hello. Welcome back. I know you might be feeling a bit lazy, well, that's obvious. But once the talk starts, you won't feel that. So before going ahead, I'd like to thank our sponsors. Our platinum sponsors, Push Owl Rippling. Our gold sponsors, Agora, The Graph, Storyblock, DevRev, and Disney Plus Hotstar. Our silver sponsors, Diet, Comet Chat, EPAM, Proximity Works, SyncFusion, Tata 1MG, Geeky Ants, Gumblet, and Expedia Group. Bronze sponsors, Saloon, Sprinkler, N26, Zata, OLX Group, Microsoft, Lab 49, Medallia. Diversity sponsor, Flight Control. Media sponsors, JS Party and WebDev Samachar. Live stream sponsor, Diet, and organizer, Gigabyte. Okay, so I hope you enjoyed the first half of the talks. We will be continuing on that. Okay, let's talk about the next one. So our next speaker is a pilot. He likes flying helicopters right side up and aeroplanes upside down. So you see, when I give this intro, then you don't want to talk about anything and just call him to show who he is. So he's going to talk about Next.js applications, how you can improve type safety in Next.js applications using third-party libraries. And some things are obvious in doing type safety, but as soon as databases get involved, it becomes a bit tricky. So I'm hoping that the next talk is going to, I'm sure actually that next talk is going to just solve that problem for you. So Brandon, who is our next speaker, is the CEO of Flight Control, and he is also a creator of famous library called Blitz.js. He'll be on stage talking you through all the various options that you can use to improve type safety in your Next.js applications. So can we please welcome Brandon with a huge round of applause?
React.
Hello, test, 1, 2. Hello, can you hear me? Hello. Good afternoon. I'm so glad you're here, as long as you don't fall asleep. But I'll do my best to keep you awake. This is my very first time in India. Okay, you did well. Now it's my turn. Woo! I really am so excited to be here. This has been one of my favorite conferences so far. You all are so inspiring. I really mean that. You are so intelligent and so enthusiastic, and I just love it so much. Thank you so much for having me. So let's talk about type safety. At lunch, one person was saying that they don't use TypeScript, so hopefully they learned something in this talk. Type safety is important because it means your program will actually do what you want it to do. For example, if you have a function that needs to do some math, you should give it a number. If you give it a string, it will probably work because JavaScript was only built in 10 days. But ignore that because it won't always work. JavaScript gives you some runtime type safety, but you have to run the program to know if it's correct or not. This is a colossal waste of time. There is a better way. The ideal scenario is that all type errors will be caught at build time, ensuring type-related bugs never reach production. And this is the entire motivation behind TypeScript! You know, it's funny. All you have to do is just like, go like this, and everybody claps. So TypeScript is like walking through a maze with your eyes open. But JavaScript is like running through a maze with your eyes on fire! Oh, didn't even mean to do that. As a co-founder of the startup Flight Control, where we make it easy to deploy apps to AWS, I care a tremendous amount about building efficiently, fast, and bug-free. TypeScript is one of the biggest levers available to accomplish this. Thankfully, setting up TypeScript in Next.js is a breeze. Rename a file to .ts or .tsx if it is using JSX in the file. Then restart the dev server, the Next dev server, and Next.js will automatically install all the packages you need and create the config files for you. It's really that easy. It's so incredible. So there is zero excuse to not use TypeScript if you're using Next.js. Here's the tsconfig.json file that is generated for you. This is how you customize TypeScript. I highly recommend changing the strict option to true, if not right away, after you have become more comfortable with TypeScript. Because strict true will give you the most guarantees of type safety. With strict false, there will be cases where TypeScript will not actually save your bacon. In my opinion, TypeScript shines the brightest when working with data, because data usually becomes very complex and hard to keep track of in your head. Let's look at how TypeScript can help us with using data in Next.js. The first and most basic way to render data on the page is using get server-side props. So we'll add this function. I wish I could run outside and watch the plane, or coding, and I have no idea what I'm doing, and we don't get any autocomplete. So, thankfully, we can import a type from Next.js, get server-side props, and now we get a type error, helping us guide the coding so that we know we're doing it correctly. So we need to change the return to an object, and now we get type safety. So I have this data file, this JSON file with data, and we're just going to load that, return it from get server-side props, and then render it in the page. Yay, the demo worked. So that is using how we use it data in Next.js. And something didn't continue like it was, but okay, so now we still have a problem. Deployments is type any. And we can break the code, but TypeScript doesn't complain. So that's not what we want. So we can define manually define a type for our data. And this is a type of the data from the JSON file. We know what it is, so we'll just write it, assign it to the variable, and add that type on our page props. Yes, we got an error. So that's exactly how TypeScript helps us. This is great. Actually, it's not. Because if we remove deployments up here, we don't get a type error. But clearly, the app is broken. So TypeScript isn't a magic bullet. You still have to use it correctly. What we need here is a way to automatically link the get server-side props data to the component. Good news! With some advanced TypeScript, we can do that. Even better news! Next.js did all the hard work for you. We can import and infer get server-side props type from Next.js. And now this gives us the type of the data. Oh, wait a minute, this is not working correctly. It's still type of any, and there's no deployments in this object. Oh, yeah. With Next.js, you have to specify the type there in your get server-side props type. And now we can change the component to use that page props. And now we can remove that deployments type. And we get a type error. It's exactly what we want. So now we really have full stack type safety on this page. This, my friends, is the secret to a long, happy marriage with TypeScript. We have TypeScript working with our JSON data file, but for a real app, we need a database. Does that mean I have to manually write all the types for all the fields and tables and everything in my database? Shit. Maybe TypeScript wasn't such a good idea after all. Wait, there's a solution. Actually, there's two of them. Prisma is a TypeScript ORM that you can connect to an existing database. If you wish, it can also manage database migrations for you, which is really cool. EdgeDB, on the other hand, is a new graph-style database that, like Prisma, also has a type-safe client for reading and writing data from your database. In many ways, EdgeDB has better performance in ergonomics than Prisma, but is tied to a specific database. So for today's demonstration, we will use Prisma. Let's throw away this JSON crap and set up Prisma. Here's the Prisma schema file that has the table and fields for the database. To use it, we run Prisma generate on the CLI. This will generate all the TypeScript for us. And let's go look at this file to see what is generated. Holy cow! This is bananas! You know, I really like bananas. I typically eat like 3 bananas every day. And I really recommend them because they're really easy to use and have minimal trade-offs. But thankfully, you don't have to know anything about bananas to use Prisma, because this is all in the background. You don't have to know anything about it. Now we'll use Prisma to fetch deployments from the database and return that data from get server-side props. Now we can get rid of this custom type that we defined, because now the type automatically comes from the database. And you can see that the type automatically updates in our component because we're using infer get server-side props. Let's go over to this new page here. What? Flash must have moved this page without updating all the links. Have you ever had broken links in your Next.js application because of shit like this? How did you fix it? What did you do to keep it from happening? Thankfully, the Blitz.js community had this frustration and came up with a really elegant solution. Install Blitz in the Blitz.js Next package, wrap your config, your Next config, with Blitz, restart the server, and now you can change your string links to be an object called routes that comes from Blitz. And this has all of the routes defined on it. And now the link works. So this is really great because it gives you type safety for your routes. It prevents broken links. And it allows you to move a page to a different URL without updating all the links. And that's because this routes object has the name of the page, the name of the component that you export from that page, not the URL. Anyone want a raise? Add this to your app when you get back to work. So we're now good on the front end side of things. We can read and render data. But for the app to be useful, we also need to let the user write data to the database. I have a form here that is ready to hook up to an API. Thankfully, Next.js makes this easy by adding a new file in the API folder and then exporting a default function from that API file. And this will allow us to return data. But we need to import this type from Next.js, these two types, and that'll give us type safety and autocomplete. So let's get some data out of this request and just code up a little bit of a function here to take that and save it. Okay, paste in the fetch function here that's going to call that route. Now we're in business. Except, I feel like there's a bug here. Anyone see the bug? TypeScript is really great at helping us with this type of problem. So let's add a type on the server side, the input type. We'll export that, and then we can import it in a client. And we'll just assign the input to a new variable. Move the input that we had up to this new variable. And boom, we have a type error. We found a bug, yes! TypeScript saves the day. That data thing shouldn't be in there. That was a bug. Okay, and now we can do the same thing for the return type. By using the return type utility from TypeScript, you can extract the type, the return type of a function. Okay, this is good, except there's a promise in there, and that's not our data. So we can get rid of the promise by using awaited, another built-in utility. And now the return type is exactly what we want. So that's a really handy pattern when using TypeScript. Okay, we're making good progress. So now I've added the return type to the client. And let's go ahead and inspect that result. Oh, crap. Object is possibly undefined. Not another one of those. Oh, there's this one little trick that we can do to get rid of this type error. We can add an exclamation mark, and the type error goes away. No! You can't do that! It just hides the bug! You should almost never use an exclamation mark or as any, because it just covers up a potential bug. However, if you are new to TypeScript, or if you're on stage doing a demo like Tejas, feel free to use as any. But just be aware that it is not giving you type safety. This week, as I was preparing for this talk, literally, I got a message from a customer about a bug in production. So I stopped preparing my talk on type safety, and I go investigate the bug, and guess what? I found an as any that I wrote. Oops. So I quickly fixed that and went on with my day. In the evening, I went to a party, and I was having the time of my life. And I got a message from another customer about another bug in production. Guess what? Another as any. Lesson learned. There are a few different ways to correctly fix the maybe undefined error. If that thing is expected to possibly be undefined, then use if else and just branch and correctly handle the logic. If it is unexpected, like maybe a ghost in your program, then use the assert function. What is assert? Assert is a function that will throw an error if the input condition is not true. The top here, using an if statement, is doing the same thing as the bottom assert call. So it's two different ways to do the same thing. And in TypeScript, you encounter this condition quite often. So assert is very handy and elegant. Assert is not built into JavaScript, unlike some other languages, so you have to write it yourself. And this is how you do it in TypeScript. The magic is using this assert keyword, which is what tells TypeScript that, hey, this is doing this assert thing, fix the type for me. Assert is one of the most important tools to have in your tool belt, and you should be using it often when using TypeScript, and probably when not using TypeScript. So back to the API handler. We have all the types to be defined, but to be production quality, we're missing something very important. We don't have authentication here, and we need that, but ignore that for now. What else is wrong? What if when it runs, what if the number of stars input is actually a string, or a date, or an octopus? It's not going to work, right? We need runtime validation. Both of these are super important. TypeScript does not do runtime validation, so you must do it yourself in your code. To be production quality, we would need all of these checks just for this one input. Now imagine if you had 10 input fields, or 50. You'd have to define all the types and all of the runtime validation for each one. That's crazy. Ain't nobody got time for that. Good news! There's a library called Zod that saves the day. Zod is a schema definition and runtime validation library. It allows you to define the type and the validation with the same line of code. So it lets you go from what's on top to what's on bottom. For only one field, it's not a huge difference. But as you add more and more fields and more complex validation requirements, like needs to be an email input or a website input or minimum password length or all that kind of stuff, Zod saves you a ton of work. Use Zod every time you are accepting user input or third-party data. So this means every API route, things like webhooks, interfacing with third-party systems, this will give you type safety and runtime safety. Here's a very cool tool that allows you to paste in a JSON payload, and it will generate the Zod schema for you. So this is really handy to quickly use Zod. There's one more trick that might blow your mind if you've never seen something like this before. Watch this. So, oops, missed one point. What's better than just validating input on the server? Client-side validation. Oh, crap. Does that mean I have to write all my validation requirements a second time just for the client? No, that'd be too hard. Watch this. I'm going to take the Zod schema and move it to a third file that I can import on both the client and the server. So now I update my inputs, or my imports here. Now I can import that schema on the client and pass it to my form component. And now I get type safety on the client for free from the code I already wrote. So this gives me type safety on the client and client-side validation. And on the server, it gives me type safety and runtime validation with the same code. This is the dream. It's so cool. All right. let's talk about the different types of client-server data transfer options. We have get server-side props, which is easy to infer data, but it's only for data reading. We have REST, but you have to manually define all the types or use some type of complex code generation tool to use that. Oh, well, GraphQL. Actually, it requires the same amount of work as REST to get TypeScript. It seems we don't have any good solution for full stack type safety, but what choice do we have? What if there was a way to write a function that runs on the server and then import that into your React component and just have it work? That would be amazing because you get type safety for free without generating code because it's just a function import. This happens to align very well with another style of API called RPC, which stands for Remote Procedure Call, is essentially running a function on another machine, send some input, and get some output. We could use React Query to manage caching and loading states and all of those things. This would be really, really cool. But for this to happen, you would have to do two things. The server function would have to be swapped out or exposed as an API endpoint somehow. Secondly, the server function import would have to be swapped with a fetch function that would call that API route. Guess what? This exists. It's called Blitz RPC, and it's been around for 2 years. It's used in production by thousands of applications all around the world, including many of you here in the audience, which is so cool. You may have heard about this, but probably you weren't super jazzed about it because Blitz was a monolithic framework. But this year, Blitz 2.0 was a major pivot where we took all the components, broke them out, and now they're standalone components that you can use with any Next.js application. Let's look at this again. This is literally all the code you need for client-server data communication in Next.js. Like literally, like there's no other code. There's no REST, no GraphQL, no data fetching, no serialization or deserialization. This is literally all of it because that build time, we expose that as an API endpoint, and we add the fetch function for you. This massively improves the speed at which you can build applications, and it gives you amazing type safety. So now this is the full spectrum of options you have for client-server data transfer, with Blitz RPC giving you the best type safety for the least amount of work. Here's a summary of all the key points that I've talked about. Here's a list of really awesome resources that you'll need to scan the QR code, take out your camera, hold it up there, tap the link, and then you can download, that'll download the slides. I'll also share it in Slack. And these links are really awesome. So you have the TypeScript docs, which are good, the TypeScript playground, which allows you to play with TypeScript in the browser. And so if you have some type of TypeScript bug or problem that you can't figure out, put the code in a playground, share it on Twitter or in your company Slack or whatever, and be like, hey, can someone help? And then people can code the solution, send you a new link, and you can see how it works. The React TypeScript cheat sheet is a really nice resource for learning how to use types in React, especially if you've ever tried to use refs with TypeScript. You know it's a massive headache. This thing helps a little bit. Typeleveltypescript.com is a brand new thing. I think it was just announced last week, and is really, really awesome for helping you understand TypeScript how to think in TypeScript. Like, TypeScript is a language of itself. Inside of TypeScript, you have variables and loops and functions and all these things, and that'll help you understand that. And then the bottom two links are some really advanced articles if you want to go deeper. As we come to the close of this session, I want to boost your confidence in TypeScript. You are smart. You can figure it out. With a moderate amount of work, you can be better at TypeScript than many of your peers. And now for a tiny plug. If you want AWS without pain, check out flightcontrol.dev. That's my company, and we make it easy to deploy applications to AWS. We give you a Heroku-style git push deploy experience, but on your own AWS account, where you get complete full scalability and full security and ownership over it, unlike Heroku or Vercel or something like that. Thank you, and good luck.
Thank you, Brandon. I'm sure that no matter for how long you have been writing TypeScript code, there was something new for everyone. And what makes extremely happy is that something I created ended up being the part of this talk, transform.tools. Okay, so moving on to the next talk. Can you hear me now? Sorry. So our last two talks have been related to testing. First it was end-to-end, then it was static. Now we are moving to something different. We are going to talk about developer experience. So our next speaker is Bruno, who is a tech lead at N26 and a former police officer. He has been a police officer for a decade. So for most part of his life, someone being shot has been a bigger problem than a website getting down. He'll be talking about Turbo Repo and how you can use Turbo Repo to simplify the user experience of large JavaScript or TypeScript code bases, which depends on a lot of dependencies. So let's invite Bruno on the stage.
React.
All right, can you guys hear me? Can you all hear me fine? Cool. All right, thank you very much, everyone, for joining me today. Yeah, I'm here to show you a little bit about dev experience. So I'm going to talk about how to turbocharge your dev experience using Turbo Repo. A little bit about me. My name is Bruno. I'm the tech lead in this cool company called N26. I'm leading a team there where we're building the client platform. So we're kind of like building the tools and foundation for all the web engineers to build up the features on top of it. So I'm kind of like just pushing for better dev experience on my day-to-day. I'm currently working in a team of 3 engineers. We don't like to call ourselves DevOps. We like to call ourselves DevOps. So I basically help you to ship divs as fast as possible. So that's basically my job. I'm also a big fan of Nintendo games. So who is waiting for the next Zelda game? Because I'm really looking forward for this game. It's going to be cool. So yeah, let's just jump right in. But before I talk about Turbo Repo, I want to talk about how companies organize their code base. Right? Like there are a few approaches, and you're probably familiar with some of them. And I want to talk about multi-repos and mono-repos. So who here has been working with mono-repos? Cool, a bunch of hands, that's nice. And how about multiple repos at your company? Nice, okay. So yeah, so basically like the most common one in large companies, specifically it's to go through this process of having separate repositories, right? You have your GitHub account, You have several repos there, and then teams work separately. So I just crafted this little example here with where I'm building like a React indie shop, and then there is the web shop, there is the admin app, and then there is the UI. So basically the React component library shared across all those apps. And this is a reasonable approach, right? Like teams want to be independent, they want to be autonomous. So they want to choose their stack, they want to move fast, and they want to make sure they're not breaking the features from other teams, right? So that's a very reasonable way of organizing your code base. But what if there was another way? So basically, monorepo is the way that some companies are adopting now. And it's just meshing them together in the same repository. Of course, it's just not like a monolith, right? Sometimes people confuse monorepos with monoliths. A monorepo, it's basically a way of structuring your code base, but you can still have microservices there, for example, or micro frontends, for example. You can still have them in a monorepo. The difference is that they're all in the same repository, right? And you might ask yourself, yeah, so companies were using multiple repositories because they want autonomy, right? They want to be independent. They want their teams to be fully independent. But why monorepos are so hot right now? Why people are speaking about them? Why big companies are using monorepos, right? We see Google, Netflix, Facebook, Twitter are all using monorepos in some shape or form. Google, for example, created this tool called Bazel, which is open source. It's basically a tool to help you manage monorepos. Facebook and Twitter did the same thing. But those tools are really focused on C++, Java, so it's a different, it's not very friendly with JavaScript and TypeScript repositories. But still, they're really investing in those tools. They're really investing in monorepos, right? There must be a reason why they are not choosing to go with different repositories. And one of them, it's called reuse, right? It's just so much easier to share code with your team. If you have, you know, like for example, in this little demo here, I put like a models package there that's sharing your database models. So if you have two different apps that need those database models, you can just reuse them across the same repo. If you're working in different teams with different code bases, then you're probably duplicating that. It's very hard to share. You might have to extract that in a library, publish that to NPM, and then people can use them. Then you have to version it. Then it becomes way more difficult to make those teams to work in sync, right? In a monorepo, then it's just much, much easier. The second point here is the shared standards. In a monorepo, it's also much easier to make sure that your team is using the same standards. So if you want to enforce ESLint rules, for example, you can do that once, and then you can share across your entire repository. You could have like hundreds of apps there, libraries, but they can still follow the same rules in a much easier way. If you have separate repos, well, that's a much harder thing to do, because then you have to make sure that people are actually using your library, your rules, and so on. If you're using TypeScript, then it's also super simple to share a TypeScript configuration, right? You can still have several different ways of exporting this configuration. For example, if you have a client-side library, you can have like a TypeScript configuration for that. If you have a Next.js app, you can have a TypeScript configuration for that. But you can ensure that they're actually using good standards. And then, like I said, a shared database model is the best example. If you were accessing the database, then you have it there already. Another point here that I want to mention, which is like I'm experienced that every day at N26, is team collaboration. We work in a monorepo with around 35 engineers, and we have 4 different apps there, like server-side apps, and we have using React, and we also have a few libraries, like for example, a design system library. We have also all the libraries that we share across the monorepo. Like we have around 20 packages at the moment. And the team collaboration is just so much higher than my experience working in different companies without monorepos. Because think about it, you don't have to context switch anymore. You have everything already set up there. You have your Node version installed, you have TypeScript, you have all the dependencies. You have everything already set up. So when an engineer needs to pair programming with you, you just sit down and do the work. You don't have to figure out how to clone a repository, install dependencies, you know, sync SDKs, and you might need another dependency that's not declared there, and somebody else knows which dependency you need. But if you have a monorepo, then it's much easier. Everybody's already there. Just jump in, check out the branch, you know, do your pair programming session. That's it. Another thing that's super cool is PR reviews. We go to GitHub. We have everything there in the same repository. The changes are all there, and then we can just review codes much, much easier. And I have been experiencing that for the almost 2 years, the past almost 2 years, and it's been really amazing. It's really like a huge experience boost and performance boost for the team. Another thing that's super cool about the monorepo, it's atomic changes. So if you have 3 different apps or packages and they somehow depend on each other, you might even think that, I can split them up in separate repositories and I can do changes independently. That's not really true for all cases though. Some apps or libraries, they depend on each other. Like think about a system that has order and then it has a checkout that you have to pay. I mean, those things, they go hand in hand. You can't break the payment, you can't break the checkout process without breaking the payment. It's very tricky to get this right. So those teams, they need to communicate. But if you have everything in the same repository, then those teams are already communicating, you know? Everything is already there. If they break something, they're gonna see that in CI. So if you make those changes across those packages and you push your pull request there, all those packages, they will have their own test suites, you know, their own pipelines, and then they are going to break eventually, and you're going to see it, and you're going to fix it, and it's just much, much easier. Last but not least, isolation is a biggest selling point for multiple repositories. And this is where monorepos can still give you this sense of isolation, because you can still have your packages scoped down to be like fully self-contained, so they are not really like depending on anything else. If they do depend on other packages or libraries, you still have to explicitly declare them, right? Once we're going to jump into the demo and we're going to see how this works. But if one package depends on another package inside of the monorepo, there are ways to specify that and say, hey, I need this package to be available for me so that I can use it. It's not just something that you just use and then things can break at any moment. So yeah, with this in mind, it seems like we got the whole package thing sorted, right? So it seems like we can actually, today we can have like a solid monorepo in Java, especially for JavaScript and TypeScript projects, thanks to workspaces. So this is something that's available for all the package managers out there, Yarn, NPM, and PNPM. My demo is using PNPM, but it works in the same way from NPM and Yarn. It's exactly the same way. So this is sorted, so you can actually have a cool monorepo that has those dependencies declared, everything works in a nice way. But there's still a big challenge though. Running tasks efficiently in a monorepo, it's a big nightmare if you're just using like a plain workspaces. It works, but it's kind of like not very efficient. Things work serially, so you have to wait for one task to finish, so then you can execute next and so on. But that's actually in the past, because now we have a solution for it, which is TurboRepo. TurboRepo came out. I think it came out open source in the beginning of the year. It was a tool written by Jared Palmer. I'm pretty sure you know this guy. He wrote a bunch of cool libraries for React, like Formic, for example. And today they are part of Vercel, so it's still open source too, but it's fully baked in the Vercel ecosystem. So if you're using Vercel today, that's a pretty cool tool that you should consider using, because they provide you all the features that I'm going to talk about. So TurboRepo is actually a build system for monorepos, but it's specifically built for TypeScript and JavaScript monorepos. So remember that I mentioned that Google made a tool called Bazel, but it was wasn't really friendly for JavaScript and TypeScript. This one is actually solving this problem, and it's solving really, really well. You're going to see that in the demo. So let's talk about the features that TurboRepo can provide you. So the first one is that TurboRepo helps you to never do the same work twice. So if you did a build, or a test, or a lint task, whatever you did, TurboRepo is going to remember that. And then if you try to do it again for package A, but you changed package B, TurboRepo will say, hey, you have done this task already for package A. You don't have to do it again. Here are the logs of this task. You can just check it again. And that's just milliseconds. That's super fast. But then if you actually change something, then TurboRepo is going to execute this task that you told it to execute. You're going to see that in a moment in the demo. Another thing that's super cool about TurboRepo, which is something that they really solved pretty well, is optimized scheduling. So if you have, think about it, if you have a laptop now, super cool M1 with 100 cores, it's like super fast machines, then you're doing like you're running your test suite all written in Jest. and you have like 100 monorepo, around the packages in your monorepo, and you want to run the tests, and then you have to wait all of them to run after each other, right? But with turborepo, it's super easy to specify these dependencies between packages, and then Turbo is going to just like run all of them in parallel as much as possible, and then it's going to give you the results in a much faster way. Turbo also figures out the dependency between tasks, and that's also a very big one, which you can kind of like get away already with monorepos without Turbo, but it's just not very efficient. So Turbo can actually figure out, hey, I can actually do these tasks here in parallel. For example, linting is a good one. Usually, when you're using ESLint, you can just do it across your entire code base. They don't really depend on each other because the code can just be linted independently. But for example, a build, it's a different task. Sometimes you need to build a library first, and then you can build your web app, for example. There are ways to optimize this, but that would be like the simple way to do it. And then Turbo can also figure out that, and then, hey, I'm going to build the UI library first to make sure that the components are ready, and then I'm going to build the web app now, and then everything's going to work at the end. Another thing that takes caching to the next level is distributed remote caching. And that's where Turbo really shines. Remember that I said that Turbo doesn't do the same work twice? And that's not only true for your machine, though. That's also true for your colleagues working in the same team, and also true for your CI runners. So if you did a test or a lint or a build locally on your code base, your program, and you changed like 2 packages, you did a test there, Turbo can upload this cache to a remote server that I have implemented one here, I'm going to show you. And then, once the same task in the same code base is working, it's running in a CI environment like GitHub Actions, Turbo is going to remember that, and it's going to fetch from the remote server, and it's going to show you the logs. So it's going to save you a lot of time. Imagine that you have a monorepo with 100 packages, and then you're changing just 1 package. You don't want to run tests for 100 packages, right? You just want to run the tests for this package that you change. But Turbo is smart enough to know that, and then it's going to run the test just for this package, and it's going to show you the logs from the other package. So you still get like an amazing output from your monorepo. And you still know which package actually ran and which package actually just hit the cache. Last but not least, Turbo has 0 runtime overhead, which means that it really stops at your CI environment and development machine. It doesn't go to your production build. It just helps you to build and do development locally in a very optimized way. But once you build your app and you want to ship to production, Turbo gets out of the way. It's just a dev dependency, and then you're done. So that's really cool, because then you don't have to, your packages actually don't even know that Turbo exists. Like there's 0 dependency in between your packages and Turbo. You're going to see that in a moment. Cool. So enough talking, right? So let's go for a little live demo. Here I have prepared like a little demo project. You can scan. You can also access this link. You don't have to follow along. You don't have to clone anything locally. You're going to do it right now. But it's cool if you want to get a little reference from a monorepo. It's a small repository, but it's good enough to show you how Turbo works. So let's just jump right in. All right, so let me just walk you through here. I have VS Code open with my monorepo, and I have 3 important packages here. That's the ones that I showed you in the slide. So we have 2 apps. Under this apps folder, I have the admin app, which is a Next.js app, plain Next.js app. There's nothing special about it. And this app is just meant for managing orders, refunding orders, seeing customers, and so on. Here, I have the shop app. Can you guys see just fine? I'm in front of it. Here in the shop app, it's basically where customers go in, buy their T-shirts. It's a cool React India shop, and then they can buy their T-shirts and so on. But here, inside of packages, I have 3 more packages. One of them is our ESLint config, so it's kind of like a shared ESLint configuration that can be shared across all the packages. We have the TS config, that's also a shared configuration for TypeScript. You do it once, you share it everywhere. And then we have a UI library. So this is where you can build your component library inside of monorepo, and it's fully independent. So let's just take a look at inside of the UI library. If you look inside of it, we have pretty much the same thing that you have in an independent repository. It just really looks like an independent repository. You have your package.json file. You have all your dependencies declared here. You have all your scripts declared here in the same way you do in a separate repository. It's exactly the same way. The only difference is that if you're depending on packages inside of the monorepo, there is a cool way to declare this dependency I'm going to show you. And here, at the top level of our repository, we have another package.json file. If you don't work with monorepos, don't worry about it. This is simple, straightforward. You can try it out later. But at the top level of your monorepo, usually you have a package.json file that is responsible for managing dependencies that's owned by your monorepo. So it has nothing to do with the package itself. For example, Turbo is one dependency that's like just meant to be used inside of the monorepo for running tasks. Your packages don't even care about it. And then, once you're done, Turbo gets out of the way. So that's the job of the main package.json file. And inside here, I have a dev command, just like you probably do with Next.js or for React apps. I'm going to explain how this command works, but let's just try it out. Let me open my terminal here. And then I'm going to do a pnpm dev. By the way, I'm using pnpm, but it works in the same way as npm or yarn. It's not very different. You can have the commands in the same way. And then I'm going to do a dev command here. I'm already leveraging Turbo for doing local development. Why this is important? Because I'm doing development across 2 different apps, right, that I mentioned to you, and then the component library. And I want all of them to react to my changes. And Turbo is just running the development server for all of them at once in one single terminal session. If you didn't have that, you probably had to open like several terminal sessions, do a dev command inside of your packages, and that would be a hassle. Or you could also optimize that in different ways using one terminal shell. But it's still a little bit tricky. So let's see how this looks in our browser. So I have here the React Indie Shop, very simple Next.js app. It doesn't do anything. Just try to add stuff to the basket. Not very special, just a mock app. And then here I have my admin app, which is also like a fully independent app, right? If you notice something, they're sharing like a little button, right? This button looks not so fancy. Don't judge me about my CSS skills, sorry. But they're the same. So they're coming from this UI component library that I showed you guys before. So let's just come here to our UI library, and let's change something there and see how this works. So I'm going to src. I'm opening the button. There's just one single component. I think that's the smallest component library out there. And there's a very fancy CSS here. So I'm gonna change the color, background color of the button to purple. And let's see in our app. You see, it's already showing you the diff, right? So it's working. I'm changing stuff in a separate package that's completely independent from my Next.js apps. But this is working just fine, the same way you're doing your own single repository. Imagine that you had this component library in a different repository. How much difficult this would be to do this, right? You'd have to try out in a different playground and then publish the library. Your Next.js app would need to update it and then get this new version of the library. And maybe there's a bug there, and then you need to release a patch and so on. That would be a nightmare. So this is one thing that Turbo helps you with local development in a super easy way. And how does this work? Let's check the package.json file again. I have the dev command here, and it uses this special keyword called Turbo, right? So that's how you use Turbo repo. It's just a dev dependency. I'm declaring it here. I'm using the latest version. But Turbo is using this command run with the dev key here. Basically, Turbo, what you're telling to Turbo is like, hey, look at all my packages inside of the monorepo. Check if there is a dev script there. If there is a dev script there, run this command. Turbo doesn't even know that it's a dev command. It just knows that's a dev key, If it's firing up a dev server, fine. If it's doing a build, it could also do a build. It doesn't matter for Turbo. And then it just spins up this dev command in those packages. And if you pass this parallel flag here, Turbo just ignores any dependency between them and then just runs the server directly. It doesn't care. Because, for example, in the admin and the shop app, they depend on the UI library. Remember that I mentioned this dependency graph? So they depend on the UI library to be built first. But during development, you want them to just run in parallel. You don't care about this cache because the dev server will build this again. Cool. So I have some other tasks here. that I want to show you. So I have changed my button here, right? So let me stop the dev server. I'm going to stop the dev server here. And you notice that I just changed this button here, right? So let's check if I have any changes here. So I have just this button changed. So I'm going to run another task here. I'm going to run the pnpm lint. And this is also leveraging Turbo. So let's see how this is going to work. It ran something here, but then the output is a little interesting. So we have something here from Turbo that says UI lint, so it's actually running the lint command from the lint task from the UI library. And we see it here, there is a cache miss. So remember that I mentioned to you that Turbo only tries to avoid doing the same work twice. So it actually knows that I changed the button component inside of the UI library, and it actually just runs again. It's a cache miss because the files changed. But for the other libraries, for example, the shop app here, we see a cache hit. And you see it just says replaying output. And that's where it really shines, because it just skipped them entirely. Admin was the same thing. It just skipped them entirely and just showed the outputs of the tasks here. We can even see them here, like for example, shopping lint, next lint, no yes lint warnings, and so on. It's basically the exact same output. If you have a task that generates the same output with the same input, then Turbo can cache. If this output is dynamic, then Turbo, it's a little bit more strict on that. But cool, we did the linting task here. I'm going to run the test task here as well. So pnpm test. By the way, I'm always referencing the top level package here. So I'm going to execute this one, tests, also using Turbo. So now, what we see here, it's a little bit different. Remember that I said that Turbo only looks for the dev key when I'm running dev commands? It's exactly the same for any task. So now I'm telling Turbo to run the test task across all the packages that they have a test command. In this case, I only have tests set up in my UI library. So that's why we see here just UI and then something else. But it also runs the build command here for the tests, for the UI library, right? So I didn't tell it to run the build, I just told it to run the tests. That's a little bit weird, right? But this is also leveraging something that Turbo requires you to do. The only thing that you need to do when you install Turbo in your monorepo is to create this file called turbo.json. And that's where the magic happens across your monorepo. This file is very simple. You don't have to change it so much, but you just have to understand this concept of pipelines. What are pipelines? Basically, pipelines is a way of you declaring in your monorepo how tasks depend on each other. That's how you make sure that, tell Turbo, hey, this task depends on this task, so please make sure that they run in the right sequence. If they don't have any dependencies, then just run them in parallel. So here, we have the dev command that I showed you before, and I have it declared here, and then it says cache false. This means that Turbo will never generate a cache, which means that you always want the fresh stuff, right? You're doing development, you don't care about the cache. Lint command, it's a little bit similar, but it doesn't have a cache false there. By default, cache is true. So basically, when you run a lint task, Turbo is going to cache that. It also says here, outputs, and it's an empty array, which means that this task doesn't generate anything. It just generates logs, but it doesn't generate any reports. Same thing goes for tests. There is no output here. It's an empty array, right? It doesn't generate anything. You could have your test generating a report, like, for example, some report that you push it to a different server to do analysis, like SonarQube, for example. But there is another one here called depends on, and that's a very interesting one. It says, look, whenever you run a test task, make sure that every dependency that I depend on, run the build command. And that's why there is a little caret here. This little caret says, do the build for my dependencies, and if I have a build task in myself as well, just do it. And if we look at the package.json file inside of our library, we'll see that we do have a build command, and we do have a test command here, right? So that's how Turbo knew that it should run the build command first. Cool, so let's run another task here. For example, where's my tab? Okay. Sorry about that. So let's run pnpn. Did I run the test? I did already, right? I did run my test again now, and I got a very fast output. And why is that? I mean, Turbo did this task already, right? So now we see here at the end that 2 tasks were executed successfully, and then two of them were cached. And it's a full turbo. Whenever you see a full turbo, you should be super happy, because basically you didn't waste any CPU cycles. The turbo repo just fetched all the caches and then just replayed the logs for you. Cool. Let's try to do the lint task here. Full turbo again, right? I have done this already in the past. I've shown you. Turbo is just caching. And now I'm going to do one thing. I'm going to remove those caches from my local machine. And Turbo caches it at the node modules.cache folder. I'm going to remove this folder. And now I'm going to run the lint again. Let's see what's going to happen. Let's see if the internet helps me. We should be able to see full turbo. It's taking forever. Yeah, this is wrong. Okay, I'm not sure if my internet is working. Okay, cool. Okay, it took a while. I think the internet was just slow. But why this was so slow? Because the internet was slow. But you see the full turbo again there? It's because it fetched the cache from my remote server. If you're using Vercel, you get this for free. It's super easy to do it. It's super cool. If you're not using Vercel, I have written my own distributed remote caching backend that you can use. It's open source. I'm going to share the link with you at the end. And this is running in DigitalOcean now just to demo this to you. And this is fetching from there. So you see full turbo there. Let's try the test again. npm test. Let's see. Hopefully it doesn't take forever. Yeah, that was fast. Okay, took 1 second. Full turbo again. It fetched all the cache. Now, let's go to the next level. I promised you that if you do cache once, you should share everywhere, right? So let me see my changes. Yeah, I'm going to commit those changes. And we will see if our CI runners will pick this up. So I'm going to just do, okay. Shit. Yeah, it's probably my, okay, yeah, now it should work. There we go. So let's push this to GitHub. And then let's see what's going to happen. I'm going to my repo here. That's the one that I shared with you in the QR code. It's going to be available to you anyway, so you don't have to worry about it. Let's see. I mean, I'm going to refresh this. And then I push straight to master. So there is a CI job running here, right? I'm going to check this. And this should be doing something. So in my CI here, I'm just running lint and test. I could have been running build as well, which is also something that's important for you to do. I didn't do it because it would take a little while. And then let's see what's happening here. There's a bunch of setup here to make sure that pnpn and node is installed. You don't have to worry about this. But let's see the checks. This is the one that I actually wrote. This is executing a command called pnpm-ci. And where this is coming from? This is coming from my package.json file, again, from the root library. And then it says CI, I have a turbo run, lint, and test. So this is how you tell Turbo to run multiple tasks as fast as possible, you know, as much as possible in parallel. That's how Turbo handles it. So Turbo is doing that here in my CI runner. And you see it run this task lint and test here. I'm not sure if it's easy to read. But you see all the output here, UI build, admin lint, UI test. But here at the end, we see full Turbo again, you see? So this is the magic. I'm sharing the cache that are generated locally in my machine with my CI runners and also with my coworkers. So imagine that you have like 30, 40 people working in your team. If they're all doing build, lint, test, and stuff locally, they're all sharing this cache with everyone else. And Turbo is just making sure that everyone is in sync. And that's pretty awesome. So that's pretty much what I want to show you. If there are 2 takeaways that you can take from this talk, is that Turbo is going to help you to scale your team. So if you have a mono repo and you have a big team, Turbo is going to help you to do that. And Turbo is going to make sure that all your teammates, they share the same cache and results. So this is how you actually really scale this, because then you don't do any recomputation, you don't waste CPU cycles. But that's it, that's my talk. Thank you very much, everyone.
Thank you, Bruno. I hope he has convinced you to do two things when you go back. First, move to a mono repo if you are not on it already, and then use turbo repo. Okay, so far we have had a pilot, then a police officer, so why stop there? Next, we have a physicist. You popularly know him as Sid. You might have seen him talking about pretty things like design systems, composability, good-looking APIs. This talk isn't about any of that. Like, this talk will actually trigger the perfectionist in you. You'll see some things ugly, and I'm not allowed to say more than that. He literally asked me yesterday that, can you go on stage and say, hey, next Sid. So I won't do that. I won't say anything more. And can we please welcome Sid with a huge round of applause? All the best.
React.
All right. Okay, so the introduction is very true. So I'm going to talk about things that you might not like, and I want to say that's okay. You can take some things, or you can reject all of it. Free country, kind of. So I'm going to talk about some code crimes that I have committed to get some good components API out of it. And first, let me ask by asking, when you think of like good user interfaces, what comes to mind? What makes a good user interface? So for me, it's the user interface should be intuitive. It should be consistent. If you learn how to use a pattern on one page, it should also work across another page, and it should be accessible for all sorts of users. And when we talk about code, we don't really talk about the same things, but I think with component APIs, the same rules kind of apply. A component API should be intuitive to read and author. It should be accessible to all sorts of users, and it should be consistent. So if you learn how to use a pattern in one place, you should be able to guess without looking at the docs too much. And to make that happen, sometimes you have to commit some crimes. So here are a few that I've done. So to start, let me just show you this component. Make it big. So we call this component anchored overlay. It's very creative because it's an overlay which gets anchored to something. It's called an anchored overlay. And it's a control component, so you have to do React useState and pass open and closed, and then handle on close and on open. And you have to pass a prop called render anchor. And this is like render props API were popular a few years ago, where you pass a function as a child, and it passes the props that you need to give through. So there's some inversion of control here, but the idea is there are a few props inside anchor props, things like ARIA labels, things like IDs to match the overlay, and most of these are things that you might not want to worry about because it's already handled. So you just pass it down to the anchor. Now, this component's cool, it's nice, and you can put whatever content you want inside of it. And one place that you might see this component is if you've used GitHub, you might be familiar with this pull request page, where this is kind of like an anchored overlay. You have an overlay which is anchored on this button. We're going to look at assignees. Here are some of my great teammates. And so if you want to create this component with anchored overlay, this is what it would look like. First, of course, we have to manage the state of it. So going to do a use state, going to add open close, kind of all boring stuff. And then when it comes to render anchor, I'm just importing the button also from the same component library. and you kind of get this default button, and passing down all the ARIA labels to it. I'm adding a trailing icon, so this is kind of like a design pattern thing where we want, how do you differentiate a button that takes you somewhere from a button that opens a menu in place? So there should be a trailing icon. The default is this triangle down icon, but you could also use something else, like a gear in this case, like GitHub uses gears here. And there's, of course, multiple variants. That doesn't matter. So when I look at this API, it's fine, but I wanted to create a more specific component just for this use case, because I feel like there's too much craft here that is extra work. So for starters, I think this should be called action menu, and don't worry too much about the name, because like it's a menu of actions and you can select one. So we call it an action menu, and then all of this, which is the state management, I think action menu should do it by default. And if you want to control it, you can, but you shouldn't have to do it all the time. Like by default, the component should be smart enough. So that goes away. And then this render anchor always annoys me a little, where if we already know that some props have to be passed down all the time, and the design pattern is that use a trailing icon, we should just do it on our own. So this trailing icon should also go away. And this is kind of what I like, where there's action menu and there's a button that comes with action menu, so you do action menu.button, and that takes care of the trailing icon, the accessibility, all of that. And then finally there's like a action menu overlay, because the overlay could also take some props, something like is the overlay small, big, and a bunch of other props. So if I want to make this component, what does the source look like? So the action menu, I'm just keeping the reference here. The action menu is kind of a boring component. As you can see, it doesn't really do anything of its own. It just renders the button and overlay. So I'm just saying pass down the children. There's menu button, which is slightly interesting because it has the trailing icon baked in. And then you see that it passes down props. So if you wanted to change the trailing icon, you could. It would just override the default one. And we map it to the action menu.button because components are functions, functions are objects, so you can just attach a component to another component and say action menu.button is actually this menu button, and you get this nice pretty API. Then we come to the menu overlay, which is this component, and this is the component that actually needs to use the anchored overlay that we discussed before and kind of hide all of that state management that somebody's got to do it. So anchor overlay is hidden over here. And there's something interesting here where there's open and closed state, which is boring, but then there's the render anchor. And you might have noticed that how does the overlay actually get the render anchor now? Because it's not passed to it, it's passed in the same component, I guess. There isn't really a clean, simple way of passing props between siblings in React. It's all top down. So the parent can pass things down, the children can call back and tell the parent stuff. But there's no sibling communication, and that's like by design, of course. So the documented React way of doing this would be pull state up. So in the action menu, which wraps both of these, I'm saying there's an anchor, there's a set anchor, I'm going to put this in state, I'm going to create a context that wraps all the children, I'm going to put both of these in, and then inside the button, I'm pulling menu context and saying if the anchor is not set, here is the anchor, which is the button. And I pass down all of the props, the accessibility props, kind of ugly, but everything works. And then in the menu overlay, you say use context, and you get the anchor that was set by the button. So we're doing the same thing where we pulled the component into state up, and then the child informs the parent informs the other child, kind of like you and your sibling are fighting and then you need an arbitrator, like your parents have come to like distribute the candy or whatever. So that's what we do here. And it mostly works, other than, okay, let me show you. So on client side, you probably wouldn't even notice, everything happens at once, it's all good. But if I have server side rendering, there's a tiny lag here, if you notice, and this kind of causes some jank. The reason for this tiny lag is when we're rendering this on the server, we don't really have the anchor because it's set to null. So the first render that happens, anchor isn't set yet. And by the time menu button actually gets to set the anchor and a re-render happens, you've already shipped that HTML to the client. So none of that happens until the JavaScript bundle arrives on the client, React hydrates, and then gets to call all of the set states. And that is when the hydration actually takes care of setting the anchor. So I've paused hydration here. If I click hydrate, I get that. So on the server, you get nothing because render anchor doesn't exist. When I hydrate, I get the thing. And that is also kind of fine as long as you don't have bad internet, because like with slow 3G, this is what you'd get. Like the button just doesn't come, it comes after a really long while. Imagine like all of these buttons behave the same way. That would be tragic. So how can we set the anchor on the server? Because that seems to be the problem, that we have to wait on the client because we're using this double render strategy where the parent has to first render the child and then the child can call the parent and then the parent can tell the other child. Like it requires 2 renders basically. How do we do that on the server? I'm going to give like a 5-second dramatic pause for like the mind story. The answer is crimes. So the way we do this is inside the action menu we say let's start with an anchor which is null, and then there's this top level API in React called react.children, and it lets you map through the children. This is usually to pass extra properties or check them, but something interesting here is that if you log child.type, it gives you the function that was used to create the component. So in this case, if it's action menu.button, action menu.button was actually created with menu button, so the type would return the function menu button, like just a reference to the button. So, which means you can do things like this, which is if child.type is menu button, now I have some access to the anchor. So I just say anchor is child. Like just take the child that was going to render, set it in my local variable, and then if it's menu overlay, then I clone the menu overlay and pass it the render anchor. Right? So this, it's kind of like, okay. The other thing that you also have to remember is that from the first child you have to render null, otherwise you'll get 2 buttons, one from the actual button, one from the render anchor. So this kind of feels like child kidnapping, like you kidnap a child, or maybe child trafficking. This is getting demonetized on YouTube now. So you kidnap the child and you pass it to the other person, the menu overlay here. And the best part about this is all of this is static. All of this has happened even before we've rendered anything from action menu. So we can statically go into children and their props, manipulate the API, and then render something once. And obviously this would work on the server, on the client. So we kind of bring that, we solve this problem pretty quickly. And then there are of course trade-offs here, which the first one is this has to happen in order. If you flip the order of like the overlay renders first and the button renders next, you wouldn't get it. And we have like warnings, etc. Like if you pass something else, it would just warn you that action menu only understands button and overlay. Those are the 2 components that are supported. If you give something else, don't do it, refer to the docs, etc. So is this a hack? If you think this is a hack, raise your hand. Wow, bunch of criminals out here. There were like 10 hands maybe. Absolutely yes, it's a hack. But is it a crime? Is it like a code crime? Like, is this a bad thing to do? 2 people, 3 people. I don't think I need to like give my talk. This is good. We're all on the same page. Also, yes, it's a crime, but sometimes crimes are okay. And the idea here is that hacks that make the code easier to read and author, that help developers do a good job faster within reasonable constraints of the system. So the constraints that we added here is that inside the action menu, you can only use the button and overlay from the same component library, and only then it will work. If you bring your own button, this wouldn't work. So it works for us because we're trying to build GitHub specific API from the component library. But I imagine something like Chakra UI cannot get away with this because you want to compose in different ways. You want to mix and match. So reasonable constraints of the system are the good point here. Okay, safe, deep breath. Okay, let's do more crimes now. So here's another component called navlist. It's a navigation list, and you give navlist.item to render something. And this is, you can see this in GitHub settings, where there's a long list of settings, and then you can have an icon, there's an href, all of these are links. So, and what did I do? Okay. Can I click this? No, I can't click this. Okay, that's not supposed to happen. Can I click this? Okay, I can click this, thank God. Okay, so the way we decide what page should be highlighted in the menu is using this ARIA variable called ARIA current. So if you're making a navigation with a bunch of links, the current link should have an ARIA current on it. In this case, it should be ARIA current is page, and you might do this with something like window.location, check that out, and that would set page. If it's server rendered, you might have a different way to do it with the router. And there's a bunch of settings, that's kind of boring. The interesting thing here is that when there are too many, we try to group them. And inside a group, if something is selected, that would show here. So when this is rendered from the server, like this, you want this group to be open. Because if this is what is rendered by the server, other than this slight bold effect, you wouldn't really see which page you're on. So it should be open by default. And that's kind of like a tiny attention to detail type of thing. And the way that works is also that you pass ARIA current on the item, and the group is smart enough to know that there's an item inside it, so it should open up. Now, how does this component work? There's nav list, which is kind of boring. It's a nav with a list, so it's a UL, and it renders all the children. There's nav item, which is also boring. Because it's in a UL, it has to be an LI, and then it renders a link component. The interesting one is nav group, because it's inside the UL, so it has to be an LI, and then it has a button. This is the button that you click. It has a leading icon that you can pass, and then there's another UL with all of the items. It's like a nested list. Now, we need to have a way of knowing if this list should be open or not. So I have like an open variable which gives a class name of open or closed, and then I need to set the values somehow. So when I'm clicking, I can say just like toggle, like a managing state, it's set by false, and then I can say when it's clicked, open, close, la la la, that's where the icon is set as well. But when I reload, I need a default value for this. The default value should be open in case one of the items has ARIA current on it. So one way to do this would be just ask the developer, like if you're using this API, just give me default open on the parent. But when you think about how would the developer using this do it, they'd probably also have to maintain a list. Like if any of these items inside match the location path name or match the router path name, then it should be open. And a good component shouldn't ask you to do annoying work. This is something that should just happen on its own. So I don't like that API, but it might work in some cases. So I want to do it by default, like it should just happen. And so how do we set this value automatically? And one way would be crimes, of course. And we just did the same crime earlier where we had React.children, we looped through them. If one of the child has ARIA current, it should be open, otherwise it should be cold. Easy peasy, we all go home. But remember I said hacks are within reasonable constraints of the system. The first thing when we started testing this out with other developers, the first thing we did was GitHub Docs uses Next.js. So they used a nav link and a router from that, which means the nesting is completely different because it's going to be a router link, like a custom component. And even the ARIA current is actually on the next link, not the nav list item. And this would be different for React router, for any other router, like all have their own different API. So we can't really rely, we can't really make assumptions on how links would be structured. And I've realized that there are two things that we have no control over. There's state management and there's navigation. And the less opinions we have, the better. So the reasonable constraint of the system is not reasonable at all, that the structure be the same. So back to the drawing board. We can't assume children, which means we also can't do the context thing with callback because it might not be a nav list item at all. It might be a next link. So we do different crimes. It's 2020. Women can do crimes as well. It's 2022. Wow, time size. Okay. So we create a container ref, and attach this ref on the group highest element of the group. And then when it renders with the layout effect, we're saying if container ref.query selector, good old JavaScript, has ARIA current. And this is fun because this would test nested across many levels. It doesn't matter how it's structured because it only matters how it's rendered. And this can be looked at somewhat of an anti-pattern because we're mixing declarative and imperative code together. But it works great. So there's that. And okay. So is this an anti-pattern? Absolutely, you already know. But is this a code crime? One hand, nice, 2 hands, 3 hands. It's the title of the talk. Of course, all of them are code crimes, right? So, but hear me out. The goal of a good component should be to abstract annoying work away, especially work that is not core to the user's goals or expertise. So in this case, the developer who's trying to make the settings page, the last thing they should think about is, how do I find out which group is open so that I can show the blue highlight? If I'm using a navigation list component, I would like if all of that is taken care of, right? And the other interesting thing is like the goals are, of course, all of this is distraction, but also the person working on it might be really good with like GraphQL and state management on showing this, but might not be very good at accessibility, so might miss the ARIA current or the right ARIA attributes. So the more we abstract away extra additional, especially like annoying work away from folks, the better. And this is kind of what we talk about user interface, right? It should be intuitive, simple, don't make the user think. There's books called Don't Make Me Think. I don't know. Your books. Okay. Fair? Deep breath? Okay, one last crime. So I like this. This is what we ship to production, by the way. The previous one and this is already on production. This is how it works. But there's one thing I don't like about it, which is if you have SSR, then the use layout effect, skip my slide, yeah. The use layout effect wouldn't again happen until the client hydration has already happened. So if I have SSR, I get this nice maybe bug, maybe feature where it opens up and it's kind of cool, I would keep it. And that's happening because of the same reason that we discussed earlier, that from the server, on server you don't know what's open, so this is how it loads, and then when the JavaScript bundles arrive, React hydrates itself, that's when the layout effect is called, and then it opens up. So the feature very quickly becomes a bug on something like 3G, where it would be closed by default, and you've already moved on reading something, and then the sidebar opens something. So there's a lot of distraction, and that's just like bad UI. So we need to figure out a default open, right? And we need to figure that thing out sooner. It doesn't necessarily have to be on the server, but it has to be sooner than the JavaScript bundle arriving and the hydration. Like that takes a while on slow internet. So there's an interesting crime here, and the guy has a key because this could be a potential security. Well, I don't know. Don't take advice on the internet. This is just try it out for yourself. And the interesting crime here that I want to show, let me get some like credibility for my hack. So this is Next.js docs, and there's something very interesting that happens here. So of course this is like the giant ID Next. This is where the entire app lives, and right next to this there's this script, and it's called Next. It has the ID Next data, and if you look at what's inside, it's just like a giant JSON. And the idea is that Next.js has to figure out a way of rendering on the server, and there's state on the server which needs to be passed to the client and carried on from here. So that you don't have to do it, Next.js has to do it, or if you're doing server rendering on your own, you need a way of passing server state to the client so that it can continue from there. And this is one way to do it. So there's data here, there's routes here, there's a bunch of things. But JSON is still fine. My favorite is this one. There's just some inline script which sets Google Analytics, and there's this one which applies redirects, which is really cool because if you apply redirects yourself, that's cool, but if you want Next.js to do it, Next.js doesn't have access to your Nginx router or whatever, like it's already too late. So if you want client redirects, they insert a script at the top, it runs async, and the moment something gets rendered, if they realize this is not the right page, then you get redirects. So That's justification of the crime, that other people are also doing it. It's not just me. And okay, so here's the crime. Would it be so bad if I put a script tag here, right? Like I could put this in the head, but then I have to remember which component has which thing here. It's nicer co-location. We've been through that before. So it's nice if it's co-located here. And the script that I want to run is that I want to create an ID, and there's a new API, react.useID, which gives you the same ID on the server and the client, so we can rely on it. I attach it to the LI, and now I have group element is document.getElementById, and then I can see, I can do a query selector, and if this has an ARIA current. So it's kind of the same code that we were running earlier, but it's running as an inline script. And the whole idea is that when the rest of this renders, it will also ship with this tiny script, and the script will evaluate as soon as the browser parses it, so it's a blocking script, and it's way before the rest of the bundle has arrived, because this is part of your HTML now, it's inline. So now when we do a slow 3G, that's not working because you can't actually do this. You have to do a dangerously, come on, you have to do a dangerously insert in our HTML, because you can't just put script tags in JSX, but you can put whatever you want in JSX if you just say, danger, I know what I'm doing. So that's where the check with your security team warning comes in. Depending on use case, this might be completely fine, this might bankrupt your company. You have been warned, this is not on me. So now when I reload on slow 3G, now that my script is working, you'd see that it always loads instantly. And now the feature bug problem is solved, because now I'm claiming this is always a feature, and I can remove the transition and then it's actually a feature, but I kind of started liking this now. So even on slow 3G, this works, and let me show you what happens after hydration. So this is the server output, this is already open, and when I hydrate, I get this, our favorite warning, that the expected output from the server did not match the expected output from the browser because we messed with React. And the fun thing about this is that I've always thought of it as the server output and the client output have to match, but that's not actually true. The output pre-hydration and post-hydration have to match. This warning comes from hydration. So it's not so much about what was on the server. Like React doesn't care about what server or what like stack it ran on. React cares about what was the initial output, and then when it tried to reconcile everything or hydrate everything, did it get the same matching thing? So if we're doing our own inline script, we just need to assist React in getting the same thing, which sounds exactly as bad, which is exactly as bad as it sounds. So the way to assist React in this case would be, I say type of document is, if it is not undefined, so this should only run on the client. Remember, we already have our server script over here, and then it's the same exact script. So I just say get document by ID, and I know that the ID is already rendered because that's what the server thing did, it attached the ID. So by the time this hydrates and runs, the ID would already be there, and then I'm doing the same exact thing. The interesting part is because I'm saying default open here, this happens on the first render on the client. And it matches exactly the output that was on the server. Not the server, pre-hydration, sorry. So before hydration and after hydration, it's the same exact thing. So now when I reload, I get the nice effect, and I hydrate, and it perfectly works because the pre-hydration and post-hydration output matched, React is happy, and this was only for the default state. Now React will take care of this, so all of this also keeps working. Now let me ask you again, is this a hack? Is this an hack? Is this a hack? Have I been... Is this an hack? Is this an hack away? But is this a code crime? Okay, a few hands, more hands. You all have way too much faith in speakers. There should be way more hands at this point. I'd say you decide, because we don't ship this, by the way. This is not on production yet. This is a proposal. I'm waiting for our security team to either fire me or say this can work. So we will, but it might be different for you. So, because it does work. And I don't know any security vulnerabilities. There's ways to make CSRF happy. make sure there's no injections that can happen, but you decide for yourself. But also, yes, it's a crime. So once again, the goal of a good component is to abstract annoying work away from the user, especially work that is not core to their goals. Like, none of this should be core to their goals. Imagine, like, if I'm not doing it, then the person who's working on the component has to do it, and there are no other ways to do it. They're probably going to do something similar, or worse, not do anything at all, and then you just end up with like a slightly bad user experience forever, because there's no React way of doing it, which is, I mean, anti-patterns are, there's a name for that because it's useful. So, final thought, a hack that makes code easier to read and author, helping developers do a good job quicker, within reasonable constraints of the system, are okay. So, sometimes crimes are okay. Thank you. This is where all of the code is, except the last one. I will not admit that I've written that, but the rest of it is on production. You can look at it at github/primer, and I'll see you on Twitter. Thanks.
Thank you, Sid. I think now I understand why you didn't want me to tell a lot to everyone. I hope the only takeaway from this is not that sometimes crimes are okay. But yeah, I think eventually it did make sense. Before moving on to the next talk, I'd like to give a shout out to Flight Control for being our diversity partner. And if you haven't taken your swag, so please go to the registration desk and take it. Okay, so our next talk is about something we all have a bit of opinion on. I won't say all of those opinions are informed. Blockchain and Web3 are still new technologies, and we are still learning it. Our next speaker, Vishwa Mehta, is a developer advocate at GraphQL Protocol Foundation. She will teach us as React developers how we can approach blockchain, how we can use it to create web applications that are easy to use. So since he's already here, can we just have a round of applause for her?
React India. React India. React India. React India. React. React India. React India. React. React India. 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 React. React India. React India. React India. React India.
I just had war flashbacks. I was at this huge conference in London in 2019, and I was preparing a talk right before my talk, like preparing my slides, and I was just like very anxious. I had 3 cups of coffee, and this happened, this exact thing with like the tech. I ended up pulling it off. So thank you so much. I think what makes a good presentation, what makes a good talk excellent is the audience. So thank you so much for your patience. And I'm super happy to be here. How's everyone doing? Good? That was lame. Can I hear you again? Awesome. So now that everyone is having fun and I'm here, I'm sure everyone at some point has come across terms like Web3, decentralization, blockchain, all of that jargon, right? So I'm here to talk about decentralized GraphQL APIs, a bunch of more jargon, basically. But just to break down some of these overly complicated terms and understand them in simpler ways, and also see how the Graph protocol, which is the company that I work for, is changing the whole data landscape. It is creating new ways, new standards for how developers like you and I can then access data, good quality data for our applications easily. The reason why I am very jittery today, so out of place, is because I've been having sleepless nights about this talk. I finished completing, like preparing my slides 1 or 2 weeks ago. I was feeling good about it. I've been doing this for over 2-3 years now, and this is what I do, basically. So the reason why I felt like an outcast at this conference is because decentralization, right? You folks must be thinking, like, why Web3? Why at a React conference? We're all literally on the beach. Stop boring me so much. So I wanted to think about ways that would relate to you folks, something that helps you in your journey as a React developer, right, without going too much into the nitty-gritties of blockchain and Web3 and decentralization. Just something that is to the point, crisp, and something that you can start using starting tomorrow. So I just want to start talking about this, like, with this story. I'm sure everyone has, at some point, has applied for the Twitter Developer API and failed because you wanted to build a side project which is fun, or you wanted to build something super valuable for the community, right? The sad story is that when the Twitter API was shut down, it affected so many businesses. So if you try to look at the list, it is heartbreaking. It were fun, goofy, cool side projects, but it was also not just that. It was businesses, both small and big, that were making actual difference, that were making a change, creating an impact on our communities. And so why I'm talking about this, I want to bring forward a fact, a very big pain point in a developer's life is data access. I've been working in the data landscape for a few years now. Started pretty early in my career. And I've just seen pain trying to access data, find data for your application that is in efficient ways. And I will share my own story. Like the Twitter API thing was, yeah, everyone knows that. But my own story, first-hand experience, was that in my final year of college, I did computer science, my bachelor's degree in computer science. And so my teammates and I, we built this deep learning model to make it easier for lung condition diagnosis, because the diagnosis period is very, very long. And the radiologists are very hard to come by. There are very few as opposed to the number of patients. So we wanted to bring a solution for people so that they can diagnose those kind of terminal diseases early on and seek better medication right after. And so you might think that this is definitely very valuable. The challenge that we faced was finding a data set to train our models. A data set that was open and public, accessible, but real and accurate. Now, I don't think, like we went to hospitals, we met doctors, they were ready to share information and knowledge, but not the actual data set of patients, because privacy reasons, right? Why am I talking about this again? Blockchain. The thing that I am very excited about is how blockchain and the whole the ethos of Web3 is built upon a few things like agency, which is basically owning your own data, creating and managing your own identity on the internet, just so that you can ensure that there is no central authority, there is no central organization that can one day shut down an API that your business was built on, or could just ban you or suspend your account from a very critical platform, or could, stop you from accessing the data that is very pivotal to your application. So that's where the agency and the permissionlessness comes from. So that's something that I'm excited about, and which is why I wanted to talk about it at this React conference. So long story short, that's where the decentralized GraphQL APIs come. And I think we're ready to begin with the actual talk. So, hi, I'm Vish. I'm a developer. I missed that part. But I'm Vish. I am a developer relations engineer at the Graph Foundation. And what that means is that I have a bag that I always have packed, and I get on a plane with it whenever my boss wants me to, wherever my boss wants me to. And I pretty much do what I'm doing right now. I talk about cool things at cool conferences, like on a beach, so that cool people like you can use these cool things to build other cool things. And one of these such cool things that I've recently started working on is the graph. Now, the graph is a Web3 indexing and querying protocol for accessing blockchain data. Now, I've thrown a bunch of jargon here, and I made it my life's mission to simplify things that I talk about. I always try to keep in mind, my brother is here, Raghav. He's a student, he's in third year of his college. So this is a hack that I use. Whenever I am delivering a talk, I make sure that everything that I talk about is understandable and consumable to him, is relatable to him. So that's why I'm going to keep that in mind. I was a student when I was at my first React conference in 2019, sitting right here, listening to talks like these. So want to take a step back and clarify a few concepts. So blockchain, let's start with the blockchain crash course. Distributed peer-to-peer network and a public ledger, a distributed public ledger. That is my best definition for what a blockchain is. Now, peer-to-peer network, again, more jargon. So what that means is that any participants on the blockchain are able to interact with each other, make transactions between each other without the involvement of any other third party. That's where the permissionless aspect of Web3 comes from. It's also a public ledger. So what that means is that it is this record-keeping mechanism, like a huge database of data about all of the network participants, their accounts, and their transaction history. So you can imagine the kind of data that would be then stored on the blockchain. So that's where the blockchain term comes from. It consists of, it is a network, it is a chain of interlinked blocks that then consist of transaction history of the network participants. Any takers for how many blocks are there on the Ethereum network, on the Ethereum blockchain? Think of the biggest number that you can think of. 2 what? 2 million? Higher? Can you think of a bigger number? 600 million? Lower. So you're kind of like in between you got the million right. So 15 million as of when I was creating this presentation, over 15 million blocks. And I'm just talking about blocks, not transactions. Transactions make up the blocks, so there are more transactions than there are blocks on the blockchain. So the reason why I'm saying this is because indexing this data is going to be super hard. Now let me talk about what indexing is, because that's also very pivotal to what the graph is trying to do right now. 15 million blocks and into the number of transactions that each block holds. Now imagine that you are an application developer, you want to build a React application, and you want your API to query data pertaining to your application and your use case from the blockchain. So for example, if you're building a DeFi application, of course you want DeFi related data and not NFT related data, right? Of course. So that means that you want some specific data which is organized, and the blockchain does not have organized data. It is in its raw form, it is not organized, and you're supposed to be indexing. So the main solution here then comes down to building your own indexing server as a developer. Without it, it does not make sense. It is impractical, very inefficient. Why you cannot build an indexing, or should not build rather, an indexing server as a developer is because it is centralized, has a single point of failure, to say the least, and it involves infrastructure that you need to manage, and it is not very cost efficient. So that's about indexing. The bottom line is that indexing is important, but is hard as a single developer. The next thing is querying using GraphQL. I've always been a fan of GraphQL and how it makes so many things easier for a developer to query data to their front-end client. And it comes with benefits like it's real-time. Sorry, I forgot to say this, but again, people who are new to GraphQL, how many people know about GraphQL? That's a lot more than the first time I asked this question. How many people actively use GraphQL? Wow, you guys are blowing me. Okay, cool. So that's good, that's good. Just a refresher for anyone who doesn't know about GraphQL is that it's a specification for how your API interacts with the database, like the data in your database, and queries it to your front end. So that was just a quick refresher. It is real time, it gives you the data that you want through a single endpoint in a single request, rather than making multiple requests for each kind of data that you need. And then using GraphQL, you can also create various kinds of queries on that data. For example, sorting, filtering, pagination, text search, multiple things like that. So that's about some of the core concepts that we will be talking about here. And now coming back to the graph. So I said that the graph is an indexing and querying protocol for the Web3, so that developers can access blockchain data. And the reason why the graph is super valuable is because while it does this, it is using GraphQL endpoint called subgraphs, and here is a good visualization of what subgraphs are and how the whole thing makes up a stack. Is that with subgraphs is the main API layer that sits between your UI layer and your data layer, which is basically your blockchain data. It forms this indexing layer, which is then like a unified data access layer. So just one single endpoint for all your blockchain data, and you can start hitting it. You can start hitting it with queries to get a response back to your client. And you can use something like Apollo client, Urkel, there's Graph client, and I'll talk a bit more about it in the end. And with that, Graph is quickly becoming a default part of the Web3 stack, and subgraphs are now becoming a Web3 standard. Now, whenever I talk about this, I often get this question, where does the graph come into picture? Like, I understand indexing, I understand, like blockchain data, blah, 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 blah. Why do I need an indexer? Why can I not do it again? So I want to elaborate on it. So the graph is the easiest way to query open decentralized data. And the reason why I say this is because in this data-driven world of ours, the applications that we build need, especially decentralized applications that developers build, need highly indexed data to perform well, to have a great UI UX. For example, DeFi apps depend on efficient indexing so that trade and exchange data is accurate and up to date. And if it's related to banking and payments and accounts, you don't want to mess that up. So of course you want data that is efficient and accurate. And the blockchain gets a large number of transactions per day. We took a stab at the number of blockchains, historical data of the number of blocks in the blockchain. So you can just imagine the number of transactions per day. So apps need indexed data for high performance, and it is becoming increasingly difficult for developers, individual developers like you and I, to find indexed data. Some developers build proprietary indexing servers, and I mentioned this briefly earlier that it is inefficient because it involves a lot of cost, hardware resources, engineering resources. It has a single point of failure, and in the end, it is centralized, which goes against the core ethos of Web3. So that's where the graph comes in. Blockchain without the graph is basically, in its raw form, it looks like this. It's kind of like finding your data, your specific data that pertains to your use case is like finding a needle in a haystack. Blockchains with the graph, it's kind of like this. Like all of the data sorted categorically. And this data can then look like DAO data, network analytics, wallets and payments, social, NFT, DeFi, communities, music, so much more. So yeah, the graph is a global open API. It is the easiest way to index and query blockchain data. It is also now a transparent and open network. Earlier, the graph started with a hosted service because we wanted to achieve product market fit. So it was centralized. We recently, and the hosted service has been supporting subgraphs for more than 4 years now. But we launched a decentralized network just last year. What that means is that there are different participants. So rather than just one company or one organization owning all of your subgraph data and managing your subgraphs that you've deployed on the hosted service, it is a network of participants, indexers, subgraph developers, curators, delegators, who manage all of this and the health of the network. So it is an open and transparent network. It is decentralized and robust, and all of that thanks to being built on GraphQL. It caters to a lot of use cases that include but aren't limited to things like NFT marketplaces, galleries and metaverses, music and video, social and comms platforms, and so much more. just a quick look into the things, the kind of applications that the graph powers is the websites like CoinGecko and CoinMarketCap, if you've heard about it. There are other use cases like NFTs and DAOs. So for that, there's Foundation and Juicebox DAO. Uniswap and Synthetics are super popular DeFi applications, complex applications that are running and powered by the graph. The graph has been supporting creators across 39 chains, and we are going live on more and more over the next few months. That's on the roadmap, and this excites me a lot. So let's see some code, and for that I would need someone's help. And I would love to build a subgraph here because it literally takes 15 minutes. But I don't want to bore everyone to death. I do have a lot of workshops that I do. So you can catch the next one live, or you can watch back to another one that I have already pre-recorded for other hackathons. So I'll just walk through the code for you guys. You can just close the notes. And give me a minute, please. So I just need to close this, right? I will close this. And okay, cool. I think everyone can see this. And this, yes, awesome. Sorry? Yes? Awesome. So this is the graph website. You can go to thegraph.com, and this is what you see. If you go to products in the navigation and then navigate to Subgraph Studio, it will take you to this GUI sort of thing, like a dashboard where you can create and manage your subgraphs along with your API keys. And essentially, like, I don't want to intimidate you guys, like essentially this is a GraphQL API that you're building on top of blockchain data. So instead of using data from, let's say, MySQL or Oracle or something like that, this is, you'll be using data from a smart contract and listening to the events. Again, events. Blockchain is made up of like state. So you want to make sure that you are listening to the, you're getting the freshest state and not stale data. Because this state is basically transaction history and the latest state for the users, the network participants. So that's where the events come in. You listen to these events to make sure that you're getting the latest data. So you literally just built a GraphQL API pointed towards a smart contract so that it can start indexing data from that smart contract and then query it to your front end. It is chain agnostic, meaning it can be built for Ethereum, for Near, for Solana, anything. So I will go to this subgraph that I built earlier, which is called Zora NFT. There's this like NFT marketplace with all of the tokens there. And if you build a subgraph for it, it has a couple of events, like transfer event, which gives you all of the data for the tokens that have been transferred from one user to another, or URI updated event, which basically means that once you start indexing that smart contract through your subgraph, it will give you all of the data about all of the token URIs that have been updated in the past. And here is the subgraph. So this is what the folder structure looks like. I'll start with the easiest thing, which is subgraph.yaml. This is your typical YAML file. It describes the configuration of your subgraph. So when you're building a subgraph, you make a couple of quick changes, like, which kind of network are you building for, which is Ethereum. It could be anything else, like Solana or Near or Avalanche. Your token name, here it's specifically token, and this is something that you can get from the Zora NFT marketplace docs. So any other smart contract that you're using, you should be able to get this information, this field, from their documentation. The network you're using is mainnet. Some of these things, if you are not very familiar with the concept of like how Web3 is, like how the blockchain works, these terms might be new to you, but don't fret it. You can always go to the Ethereum documentation and the Graph documentation to familiarize yourself with this jargon. And then the main part is this address right here. This address is the address to the smart contract. So you can imagine, you can visualize this in a way that it's, that is close to how you deal with data right now. So it's kind of like pointing to a table on a database in the Web2 world, but in Web3 it's typically like a smart contract that has data. So it is addressed to that smart contract, and you're pointing your GraphQL API to that smart contract to start querying data from it. And then you define entities here that you then want to further define in your GraphQL schema. So I have token and user, which is basically the token data and the user metadata. Token is the NFTs from the marketplace, and then event handlers. So I mentioned events that we want to listen to get the latest state from the blockchain in the smart contract. So whenever you start listening to these events, you want to define these resolvers, like these functions called event handlers that will then handle, that will then like run some sort of business logic that you've implemented when the subgraph starts listening to these events. And so that is token URI updated and transferred, these just like typical events for any token. The next exciting thing here is the GraphQL schema. So if you've worked with GraphQL before, this should look familiar to you. It's basically, we're defining types, and here we're using the entity type to define top level fields for the kind of data that we want our subgraph to query from the smart contract. And since it's an NFT smart contract, it's things like ID, the NFT ID, the link to that particular NFT on the internet, the metadata link, created at timestamp, so like when was the NFT created, the creator of the NFT, this is like with the user object defined using that. There's also a creator and an owner. So when we define the type user, which is the user metadata, we will be defining relationships between the tokens and the owners, like the owners who own these tokens and the creators who have created these tokens. So we are using the derived from directive here, which is also very specific to GraphQL. Basically, rather than using an array, this makes it a lot more performance efficient. So that's about the GraphQL schema. Just to recap a little bit, we took a look at the YAML file, and then which is the configuration, and then the GraphQL schema is basically all of the types that you're defining for the data that you want your subgraph to query from the smart contract. And the last and the most important thing is the mappings.ts file. Now, TS, again, something that is familiar to you and is relatable. We use something called assembly script for subgraphs, and this is specific to Solidity developers. So if you've used TypeScript before, assembly script should be familiar to you. And the Graph CLI, once you install it, it comes with a TypeScript library out of the box that lets you write strongly typed functions here that can then let you map your event handlers to the events that are happening on the smart contract, that are emitted by the smart contract. And so I've just written a few resolvers here that will then be implemented. It's just some business logic that I want to run once my subgraph starts listening. And then I deploy. So the commands that you'll be using, going back to the subgraph dashboard, just a couple of quick commands. The first one is the one that you can use to install the Graph CLI, very nifty thing. It gives you a couple of utility commands that you can use to manage, like build, design, manage, deploy your subgraph. The init command, graph init command, is to initialize some boilerplate code. So once you run this, it will scaffold your subgraph for you and give you some bare bones boilerplate code that you can get started with without being intimidated about like, what the heck is this? And finally, it is auth and deploy. So you authenticate your API just like any other API using a deploy key and connect it to your subgraph dashboard right here from your local environment. And once that's done, you copy and run this command, which is GraphQL command. It generates the TypeScript library out of the box that I talked about earlier. And the final step here would be the graph deploy command. Graph deploy Studio Zora NFT. Zora NFT is the slug for my subgraph, and Studio is basically, the Studio flag is basically to let the CLI know that I'm using the subgraph Studio. And once that's done, it should deploy your subgraph on the Graph Explorer, which is the decentralized network. And you can also start testing the query. You can run an example query here. I'm going to do it, hit play, and it will give a response to my request with all of the data that I asked for. This is basically the first data for the first 5 tokens and the first 5 users from the NFT smart contract. And when you want to start querying using this subgraph, you can connect it to your front end using this development query URL. So that is about subgraphs. And yeah, if you want to get involved, want to join the Web3 movement, first thing is to follow me on Twitter and come talk to me. But you can also go to the official website, just explore a bit there. Go to our docs, which is thegraph.com/docs. Follow the Graph Protocol on Twitter. We post a lot of links to the upcoming workshops, events that we're doing, bounties and grants programs that we have, like these extensive grants programs that help developers get started and also fund their projects that they're working on, and Discord for support and community engagement. Thank you so much.
Thank you, Vishwa. It's good to hear some things about terms that used to be jargons for me, and at least see code and concepts like blockchain at the same time makes it a bit easier to understand things. We are moving on to our next talk. It's about concurrency. Our next speaker is actually a former iOS developer. He'll be talking about the internals of concurrency and its use cases. He'll also talk about how React is affecting the future of web, how to create abstractions, and why you should measure things before taking a decision. So can we please give a big round of applause for Matthias?
React.
All the best.
React India. React India. React.
Can you? Cool. Yeah. Can everyone hear me? Great. So, hello everyone. It's great to be here in React India. It's my first time here, and I can't complain about anything. I'm loving everything so far. Yeah, and as they said, I'm here to talk about deep diving on Concurrent React. I'm pretty sure many of you watched Teja's talk earlier today and really loved it. I did love it as well, and it's even harder to follow up on that. But let me try it. So this is me. I'm Mateus. As you can find me as Y Combinator literally everywhere. I'm a senior software engineer at Medallia, and I also mentor people on front end at Tech Labs. Before we start, I do have a couple disclaimers. So the first one is we're going to be talking about React, and the source code of React, it changes a lot over time. And some things are complicated to read and etc. So some of the thoughts you're going to see here are speculations. And the second thing is sometimes it might sound a lot of information. So if you ever feel lost, look for this emoji. Then it means we can have further discussions about the topic after the session. So a little bit of why we're here and the why's behind of the session. So couple months ago, I had my last session about React, and it was called Inside Fibers. And we got to talk a lot of interesting stuff that I love, like fibers, coroutines, generators in JavaScript, and algebraic effects. But at the same time, I felt like I needed to talk about other stuff. I wanted to talk more about virtual DOM. That is one of the key things behind React. I also wanted to talk more about concurrency and parallelism. And we always should talk about Concurrent React, right? And last but not least, measurement. So we always hear a lot about Concurrent React, but we don't talk a lot about how to measure that or when it's actually necessary or not. So let's start from the beginning. So if we were to build a new library, just like React, Angular, etc., which ways we could go, right? So we could work with DOM reconciliation. That's, for example, what Angular, Polymer, Blitz HTML, that's what they do. We have virtual DOM that we know very well from React, from Vue, or from Inferno, or many others within this ecosystem. And we have also reactivity. That is the thing that everyone is talking about. So we had Svelte, and then we now have Solid that's really popular. And a couple years ago, we even had Knockout doing reactive approaches. Focusing a bit on virtual DOM, so React, Vue, and Inferno. I don't know if you have managed to watch, but there's this session by Pete Hunt. He used to be core team of React, and this session was like almost a decade ago. And there's many interesting stuff, but one of them is he said that with React, we can build applications without even thinking about performance because the default state is fast. And this was back in 2013, and it actually made sense. It's not that he was wrong. But the point is, back to virtual DOM. We know that virtual DOM works by generating a virtual tree, and then you diff against the previous iteration. And once you have this diff, you patch the DOM updates. And we use a lot of immutability and referential equality to optimize this whole process, because in the end, we are still doing trees. But this results in a lot of cloning, and because you have a lot of cloning, you have a lot of memory allocation. And that's not the only thing. Throughout the history of React, we've seen some perf issues, and that's why we have perf mitigators. So when we were doing classes, we first had should component update and pure component. I'm pretty sure some of you remember that, right? And then we had function components, and we had React.memo that was pretty much the same thing, but for this. And then, in the age of hooks, we had use memo and use callback. And then, with the new concurrent features and etc., we got new hooks. So we got use transition, use deferred value. We got also suspense, as we saw in Tisha's talks, and we got many other stuff. So these mitigators, they kind of have a reason. And the reason is React doesn't actually know what's, it doesn't have an idea of the flow of the values through our app. And that's why we can say it's not reactive. And that's pretty ironically, and it's actually been kind of a joke in the community for a couple of years now. And it's pretty much in this scenario that guys like Svelte and Solid came. And concurrency, reactivity itself has a lot of interesting ideas, and I love it, but we are here for React and virtual DOM, right? And we can see nowadays is that for most of the scenarios, virtual DOM has been optimized well enough. And it doesn't necessarily have to be React. We don't see a lot of people complaining about performance in Inferno or how Virtual DOM increases the bundle size of a Preact app. And there are libraries that they do Virtual DOM that can get even smaller results like HyperApp. So the thing about Virtual DOM is it's just one of the approaches we have to build a UI library. And it has drawbacks, but it has like the good things. And it's never a true or false question. And the reason why I'm saying that is because understanding the key takeaways from Virtual DOM is really helpful for us to see where Concurrent React fits in. So this brings the question, why do we even bother discussing that? What we even care? So if I had to go with one word, performance. So we are very used to seeing like especially runtime responsiveness and smoothness associated to Concurrent React. So we talk a lot about how it helps like with the flow, with the good user interactions, and maintaining a good frame rate, and etc. But the thing is, Concurrent React can help you in 4 different aspects of your app, and that's why we're here today. And I'd love to start with the classics. So in this very simple example, I do have some input fields, and I have links, I have like tasks, checkbox, and etc. And what I'm going to do is I'm going to virtually block the main thread. And because it's blocked and the browser is single-threaded, we have bad experience. And this is called mostly because of long tasks. These red signs that we see every time we are inspecting that kind of thing. And even though this was a virtual example, it happens a lot out there. And that's because of that we have metrics like first input delay and many others to track that. Because these things are happening in production for real users in real apps. And there are even studies about that. So there's this one from the last year, for example, that they showed that the slow first input delay happens 7 times more on mobile devices. And it's even worse when you get to visualize that. So you see how it's like for desktop, and then you see the huge yellow and red parts of the chart for mobile users. And of course, this does bring business outcomes. So the first thing is long tasks, they delay the time to interactive. But not only that, because of this, the overall conversion rates decrease. And in mobile, these long tasks, they are 12 times longer, so they're even worse. And it's terrible because old devices could be spending half of the time they have in their load time on long tasks. And if it sounds like really bad, it's even worse when you see a chart of how this affects your business. So that's why we bother discussing Concurrent React. And to move on with this session, I'd love to have the help of you. So I have this one question. By watching the previous talk and from everything you heard about Concurrent React now, if you had to summarize in one word or one expression, what would be your take? For example, if I had to summarize fibers in one expression, that would be units of work. So to help me with this question, I have this QR code, which I would love to have you scanning and telling me your answers. And wait for it. I got a timer here, so please allow rush. And to show you how much I would appreciate to have your help to answer me this, the first 3 people who answer that, I'm going to be giving discount codes for React Brussels. And everyone else, I got tons of stickers over there. So I really hope I can buy you stickers. I could be. So yeah, let's give it like another 30 seconds. I really hope this is working out for you, the QR code. Yeah. One word, one expression, Concurrent React. Yep. It's funny how a minute takes long when you're not saying a lot of stuff, so I'm kind of trying to. Okay, 8, 7, 6, I don't see anyone with the phones. Let's skip it. So before we get to an answer, let's talk about the main thread. So to talk about the main thread, we got to talk about units or about tasks first. So what we know about a task is it's a unit of work that the browser does to render a single frame. And this includes all the 5 steps of doing JavaScript, the layouts and styles and layout, and then paint and composite phases. And this is like what we usually see when we are studying a browser under the hood. And basically, a long task, as you might imagine, it's a task that takes more than 50 milliseconds, because that's when input starts to feel delayed. And this is not a magic number. This is based on a model called Rail. This is a user-centric model. And the other bad thing about long tasks is that not only they take long, as the name suggests, but they also block other tasks. So I guess one of the questions we should be asking is how to avoid blocking the main thread. So for this, we got a couple task running strategies. So we have parallelism, that is when we have multiple threads. So we have multiple tasks at the same times in different CPU cores. We also have concurrency, so we have only one thread, but we are able to quickly switch between these tasks so that it feels concurrent. And then we have scheduling, that is when we have concurrency, but we have a tool called a scheduler on top of that, assigning different priorities to different tasks. So it's better if we visualize that. So let's assume we have tasks A, B, C, D. If we're doing parallelism, we could split them like that. 2 per thread. In concurrency, they would look like this. And scheduling, pretty much the same, but you're going to see that some of them got higher priorities than the others. So to talk about concurrent React, it's good that we talk about parallelism first. And parallelism in the browser comes as workers. So workers, they're very different from threads in C++ or Java if we are used to them. And this happens because we don't have access to variables or any code actually from the page that created them, and vice versa. Oops. And because of that, data exchange happens via message passing. So if you've done workers before, you know what I'm talking about. And by the way, tomorrow is going to be a great talk about workers. But one of the things they have is they don't have access to the DOM. And because of that, making UI updates is almost impossible. And apps that want to use workers, they kind of have to adapt their architecture to this model so that they can kind of overcome the limitations of workers. Another thing is we have 2 models for doing workers. We have actors that we might have heard from other ecosystems like Erlang and Elixir, and we have shared memory. So basically, actors, they may run on a separate or on a different thread, and each actor fully owns the data it is operating on. Actors, they can also, not also, but they can only send and receive messages. And if we were to talk about a browser, it's like the main thread we have is the actor that fully owns the DOM and the UI. The other thing about actors is every message we send, it needs to be copied so that it works. So if you've done workers, you know that. And we end up having to balance, okay, we want to move code to a worker so that we can optimize and offload the main thread, but at the same time, we have this communication overhead. And also, we have to handle, for example, if that worker is not busy handling something else that it got from somewhere else. And the last thing is that post message, that is the method we have, is a fire and forget mechanism. So there's nothing out of the box that allows you to, for example, track requests and response, and if something failed, for example. The other thing is the shared memory. So in the browser, it happens with the shared array buffer. That is the only dedicated type we have for that. And basically, that's a linear chunk of memory that we can manipulate that with these 2 guys, typed arrays and data views. And the amazing thing is, if you send one of these via post message, the other end is going to get a handle to the exact same part of the memory. So that's cool. But we are in the browser. We are in a place where most of the APIs were built with no concurrency in mind, no concurrent access to the objects. And if you've done concurrency in other ecosystems, you know that this is critical. So you end up having to build your own mutexes and other data structures that are prepared for handling that kind of thing. Not only that, we don't have a direct way of doing arrays, objects, and the things we are used to. All we have is a series of bytes that we have to build abstractions on top of them. Last but not least, you might be thinking, okay, what about WebAssembly? So, oops. What about WebAssembly? So that's a pretty good case where we have workers and the shared memory, shared array buffers, and we get a threading model similar to what we would have in C++, for example. And to be honest, nowadays, I would say that's the best experience for the shared memory model. But it's usually faster than JS when you stay within WASM. But the first moment you got to do something that has to do with updating the DOM or manipulating something in the main thread and things like that, then you start realizing that it's not as fast as you expected to. And there are many talks and benchmarks about that, by the way, out there. So we come to realize that JavaScript is actually faster at doing DOM rendering in a lot of times. And the high-level libraries you have, like React, Svelte, whatever, sometimes, for some scenarios, they can be faster than the fastest low-level abstractions in the WASM. And last but not least, you still don't have the benefits and comfort of writing JavaScript. Before we move forward, it is important to highlight that there's a lot of work happening on that to improve all of these aspects I mentioned. So we have the atomics type that's moving fast. We have open source libraries like Buffer, Bake the Object. We have Comlink by Google Chrome that is like a really good abstraction on top of workers that makes using workers really smooth. And we even have WorkerDOM also by Google that's also a way of making UI changes from inside a worker that makes it possible. So to wrap up, I'm sorry you were taking a picture. To wrap up, workers are really good for data processing or when you have to crunch numbers and do heavy stuff with that. But they end up being hard when you got to do UI-related stuff. And it's harder than adjusting what you got to do for a scheduler. And this takes us to the other two things we had. And this takes us back to the question I asked in the beginning. So I really hope this is going to work. And I really hope I'll be able to fetch your answers. But if I'm not, that's weird. I can see them on my screen. I don't know why it's not rendering here. But yeah, the first word was fast. And then we had parallel, response, and suspense. But the winner was fast. I'm going to present to you my take on that. So if I had to go with one word, that would be scheduling. So, and to talk about scheduling in React, I have this piece of code. So we have a function that's called resourceful operation. I hope the code is not too small. And this is basically to mimic any CPU-bound operation. And in this scenario, I'm iterating up to 1,000,000. And then in my React component, I'm using this function. And you can see that as I start typing on the right, it takes me like quite some time to get it rendered on the left. And then it starts to getting laggy, and then Chrome stops working. So that's really poor user experience. And we might think, how can we prove that? So to start with that, who here has seen Redux Saga or ever worked with that? Whoa, that's pretty. So you all know that it was one of the most popular, maybe it still is, one of the most popular Redux middlewares a couple years ago. And there's one of the things I love about it is how they use generator functions to do concurrency, parallelism, handle cancellation, race conditions, and etc. So getting some inspiration from Saga, this is the original code we had. Let's change it a bit. And what we changed is now our heavy function is a generator, and we are yielding execution back to the main thread right in the beginning. And we have this scheduler object, and we are doing some concurrent tasks with this scheduler object. We're going to talk about it in a minute. So let's see the results. So you can see that first, it is suspense ready. so the user is never in the dark. They can see that there is some heavy operation going on. And the second thing is the input is never janky. So I can type, and it's still responsive. And I don't have, the long tasks are not making the user experience bad anymore. And this is the full code for that scheduler we talked about. And the most important part is this perform unit of work section, where basically we are switching on 3 different states: idle, pending, and done. And the key things we are using is, first, we are throwing promises, just like Tejas was doing earlier today. And we are using the next method from our iterator to do that. So it might sound a lot like we just used transitioned. If we get back to the original code and we change that, yeah, this could be a transition. So yes, we just did use transition, but with the own scheduler we built in 40 lines using generators. So talking about scheduling in React, now that we know there's no parallelism, there's no workers, was, or anything like that, what we do have, though, is this multitasking model that's cooperative, and we have a single interruptible rendering thread. And because of that, rendering can be interleaved with other browser tasks, including React renders. And because of that, an update can happen in the background without blocking what's going to happen. The response to the new input, for example, and then React is able to resume the execution. So to visualize, it's like that. So we had the original render task, then I started typing, so that was my user input, and the browser has to enter in the input field what I'm typing. So that was the higher priority thing. And then after I stopped typing, React can resume the original render task. And there are a few key things about that. And one of them is that it yields execution back to the main thread after 5 milliseconds. And I know it sounds, again, a lot like a magic number, just like those we use in CSS to make things work. But the key thing is that it's smaller than a single frame, even when you are in 120 FPS devices. So that's what makes that in practice rendering is interruptible. Another amazing thing about the source of that are the priority levels. So inside the scheduler of React, we're going to see these 5 different priority levels. And the same thing we see in the scheduler, we see throughout the rest of the framework. So we see them inside React Reconciler. We see them inside React Done and other React renderers. And we see them inside the DevTools, for example. So that's how important priorities and scheduling are. And basically, these different levels, they range from immediate to idle, and they have different timeouts, as you can see. And this basically tells React when it has to do something, ranging from, OK, this needs to happen like right now, to, OK, do it whenever you can. And another amazing thing that's also mind-blowing are render lanes. So they're an abstraction built around bit masks. So basically, 1 lane equals to 1 bit in a bit mask. And each update in React is associated to one of those render lanes. And one render, as opposed to an update, can be associated to 1 or more lanes. And as you might imagine, updates in the same render lane are batched together. Updates in different lanes are batched separately. And first, this abstraction gives us 31 levels of granularity, because that's what we have in a bit mask. But the other tricky thing, or the good thing, is that it allows us to choose whether to render multiple transitions in a single batch or to render them independently. So that's the magic under the hood of Concurrent React. And this whole thing reduces the overhead of multiple operations, like multiple layout passes, multiple recalculations of style, and multiple paints to the browser. And I myself, when I figured out about the different priorities and the different lanes and etc., I was like this, like really mind-blowing. But there's this session by Kites, and it's called But You're Not Facebook. So we are not Facebook. We are not writing schedulers on a daily basis. We are just writing components, or we are writing divs enabled by DevOps guys. So how do we benefit from these in our everyday projects, from the scheduler, from all of these things? And this takes us to scheduling in React for the rest of us. So there are a couple scenarios that I see that this can be really helpful. So the first one, and maybe the most obvious one, is when we have to handle large sets of data. So most of the examples we see out there, and even the example I did in the beginning was really non-practical because we're not iterating up to 1 million in our components. We are not trying to find prime numbers. We are not trying to run some heavy crack password algorithm or draw fractals. But what we usually do, though, is we usually render many data points on a dashboard. We usually try to render things on a canvas, and we don't have off-screen canvas because it's not available in all of the browsers. And we usually have to process some data on the front end. So one good example for that would be, so this is a dashboard that basically calculates the number of people who visited some app each day. And you can see that I should be able to filter by data. But the thing is, it's really lagging a bit. It's not like the first example, like that was almost crashing my Chrome, but still the animation is janky and the response to the user is not immediately. And this is the whole code for that. So we not magic. Use a state and use a fact to populate some data, and then we pass that to the dashboard component. Let's see what happens if we just change that to a transition. So in the very beginning, so you can see that I can move. And I'm filtering data. The records are still changing after I've done that, but the animation is smooth all the time, and there's no long task running in Chrome. There's no running task making any harm in a mobile device. And I myself, when I saw transitions, I was like, I wish I could go back in time to some scenarios where I needed them. The first one was this app I was working where we had the maps, and we had 100,000 data points plotted to that map. And back then, we used workers, Redux Saga, and some debouncing techniques to allow proper searching and filtering that data, but we could have used transitions. And also, this one was 3 years ago. I was watching, I was developing this football game where users could chat at the same time. And there's an admin panel that you had thousands of users sending thousands of messages, and the admin should be able to search them, to query them, and that kind of stuff. And back then, we had to do virtualization and memorize basically everything. But actually, if we just had transitions, things could have been better. The second thing is tackling wasted renders. So just use sync external store hook. It's, who has heard of it? Oh, yeah, quite a few. So it's a quite simple one. It has 3 parameters, and it was also introduced in React 18. And actually, when it was out there, there are a lot of posts like how you can use it to improve your state handling library or something like that. And there was even talks about that. And even some libraries, like Vaultio, they switched to using that. And Redux, starting in V8, was also using that. So still, we think, how can we use that in our everyday projects? We are not maintainers of Redux. So we are using React Router here, right? So I guess many of us. So React Router has this use location hook, and it gives us information about the hash and the path name. But it's what we call as an over-returning hook. So even though my component only needs the path name, I'm still going to get the hash and other stuff, and vice versa. And the thing that impacts the performance is, you can see here, I'm clicking the components, and I'm changing the hash of the page, but the component using the path name is still re-rendering. So we could change that by using, instead of that one, using use history and use sync external store. And now we can kind of create our own selectors inside the history object. And with that, we can see the results, and now only the hash object is re-rendering as it is supposed to. So no re-renders in path name. The other thing are hydration improvements. So before React 18, we could only, the whole process of hydration could only begin after the entire data was fetched and rendered. And because of that, users couldn't interact with the page until it was fully complete. And the bad thing is that parts of the app that loaded faster would have to wait for parts of the app that were slower so that you could have the full hydration. with React and 18 and concurrency, you can have selective hydration, and you can wrap your server-side rendered code with suspense. And in this example, articles is going to be streamed, and it's going to start running comments, and then comments is streamed after. So React won't wait for that component to load to continue streaming HTML for the rest of the page. And the great thing is when that one part of HTML becomes available, it will be added to the same string, and it will become a script tag that's placed in the right place. So also because of Concurrent React, React is going to prioritize hydrating the parts that the users interacted first before the rest. And the whole result is components can become interactive faster. And because of that, you have better first input delay and better interaction to next page. That is also another really important metric. And there are even case studies out there. Verso, for example, they use that to improve the performance of the Next.js web page. Last one, profiler. Oops, I'm always clicking the wrong one. Last one, profiler enhancements. So the new profiler for React 18, it allows you to inspect transitions. So that's really good, because if some people are using transitions, but they don't have the right tools to profile them. So now you can profile them, because we're not only writing code, we also need to debug it, right? And it has utilities, for example, to detect when there are some other parts of the code that are blocking your renders. And it even has warns to tell you, hey, this could be moved into a transition. So you have a long task here that's poor, that's making your experience poor, move that to a transition. So that's amazing. It's not fair to talk about scheduling in React and not talk about scheduling on the web. So on the web, we might be thinking throughout the whole time, we have things for scheduling in the browser. So yeah, we have scheduling primitives. We have set timeout and set immediate. We have request animation frame and request idle callback. Probably some of you even used that in the past. And we have post message for workers that they are a way of scheduling. But we also have some problems on the web. And the first one is that everyone should be using the same scheduler. So if React has its own scheduler, and then Angular, and then Svelte, and then some maps, for example, Google Maps, they have their own scheduler for the app. So everyone should be using the same scheduler, because if not, if you have more than one schedulers, then you might end up with resource fighting. And that's something that you can even happen in your app if you, for example, poorly using your Redux sagas. So not only that, everything should be interleaving with the browser work, like rendering, garbage collection for JavaScript, and etc. So it turns out that we do need better and more uniform primitives for scheduling in the web. Like the ones we have now, sometimes they are unpredictable, they don't work in a cooperated way, and etc. And people out there are aware of that. And that's why we have the prioritized task scheduling API that's being cooked up. And it's amazing. I would definitely recommend you to check it out. And it's supposed to be like a better solution for scheduling tasks. And the difference is it's integrated directly in the event loop. So it's going to be like native scheduling. And this allows you, as making my point, this allows you to control and schedule tasks in a united and flexible way. And another amazing thing is that it's pretty aligned with the React core team and with the core team of other frameworks like Polymer, with other teams at Google, and with the web standards community. There's an amazing talk about that by Jason and Shubi Paniker. I would recommend you to check it out as well. And to basically summarize this API, these are my 4 favorite parts of the API. We have yield that, as the name suggests, allow you to yield back to event loop. We have post tasks to control and prioritize tasks. We have wait and is input pending. Going quite briefly through them. So post task looks like this, and you can, for example, add delays and etc. And it's promise based. And you can come up with a lot of interesting scenarios where you define different priorities, like for example, whether it can be in the background or whether it's user blocking. And because you have signals, you can change the priority, or you can get information about that, you can abort some tasks, and etc. Is input pending basically allows you to stop doing something if the browser is processing input, and you can even filter the kinds of inputs you're going to listen for. And yield, as the name suggests, allows you, it's a promise-based API that allows you to switch to yield back to the event loop. And you can even combine with as input pending, for example, because if it's not, then you can continue. And there are many great stuff out there. Airbnb, for example, is using some of these APIs, the ones that are available to be used. Facebook was a huge contributor for the is input pending one. And there are even libraries like Manfred scheduling that kind of mimic the yield spec, for example. So people are already doing great stuff with that. So to recap scheduling, it is an alternative for responsive user interfaces. We have a web proposal that's on the way. There's going to be like a more united way and a more stabilized way to do scheduling. But in the meantime, we can solve a lot at the framework level or at the application level with Concurrent React and its scheduler. And before we move forward, it's always important to remember that there is no silver bullet. So sometimes code that you use too often can also cause some overhead, and this total overhead might have a bad influence in your app. So scheduling does have bad parts. So the whole process of detection and scheduling have an overhead. Also, scheduling is about splitting chunks of work and assigning priorities. And sometimes it's difficult to find the right amount of chunk that's going to fit all the devices, because every device has different specs. Also, partially complete interfaces can increase the cost of layout and paint, and it can even result in issues like tearing. That is why we have used Sync External Store. And in the end, it's hard to find the right spot between performance and amount of blocking. So, and the fact that we have the no silver bullet thing for parallelism and for concurrency and scheduling takes us to talking about measurement. So it's always important to remember how measurement is important. And we have great tools to measure in the lab. So we have the profiler components that it's a page that's been out there for a while now, and very few people are using. We have Why Did You Render? That's a really, really interesting library that allows you to spot wasted re-renders and that you can use combined with the profiler. And we have Lighthouse and other tools like Lighthouse that kind of allows you to check metrics, all of those metrics from Core Web Vitals. Also, we should always measure in the field, because it's the only way to know how our apps are actually working to our users. So we have tools like Caliber and Speed Curve to do like observability tools for performance. We have libraries like Web Vitals that it even comes out of the box and create RecDApp, for example, and it allows you to track metrics like first input delay, largest contentful paint, and so on. And if you're using platforms like Vercel, you even have Vercel Analytics out of the box. So I also think it's important not to forget that, yeah, we do have observability tools, and we do have libraries. But in the end, let's always remember that we have the web as a platform. So nowadays, we have a lot of APIs for timing. We have user timing. We have event timing. Event timing, by the way, is the basis for the first input delay metric that we see the tools generating. We have element timing to measure the largest contentful paint. And we also have a lot of profiling APIs in the browser. So we have long tasks API. That is how, under the hood, those tools, they measure your long tasks. We have the self-profiling API that you can use exactly to spot bad parts of your code that are causing long tasks. And you have user agent-specific memory to debug memory leaks in your app. And when we see what these APIs can give us, it's a lot of metadata about our code, about how it's consuming process power, how it's consuming memory, and how it's affecting the experience. One last thing is the future. And I'm so hyped with everything I've talked so far. And I think that the future is even brighter. There are a lot of amazing stuff coming down the line. So we're going to have I/O libraries like React Fetch. I know it's been promised for a while now, but at some point it's going to be there. We're going to have the cache components to allow data fetching libraries to properly integrate with Suspense to have like better integration. This is one of my favorite ones. We're going to have Suspense for CPU-bound trees. So that's kind of like you check your code and you know which operations are going to be really heavy. So you just add one extra pop in Suspense, and that's going to fall back immediately without even trying to render that CPU-bound tree. And then it's going to render fallback, and then it goes after rendering that. There's going to be also more hooks for library maintainers, like user insertion. In fact, the off-screen component, which is a declarative way of assigning like idle priority to some part of your tree. Server components, which don't need further explanation. They are amazing. And the web is also, there's a lot of things. The APIs I mentioned, some of them are still being spec'd like they used. So we're going to have a lot of native scheduling primitives in the browser, and that's going to be amazing. And much more. Seriously, we could have like tons of different talks about each of those topics, and it wouldn't be enough. So moving to a couple of closing notes. I guess the first one would be, we can clearly see that React has been pushing web apps to the future, web APIs to the future. So this is the example for the scheduling API, and the is-input pending part of the API, for example, it was drafted by Facebook, and a lot of the requirements are aligned with the core team. And we have other examples, for example, like effect handlers, algebraic effect handlers in JavaScript. The discussions for having that started like 5 or 6 years ago when one of the core team members of React wanted to have them in the language. Another thing we can see is that the framework tries to address the lack of some features in JavaScript as a language, but also in the browser as a platform with their own solutions. So for example, when we saw this morning, like we were throwing a promise, this sounds like a hacky solution, etc., but that's an oversimplified way of describing Suspense. But actually, what Suspense is trying to do is to do effect handlers in a language that doesn't have effect handlers in continuation. And the same thing with the scheduler API. So React is building a scheduler probably because the browser doesn't have a proper one. And it leads to thinking that understanding these internals and the motivations behind them helps a lot, helps us bringing our own abstractions on top of that, like this scheduler we drafted in 40 lines of code based on generators. It is important to emphasize that scheduling, by definition, does not necessarily mean a better performance. And just like that, there's no silver bullet. So it's really important that you identify your core metrics and use the observability service, the libraries, and the web APIs to actually figure out what's working for you. And there's a lot of information out there. So you're going to see, especially on Twitter, GitHub, and etc., different members of the communities making really good points about each of those libraries as well, the Solid, React, etc. And those are all really good points. So it's important that for us to always correlate the business metrics with performance, because there's no way to game business metrics so that we can post on Twitter that they're cool, because these are what actually are making results for our clients. So measure and correlate that. It is a closing thought, not related though. I work with Medallia, and we are hiring in a lot of countries, including here in India. And if you're interested, just reach out to me. I do have a couple stickers, as I said in the beginning, and I have the results for the thing. So if you think you might be the first one, let's chat. The slides for these sessions are going to be available on my speaker deck. It's not published yet, but by the end of the day, it is going to be. And there are slides. Oops. Yeah, feel free to take a picture. But this is the one go-to link. You're going to find the slides for this session. You're going to find other sessions about internals of React, the performance optimization, etc., as well as info for Medallia. That's all I had for today. Thank you so much for having me, and it's great to be here.
Thank you for explaining us how we can use the newer APIs to improve the performance of our applications, especially concurrency. So our next talk is about forms. Anyone who has implemented forms knows one thing, that as soon as you start adding forms to a page, it becomes a nightmare to control the data and also at the same time to control the performance of that page. And then we start thinking whether we should have went with controlled components or uncontrolled ones. So in his next talk, Akash is going to solve this confusion for us. He's a software engineer at Razorpay. And fun fact, he had just graduated 2 weeks ago. This is his first React conference. So can we have a loud clap of hands to welcome him, please? All the best.
React India. React India.
Hello. 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 Is it working? Am I audible? I think the volume, okay, now it's fine, right? Okay, cool. Not gonna lie, I'm quite happy that it started raining so that people can stay here and listen to my talk because it's the last talk of today, so yeah. I'm quite excited to be here and I'll be talking about how you can calm down your overreactive forms using uncontrolled components. A little bit about me. My name is Akash Amirvasia. I write code at Razorpay and build products to help early stage founders in their startup journey. I also like trying new technologies and have contributed to a ton of projects and products in open source. Fun fact, one of my open source projects became #1 product of the day on Product Hunt, and it wasn't planned at all, it just happened. You can find my Twitter and GitHub. You can follow the stuff that I do and the projects that I contribute to. And I also have a personal website where you can find me bragging about myself. So let's talk about forms. Forms are important. Why, you may ask? Well, it's arguably the most interactive part of any web app today. A poorly optimized form can be a very jarring experience to the user. The user has a ton of things to do at any given point of time. And the fact that they have chosen your web app is itself a big thing. And then they have decided to fill the huge form that you're showing to them. And if that form is not optimized and causes a poor experience, I think you're doing injustice to the user. So it's important to define what poorly optimized can be here. It can be the UI and the UX of the form. It can be the accessibility of the form fields, which is a very important topic in itself. And it can also be the performance of the form, which is what we'll be discussing in detail today. Obviously, no one likes a form that has a noticeable lag while typing. And by the end of this talk, we'll build a nice API that actually eliminates these kind of issues. So let's look at a simple example at how forms are usually built in React. I'm sure most of you have
build forms this way at one point or another. So here, this is a very simple login form, and here we have two fields, email and password. Here we have two state variables, email, password, for storing the value of each of these fields, and then we set the value of input email as the value of the email state variable, and we attach the onChange handler, which updates the value of the state. This is a very common form technique that I'm sure most of us have built at one point or another. And obviously, since it's a form, we can attach a onSubmit handler, and within the handler we can access the values of email and password and use it to actually do the operation of the form. So this is cool. Let's actually try counting the number of renders of this simple form. So I'll just type in a very simple email address, some password, nothing fancy, and look at the number of re-renders, 26. This is just two fields, and it has rendered 26 times. Now just imagine this becoming larger, adding more input fields. Maybe the user types a lot of text. At every keystroke, your components inside the form keep re-rendering. So it's bad, and it gets even worse with more components. As the form grows, as the input elements increase, as you add more decorative components within your form, the performance gets worse and worse because you are rendering way too much. And the reason I'm even talking about this is because I have been a victim to this. This is another side project of mine called Diode. It is not important to know what the project does, but this entire page that you see here is actually a large form. So here we have like a select menu, we have input, we have like a few switches, we have dynamic inputs which the user can click on add to add more input fields, click on remove to remove them. If we scroll down, there's a few more decorative components just to see how things are working. And there are again more switches which if you turn on will show even more input fields. So all of these things, all of these components are actually one giant form, and there's a small submit button or a save button at the end to save all the changes. And honestly, I built this entire thing with using control components, a simple state, updating each and every field and storing the new state in the large object. And yeah, it wasn't really a good experience. At every keystroke, even on a powerful Mac, I could feel the lag. I'm typing fast and the component is updating slowly. And it's very, very annoying, trust me. So yes, you could React.memo the components and use memo some expensive calculations too. But that doesn't really solve the underlying problem of over-rendering in the first place. So let's talk about, an old friend, uncontrolled components. How many of you remember or even use uncontrolled components in your day-to-day stuff? So a quick refresher, uncontrolled component is one that stores its state data internally, and the consumer or the parent of the component that is using the component does not really control the component's state. It asks the component whenever it needs the latest data for some operation. In case of the form elements, the DOM manages the state of the form fields, and that is why the React components don't have to manage the state, and hence re-renders are not required for reflecting the changes because DOM is already optimized to do these things. So it's better to leave it to the DOM as long as you don't have custom logic or if you don't understand what optimizations that you can do in React itself. So let's try to build uncontrolled forms using uncontrolled components. So we can use uncontrolled components for simple forms with lot less boilerplate. In the next slide, I'll show an example with only uncontrolled input elements, and you'll see how less boilerplate that is. And the result is actually a really nice user experience and a great developer experience as well. Again, I'll come to it in the next slide. And just like Ken said 3 years back, so he put out this tweet at 3 a.m. So I'm pretty sure he was serious about this. So now let's actually look at how we can, how most forms out there should be built using uncontrolled components. So same form, same simple login form. We have two inputs, email, password. Notice how we are not setting value or on change, all that. It's just the simple name field that we are assigning so that we can figure out which input has which value. And within our on submit handler, we are getting all the data of the form by simply using the form data API. The form data API takes a form element and it gives you the entire data about the form. And you can use this snippet of code to convert that form data to a simple object where the key in that object will be the name of the input and the value will be the value in the input field. And look at this code. This I think it's smaller and much easier to understand compared to the controlled counterpart that we had seen earlier. So here let's actually try to count the number of renders. Any guesses how many times this component renders? Yes, so let's actually try it out. Notice how many times it's rendering. It's actually not re-rendering at all because we don't have any state updates. Our UI is not changing, so there's no point in actually causing a re-render. So this looks awesome, right? Even though it's not the most React way of doing things, but I think it works very well for most forms out there. Unfortunately, it has various drawbacks for serious forms, and by serious I mean those forms that do more than just collecting and submitting data to a server. So how do you perform complex validation in this case? You can rely on HTML pattern and native ways of validating, but you can only go to some extent, and you would require some extra validations using JavaScript, and it's quite hard to do in this setup that we have. The second thing is, how do you have fields that cause changes in the UI? In the example of a project that I showed earlier, I had a switch which on turning on was actually showing more input fields. But with this setup, how will I have a UI that actually depends on the value of other input fields? You can do it, but it's very hard and it gets very clumsy. Third thing is, how do you update values declaratively? When you're using control components, it's very easy to update the value programmatically. You just have to update the state and that will automatically be reflected. But here you'll have to dig deep into the DOM API and then set the correct attribute, and only then maybe it will work correctly. Then it's computed field values, again things that depend on other things. Basically what I'm getting to at is you have lost reactivity and control altogether when you're using uncontrolled components. So we are at two extremes over here. We like the simplicity and performance that we just got, but not at the cost of reactivity. So the two extremes are using uncontrolled components, we are getting the nice performance, the nice user experience, but we have lost reactivity, which is an important thing. Second thing with control components, which gives us all the reactivity benefits, but then there's way too many re-renders and it might slow things down when you have a large form. So how do we find a middle ground here? Say hello to on-demand reactivity. This is just a fancy term that I coined 1 hour back. It just means that cause state updates when you actually need and use uncontrolled components otherwise. So let's try to build a simple API around this idea. Pretty sure nobody saw that. So let's start by some simple refactoring. First, we start by actually creating a simple ref with an empty object called fields on line 2. And what we're doing is trying to store the ref of every input that we have in the form so that we can programmatically do some interesting stuff with it. So here on line, I think 9, we are storing the ref of the email input within the fields object, and similarly for password. And then we assign the onChange handler. Now the onChange is actually a very important event if you think about it, because it inherently is the function that tells you that something has changed in the input, and that is probably a hint to you that if you are actually dependent on the value of that input, you should probably consider re-rendering. And if you don't actually depend on it, there's no point in re-rendering. So here for the email input, the onChange handler, let's say my form actually depended on the email inputs value, I can actually trigger a re-render manually within the input emails on change handler. If I don't depend on it, no need to trigger a re-render. Again, some refactoring. So we had 2 different on-change handlers. Now I've just extracted it out to a single one. We can still differentiate between which input has actually changed by getting the name of the input. Now let's actually try to extract all these things to a use form hook, because the thing here is that we are actually writing a lot of repetitive code in the input. We assign name, we assign ref, we assign on change. Again, when we add another input, we'll have to assign name, ref, and on change, which is quite repetitive. So let's just extract out everything. So this is use form. Nothing different, only one function that has been added called register. What register does is it takes the name of the input field that we were manually setting as the prop, and it returns all the props that needs to be assigned. So in the previous example, we were assigning name, ref, on change. Here in the register, we are returning name, ref, and on change dynamically. And from the consumer side, it becomes very convenient to use. You can just call register, email, and destructure all the props and spread it across the input element. While we are at it, let's actually add another field called confirm password. So we are now building a sign up form. The user can enter email, password, and confirm password. And let's go ahead. So the next thing that we'll discuss about is thinking about the API. So whenever I'm building like a library or some dev tooling, I like to think backwards. I first start by thinking about the most ideal API that I would enjoy using when I'm building something, and then try to bring it backward and implement that. So if I find an API interface and a structure that is very flexible, very enjoying to work with, only then I go ahead and implement it to actually work. So as a consumer, what do I have to do with a form? Right now I have only register, fine. The most important thing about the form is actually getting the values of the form. So let's expose a function called getValues, which we can use whenever we want the values of the form. So here in this example, we have handle signup, where we are calling getValues, and we'll get all the values of the form. Whenever we need values, we'll call getValues. The next function that we'll expose is an important one, and it's called watch. So watch is a function to declaratively subscribe to changes to a form field. A lot of jargon there, but just it's a fancy way of subscribing to changes of input elements without having to attach event listeners or anything like that. And as we get into implementing it, I think it will become more clearer. But here what I'm doing on line 15 is watching the value of password, watching the value of confirm password, and checking if they are equal. If they are not equal, I'll show the message passwords don't match. And the reason we are using watch is because as soon as the user types a password in both the fields that are same, I want to hide that passwords don't match message. So my UI has it is now dependent on the value of password and confirm password. And that's why I want to subscribe to listen to the changes of password and confirm password fields. And the fun thing about this watch function is that it's declarative, and you can subscribe and unsubscribe automatically. So here, let's say I add a checkbox, a very contrived example. So let's say I add a checkbox to allow the user to enable or disable this password checking logic. Let's say the user disables it. That means the watch check password match function call will return false, and I'll automatically not subscribe to listening to password and confirm password fields. As soon as the user turns it on, the watch password, confirm password, that ternary branch will be executed, and I'll automatically subscribe to listen to the password and confirm password changes. So let's go ahead and actually implement the use form hook. The first function was getValues. This is quite simple. We already have an object with all the input elements that are there in the form. We just go through it and get all the values, and we return that in a nice format. This is the interesting bit. So the watch, as I said, is a way for the consumer to subscribe to listen to the changes of specific inputs. And here what we do is, first we start by creating a set. I'll get to why we create a set. Come to the watch function's definition. What we are doing is, first we are adding the name of the input field that the user is interested to listen to in the set, and then we return the current value that we have from the function. Now, whenever the onChange handler is called, remember the handle change function was set as onChange for all the input elements in the form. Whenever the handle change is called, we check if the watched set has the name of the input that the user had subscribed to, only then we want to trigger a re-render. If the user hasn't, or if the part of the component code did not execute with any watch function calls, the set will be empty and there will not be any re-renders, because that if condition will become completely false and will prevent any re-render. Now, how do we trigger a re-render? So this is a very naive way. Just add a state variable, and here I'm just updating the value to something so that it forces a re-render. And let's actually see how it looks from the consumer side. I haven't changed a lot over here, so just the check watch, check password, and watch password, all that logic I've just extracted out as a variable is invalid. And yeah, I use it to show the passwords don't match message. So let's actually try this out. I'm changing email. Notice the number of renders, it still stays as 1 because we haven't subscribed to listen to the changes of email. Now let me actually try changing password. Any guesses what will happen? Will the number of renders increase or stay the same? Oh, nice. So it will actually stay the same. So I'm typing something and the number of renders still stay the same. Any reason, any guesses why it stays the same? Okay, I'm typing confirm password, still it stays the same, nothing is happening. Now let me actually turn on this checkbox. The number of renders increased by 1 because my code is actually listening to or it has subscribed to the value of this checkbox, and because it changed, I triggered a re-render and my UI updated. Now let me actually try typing. Notice how I'm automatically subscribed to the password input and the number of renders are increasing. Let me actually remove this and let me try typing the same password. And because my condition is invalid became false, I don't show the message anymore. So my UI has started behaving reactive, and we aren't using controlled components anywhere till now. We are still using uncontrolled components, but the added benefit here is that we have selective control over which fields we want to listen to for changes. So is this the best? It looks like we have reached a really nice API, right? We are able to selectively listen to fields that might actually cause changes, and we prevent re-renders when the input is not really causing any changes to the UI. Unfortunately, no, we are still over-rendering because we render on input change and not on derived data change. Any guess like what is over-rendering still over here? So I'll just, so notice when I'm typing the email, nothing happens. This is behaving as we want. But let's say I type some password and also enable this check. My is invalid is now true, and I keep typing, and notice I'm still re-rendering. This is actually a wasted render. My UI hasn't changed. The is invalid is still true. So I don't have to cause a re-render, right? Because the data, the is invalid is still true, and my UI is still the same. So why am I re-rendering and causing extra renders? Similarly, if I come to confirm password, notice how even this is causing many renders, because again we are just listening to the value, not the change in the is invalid check that we are doing. So the solution to solve this is actually memoizing the derived data of your form fields and render only when it changes. So in the code over here, we had the is invalid variable. This is actually a derived data because it depends on the values of various form inputs. It depends on 3 inputs. One is the checkbox, the second is the password input field, the third is the confirm password field. Whenever any of these change, I just trigger a re-render. I don't actually check whether the value is invalid has changed or not. Only if is invalid has changed, I should actually trigger a re-render, because is invalid is a boolean, it can only be true or false. So let's actually try to add memoization a bit over here. let's start by first defining a simple API again around defining the derived data logic. So here we have, we are passing derived, and the is invalid as a key to that object, and we are defining the logic of how we can compute this is invalid data. So in this case, we are just checking whether password is not equal to confirm password, and we are returning that. So it's simply defining the derived data here. And how do we listen to the changes of the derived data? Well, we already defined a very nice API, right? We defined the watch function. Can we use the same watch function to listen to changes of the derived data as well, instead of just listening for input changes? So now actually, let's try implementing this. It looks like a lot of code, but honestly, it's quite simple. There's only two functions that I've added here. One is get derived to compute the values of each of the derived data. So it goes through all the data that you have defined in the derived object, and it computes the value for each of them. And the second function is derived different. This is a function to check whether the previous derived state is different from the current derived state, basically. So we also have a ref called memoize that's just storing the current state of derived values, and whenever we want to check whether the derived data has changed, we can check using the is derived different method over here. Now this is actually the important part. So here what we are doing is, first in the watch function, we were previously returning only the value from the fields ref that we had. So like if the user has subscribed to some input field, we return the value at that time. But now let's say the fields ref that we had, we don't have, let's say, the input field called is invalid, right? So instead of searching for fields, now check memoized ref as well, because that is where the derived data is stored. If you find the data over there, just return it. And within the handle change, we make small updates. We calculate the next derived data state. We compare whether the derived data has changed using the is derived function, is derived different function. And yeah, if it has changed, we again force a render. And also we store the next derived data to the ref memoize, so that in the next call we can again perform this comparison. So it looks like a lot of code, but honestly it's quite simple, and I think the result that you get, which we'll see in a bit, is actually quite nice. This is how it looks like from the consumer side. We have just defined a derived data. Previously we were just using const is invalid equals watch. Here we are just passing that in a different way, because now we have a really nice mechanism of handling derived data. So now let's actually try. This is a very optimized form. So the email input, no renders, only one render, which was the initial render. Now let's try the password. We got one render, but after that we don't get any re-renders, because the is invalid data that we had calculated, that actually hasn't changed. It became true and it stays true. So we don't cause an extra render. Now let's actually try changing the confirm password. Notice how we are still not re-rendering, because the is invalid is still true and nothing has actually changed. As soon as the passwords become equal, my is invalid becomes false, and now is when I actually cause another re-render, because my UI is dependent on that value and it's causing the change. So that's why we get another render. So we started out with how many re-renders? 26. We are now at 3, and this one also has an extra form field, so that is also one more thing. An important thing here is, remember that you should use this only if you actually need to, because we are doing a lot of things for handling derived data. We are actually storing, we are comparing previous and the next one. If you have a very simple form similar to the one that we have here, it might actually slow your form down than actually improving it. So if you have, let's say, a very small form, maybe in this case, in such a small form, re-rendering multiple times is actually faster than actually performing the derived check. But if you have a large form, similar to the one that I showed earlier, which was the side project I was working on, there using this concept, right, it saved a lot of re-renders. But wait, there's some good news. You don't have to implement the use form hook because it's already available as a library. It's called React Hook Form. It's made by Bill and the awesome community, awesome React community. And honestly, it's the same thing that we developed here today, right? The API is almost the same. Obviously, the implementation might be very different. There are a lot of edge cases that we didn't actually handle here, but the React Hook Form handles for you, and it makes it even better. The one thing that React Hook Form doesn't support right now is the derived data logic that we added, where we were listening to the changes to derived data and not just the input change. That is something which is missing in React Hook Form, so you still have to listen to input field changes and cause extra re-renders. With that, we have kind of come to the end of this talk. So summarizing, we discussed why using state for storing all form data might not be a good approach, and how you can use uncontrolled components when your UI does not depend on the form, which I think is the case for a lot of forms out there. And if your UI actually depends on the value of the input fields, you can selectively listen to only those fields that are required for changes. And even then, let's say you still have a lot of re-renders, you should actually listen to data changes instead of not just the input changes, and you can use memoization and the comparison technique that we discussed. Again, use this only if you need bottlenecks, because React is already fast, and adding these additional checks might actually slow things down. So do proper testing, and only if you need, try this approach. And the final thing is wrap everything in a delightful API, which is actually fun to use. The last thing, I think this is an important point that I would like to share. Take a peek at the internals of libraries that you use. I think you'll get to learn a lot of awesome stuff. With that, I've come to the end of this talk. Thank you for having me. It has been great giving a talk over here. It's been a privilege, and props to the volunteers for organizing this so well. You can connect with me on Twitter, GitHub, LinkedIn, email, website. If you want access to these slides, you can just go to slides.akashamirvasia.com. You'll find the slides over there. With that, yeah, that's it. Thank you.
Thanks, Akash. It definitely didn't look like your first talk. I personally got to know a lot of things about uncontrolled components that I felt like were big performance issues with it. So I'm really happy about that. Next up is a panel discussion. I know we are running late, so we'll try to make it quick. So yeah, I won't introduce them now because I'm also the moderator, so I can do that then.
React India. React. React India. React India. React.
He's a staff software engineer at Coinbase. Nikhil Sharma, he's an engineer at Postman. Saurav Verma, he's an engineer at Tata 1MG. Matthews, senior software engineer at Medallia. And Mohammad Rafi, engineer at Pushout. He's the famous one here, I believe. Okay, please have seats. Okay, the good thing here is I can shamelessly see at my screen for all the questions that I have to ask. Okay, so the topic of this panel discussion is what are the expectations from web framework? Like it itself is a very straightforward question, but at the pressure of breaking it into multiple ones. So the first question I have for you all is, so why did you choose to go with a particular framework in whatever last project you did? Like, I don't want to know about the pros and cons of one framework versus the other. Just one feature that one framework had that sold it for you that I should go ahead with this one. So we can start with Prateek.
So it's working? Okay.
Yeah.
Cool. So I guess as soon as I started working on large scale applications, one of the biggest thing was maintainability, and like bringing on folks on the team and getting them to write code which would not regress performance, right? So guardrails would be the one keyword. If my framework can tell me and the rest of the team that you're basically doing something which would go and regress your performance, not just like have those primitives which would give you good performance, but would also warn you against using anti-practices, that would be one of the major things that I would easily get sold on.
Okay, so which framework did that which you actually accepted?
One of the good ones that I currently use is definitely Next, right? It has bunch of primitives, components, image components and stuff, but basically can also yell at you when you are just going towards something which is not optimized for scaling or performance at scale.
Okay. Yeah. Nikhil, do you have anything to add to it?
Yeah, like I don't have any strong history around using frameworks. So back in my college days, I started this journey while using Angular. So it's mostly to answer your question, the most important term or a feature that I thought of was mind blowing for me at that time was the concept of shadow DOM and how everything works out of the box when you have data mining and stuff. So it was mostly like that. But yeah, there's also React that if there's React obviously, but there is a very thin line around if it's a framework or if it's a library with the amazing stuff that these libraries and the frameworks are doing. But yeah, that was mostly.
I mean, just to be specific, we are not talking about just React frameworks. We are talking about any framework. So, yeah. Saurabh.
I also started off with Angular, but recently I've been doing React for the last 5 years. What I found with Next.js, which was my choice of framework just recently, is that it was very easy to set up, and we wanted to use it in a place where we did not really care about performance. It was an internal tool, and it's so easy to get Next running, routing set up, and if you just want to do server-side rendering and everything right off the go, right? So I think that there is no really steep learning curve when you want to boot something up. So documentation websites are very easy on Next. And I don't want to use the framework that we use in production, because that would require people to spend a lot of time to actually get that documentation website going.
Okay.
Yeah. Yeah, I've also had an Angular background back in, I don't know, 6 years ago, when I was doing Ionic with Angular 1.3 and etc. Yeah, you feel me? One of the things I would say is performance, but I don't want to go repetitive here. Another thing I think a lot is developer experience and how the framework fits in with the ecosystem. So, for example, even though like my last couple of years have been focused a lot on React and everything in the ecosystem, so Next, Gatsby, React, Inferno, whatever. But I did experiment a bit, for example, when Vue first came out and when Svelte first came out, because they had like really good selling points. But I admit that, for example, back then I was so into JSX and everything that React brought together in the ecosystem that even though, okay, they got this one and this one better benchmark, I still can see, okay, people are improving this performance side of React with React or Inferno, so that the whole developer experience is still smoother. It's been a couple of years since I played with them, so I don't know. I've heard that at this point, for example, Svelte has way better support for TypeScript and etc. So, but anyway, I would say that developer experience is one key thing to me, and because I see that actually this repeats throughout the community, not only with front end. So, even if we look at programming languages, for example, Elixir, that's like backend language for that runs in the Beam virtual machine and etc. That was basically taking something that was there for decades, and then adding like a better environment for engineers and more friendly syntax. And so I think this is one thing. And another thing is saying like how they've been aligned with the web platform. So there's been always some kind of an issue with React. They've always had their own syntactic event system and etc. But it's still like that, but that's something that they've been addressing throughout the years. And the other factors I mentioned in my talk as well, like scheduling and etc. So seeing how they're aligned with the whole platform, like for Remix, like how they're using the power of forms and etc. things that the web gives you, I think that's another factor I would count other than performance.
Great.
I actually have a history of starting side projects that I never complete. So my GitHub repo is probably like haunted by side projects, right? So whenever I actually choose a web framework, I tend to choose something that is like familiar to me, as in like it doesn't need to be the same framework that I used before. It's like in a familiar stance. So, since I'm used to React, like React flavor things. And also when you actually build a project, right, you like actually want to focus on the project, not on the build tools, at least when you are building it initially. So I tend to pick frameworks or anything that would actually help me, get to that MVP initially, quickly, whatever it is. And most of the times that tend to stick as like, the thing that is there forever. Like you never refactor, like serious.
Yeah, I mean, if I can summarize what you all have said, you have almost covered everything from DX to, familiarity and debugging and everything. So I think, what we can see here is that if you combine all of that, you are talking about almost all the features that a web framework should give. And one more thing that I'm surprised to hear is actually, not surprised actually, but we talk a lot about, Angular 1, but I think for most of us, what actually attracted us, like for most of us, our first framework was Angular. It might be because of two-way data binding or whatever that attracted us. Look like it might be a crime, it might be evil, but it's very useful that actually attracts you towards it. So that's a good point. So where do you struggle with the framework of your choice? Like we have talked about why you chose something, but every framework comes with, okay, later you realize that this framework is missing something, right? Whatever you choose, it doesn't matter. So, yeah, Pratik?
Right. One of the common pain points is a lot of JavaScript frameworks. I won't talk about web frameworks, at least the JavaScript frameworks are super emphasized on authoring the code, right? And how do we deliver this code? I guess it's high time we start thinking about like once this code has gone into production, how are users reacting to this? How are my metrics dipping? How are my metrics looking? they may or may not be like business related metrics, right? They can be as simple as web vitals. So the monitoring post authoring, right? Or debugging what has gone wrong, what has gone sideways, post authoring experience is something that I think about a lot. That would have been like a real bliss if JavaScript frameworks start putting them in.
Okay.
Right.
That was my follow-up question, but you have
Okay.
already covered it. Anyways, we'll continue with the same question. Like, what do you think? Yes.
I think one of the most toughest things today's frameworks do is that opting out isn't easy. Right? Once you go into a framework, you're sort of vendor logged in to whatever the framework wants to do. And it would be really amazing to see frameworks that could let us choose different flavors. Because at the end of the day, I feel like web frameworks are primarily just a bunch of opinions brought together. Right? And your opinions might vary, or your requirements might vary from what their opinions are. But every single framework out there I've seen makes it so tough for you to opt out of something. When you opt out of one thing, they say that we're not going to do any of the other optimizations that we are claiming to do. So that is something that I really run into quite often.
Matthias, do you have any opinions about this?
I think it's one of the first things that get my mind is one discussion I was having with Nikhil this morning that kind of has to do with balancing flexibility and consistency when it comes to the framework. So I've seen teams picking up Next.js over SSR, other SSR alternatives because Next.js enforced some guidelines. And for example, some of these people were people who were doing Angular when you had like really more tight guidelines on that. So I think that it's probably not the pain point, but one of them is like when designing the framework, whether you want to be more permissive or more enforce more stuff at framework level. So yeah.
Yeah, Kritish, like, I'll just take another minute, Rafi. So we were like having this very interesting discussion, just as he mentioned, and just to extend upon this, we were talking, as he said, we were talking about the fact that every web framework that we have, like especially like let's talk about JavaScript frameworks like that I've used. Those are all awesome, and the thing is, they bring in some perspective of theirs because there's no defined definition of a best practice, right? Like you can't just have a silver bullet saying like if you want to do code splitting, like here's the only way. If you want to do routing, this is the only way. That's the best, right? So with this, like although it's very interesting to see like different corners, like people looking at it at different angles, and it helps choose like, oh, it could be used like this. Oh, there's another way of using it. So this is good. But at the same time, as Saurav mentioned, right, I would also want web frameworks, like it's just my personal suggestion, although they're doing great stuff, but there can be sort of a middle ground where a web framework brings in its own perspective of doing things, but it also gives you an opt-in feature of like let's say I use like some like a framework, let's say Next.js or Remix, any framework, and maybe in the future I realize that hey, like my requirements have changed a bit, which I had not anticipated for. Now for that requirement, I might not have to change the web framework entirely, right? So that framework should give me sort of a way to scale it on top of things, like just provide me a way to opt in some other stuff. So this is like one thing that like I am really curious about when using web frameworks, and something like along with it, maybe I think Rafi might mention about it, but like a developer community and people who are like very interested about that framework is something I look for, because if there are people already building like cooler stuff on top of it, it's really easier to choose that way, because it might not have a support of something now, but if people are using it, you might not know. There might be tons of libraries or plugins that are gonna come in with it. So that's the thing. So yeah.
Okay, Rafi.
So one particular thing that I actually like have faced issues with a lot of web framework, starting with Backbone, then to Angular, and then to React, and then to Next, and so on, is all the abstractions are leaky, right? They are not perfect abstractions, right? So let's say if you take Angular 1, like the oldest one, So it came in with what do you call, like binding, data binding, right? That is not proper. If you do something outside that in like plain JavaScript, right, it actually breaks. It doesn't like work well. Of course, React also has its own issues on the same lines. So like abstractions, whatever we build in whatever framework won't be perfect. Like, so it'll be nice if framework, how do you put it, provide a way to like somehow deal with this leakiness, because it's never going to be fixed. It's probably going to be reduced, but it's never going to be fixed. Like figure out a way to deal with this like leaky abstraction issues, like whenever it happens, and like, sorry.
Okay, fine. My next question is similar, so I'm not going to summarize this, but your answer might differ. Like you talked about different problems that you face with the current web framework that you are using, but some of the problems are, I think those problems are not easy to fix. Like the problem was of making it like opt out easy. Making opt out easy is not something that that is a trivial problem to solve. But there must be few things that you must think that okay, it would have been great if my framework actually did this. Not as big as opting out, but something maybe something that your use case is, but your framework is not serving it. So are there things like that? Like are there such kind of improvements that you want in the framework of your choice? Anyone? Yes, please.
Yeah, so I can go in. So one thing that I'm like really passionate about is adding like some security practices when I'm like using a framework, right? So like what I have seen, although like that my knowledge might be like slightly limited, but I have seen like very like security practices like adding security headers to your APIs whenever like you're making network calls. But like what I'm more curious about is if I'm using a framework, I don't want to like care about if my hacker, like any hacker in the world, can trespass my app in some way. Like I don't want to think about those sort of exceptions altogether. So like this is one thing that I really look forward to, like in like any future improvements that the web frameworks might bring in. So this is one point that I had. Yeah.
That's a great point. Yeah, you also want to say something?
Yeah. If frameworks made transitions and animations easier, man, that would be so good, right?
I second that. Yeah.
It's so tough to do things across routes, and we have to write all sorts of data sharing pipelines and preload things, pre-render things, just so that we could seamlessly migrate to a different route. That is extremely tough today, and I don't see frameworks working towards doing anything good there. One concern that I have always had is that abstractions are pretty high in frameworks. For example, when Mohammed talked about Angular, right, and two-way data binding in Angular, I was fairly young then. I had just started writing, building websites with Angular, and to me, that's how I thought browsers were working, right? So I never looked at orchestrating my own way of binding data in Vue. To me, it was, okay, this is how it works, it's just magic. And I think a lot of frameworks for a lot of people is magic. And we should probably have toggles or areas where we could lower those abstractions or have maybe detailed information about how things are working underneath. So that as people start growing from software developer 1 to 2, 3, and they're framework intensive, like dependent on the framework, they slowly get to learn as well. Okay, that's a problem.
Do you want to take this?
Another thing I would love to see is, for example, and that's one of the amazing things that Svelte does, and I'm looking forward to the future of React, is like getting more compile time optimizations, but for performance. I think that one of the things that React misses the most nowadays, and not only React, are more optimizations. Of course, we have optimizations when it comes to tree shaking and that kind of stuff, but I mean more in terms of Svelte. But of course, it's tricky because of the whole nature of virtual DOM when you compare that to reactivity and etc. But I'd love to see that, and because he spoke about abstraction leaks, one thing, I'm not saying it's going to happen, but it would be interesting to see. We going back when we didn't have to think a lot about memorizing every single thing we do, like when we had less abstraction leaks in React, for example. So yeah, having like the default state being fast again would be something to be interesting to see, and I think compilers might be one of the ways.
Before going ahead, we have used this term abstractions a lot, right? Can you explain what they mean? There are a lot of people who might not have heard about it, so we want to explain what abstractions actually mean.
Not abstractions themselves, but when we meant abstraction leaks is, for example, sorry, I need to make the reference. So in the session, my session, I showed the talk of 2013 when React was starting to be the thing and etc. And the default state was fast and etc. But then, so you had this abstraction that you just wrote your components and they were faster, because back then what you had was jQuery and other heavy DOM manipulation, etc. So the default state that you had to write your app was that. But then, given time, we started to see the pain points of React and to have points where the abstraction we have didn't work. So we needed new things like hooks, like pure components, and etc. So the abstraction leaks are kind of this, the points where the abstraction that React gives us out of the box is not enough and we need more things. So I think, I'm not sure if that's what you meant, but when I talked about that, that's kind of the thing I meant.
No,
I do have a point to what you just said, like on compile time optimizations. I do have this big wish list item where, like, as a developer, we see every day new compiler time optimizations landing in different frameworks or different pieces, right? Recently, Astro has come out where it is great for content heavy because it can optimize sending less JavaScript and can only send like JS sprinkles, right? Whereas Next.js has come out for SSR heavy, and then there are a bunch of other frameworks. I would love if the framework, whichever I'm using, can look at my source code and alter its strategy, right? I'm great. I need to do these XYZ things because this is a very interaction heavy page, versus I can go more Astro way, right? For context, like Astro is this new JavaScript framework, I can say, which has very recently landed, and it's meant for content heavy websites, not very interaction heavy, right? So if the framework itself can quickly realize, looking at the code, what way does it need to deliver itself, that would be great, right? As a developer, I don't need to be, I don't need to know like, hey, do I need to switch my tools because my just one of the pages is marketing pages and it's very content heavy, versus the other ones are forms heavy, versus the third ones are animations heavy. Like, can you morph yourself to suit the needs of the current response? That would be great. Right?
Yeah.
Like, look at compile time and just change yourself.
Yeah, actually, I think like just one point to add, like a super big like to what Prateek said. One thing like that I have been listening about the frameworks is, hey, the learning curve is like too much for frameworks. Like, I have to learn JavaScript, and I also like want to have to learn how to use the framework, right? So I think this is also like one thing. Although like the frameworks have been trying to do this brilliantly, but this one thing I think, if we can reduce this learning curve to a bit where the framework's strategies or its perspective becomes, you know, more welcoming. Because like what I've seen with React is, we call it a library, we call it a framework, that's a different topic, but it gives you some perspective, but it does not, like it tells you that, okay, it's opt-in. You might use it, you might not use it. It's completely up to you. And why people use React is, it's just simple JavaScript. Like you know JavaScript, then you almost know React. So this is also one thing that I would like the frameworks to be like more welcoming, because they're already bringing in so much to the table that's valuable. So if it's easier to understand and like be and get acquainted with it faster, so that's something that you know, would add into the success of that framework. So yeah.
Rafi, do you want to add anything?
So in addition to all the other things that they said, there's one thing I really wished all frameworks did, especially when coming up with a new feature, right? In whatever framework, right? It'll be nice if the features are named in like simple words, like in a very simple words, because it's sometimes very hard to search. And like, let's say if I talk about like suspense, right? You might not know what suspense is if you didn't actually read the doc. So like naming things is actually a very hard thing in programming, but especially in a library of sort, like it'll be nice if they like go with the simpler names.
Yeah, I mean, that's a problem I think everyone suffers with when you start reading the docs of a new framework especially. It's a random names that you have to know, then only you can search about them.
I think we should get some design system guy to start naming things. They're pretty good at it.
If only it's possible, yes, why not? Okay, so most of the times when we look at web frameworks, the biggest thing we consider is how easy it is to get started with something, right? But what we often ignore is what happens after the app reaches production. Like, how do you think a web framework can make your life easy in that regard? After the web is in production, what role can web frameworks play? You want to go?
I can start. So
yes.
we have like years of knowledge behind us on how to optimize web applications, right? We do conferences every year, we do courses, and like there's a ton of knowledge of, hey, here's my web page, can someone look at it and tell me like how to improve it, right? I would love to see if like a web framework can create an observability bot around all this knowledge that we have through all these years, and can come back and tell me that, hey, you have shipped this thing, great, this works now, but probably you should go and change X, Y, and Z. You are having janks in your frames, and this is coming from this X, Y, and Z piece of code because it's a framework code, right? It's written with you. Also, the manner these images are loading, they're not the best. Probably go and use suspense list or something else, right? So, like, all these years of knowledge of performance improvement, if frameworks can start baking it in, this may or may not be a framework. This can be like a platform, right? That framework can have on site as an offering, but it's probably the right time that someone automated can start doing this. And I'm not hinting ML and AI here. It's just very simple, straightforward. Start having bots, look at what we look as humans, right? And start telling me those things. As humans, I'd slip on them.
I mean, the moment you say you want a machine to act like a human, you are already...
That's why I clarified that I'm not hinting. Don't throw AI/ML just because I said this.
So, do you want something like what happens with Next.js, where they have ESLint configured to tell you that
that's
load image?
That's still like pre-commit, right?
Yeah. That's a start,
great.
right?
That's a start in the right direction.
Okay.
I want to see that more. Like, if someone can come back and tell me, hey, I profiled it for you,
yeah,
right?
Oh yeah. Do you also write a ton of like cron jobs to profile your websites here and there? A lot of tools.
I have done that in my career, right?
Yeah.
I don't want to do that.
Exactly, right.
Anymore.
So I'm assuming that's where you're also coming from, right?
Exactly.
So yeah, I think telemetry and application monitoring is definitely another region that would help.
By the way, we already have Kent here. Why not like we like sometimes discuss with him like why not add AI stuff with Remix and all? So yeah.
So I mean, they're just adding feature requests for you.
It's a feature request, yeah.
Okay, Rafi, do you want to add something? Okay, no, nothing. Fine. Okay, so we are short on time, so we'll go to the last question. Where do you think framework can help you with your architecture?
I didn't get your question. What is it about?
So I mean, first thing, like, you can think about it in a way that how much does your framework influence your architecture and how they can help you in deciding the architecture. Like, one of the things that you generally have to discuss a lot is which architecture should we go ahead with, so that it's scalable, maintainable, and all that. But can framework come and say that, hey, you should be using this? I think this is somehow related to what Prateek said, like we have all those learnings.
Feature
and
request.
Yeah, there's someone, not a machine, who comes and says that, okay, this is the way you can do it. But do you have any ideas about that? Like how can frameworks help you decide your architecture?
That would be really tough, right? Because then you also have to look at how your backend is set up, how your data fetching pipelines are set. Although some of it the framework would already know, depending on how are you fetching multiple APIs, are you using GraphQL. I think the architecture dramatically changes. How many cache layers do you have? At what stages are you caching things? And the choices keep changing. And we did an entire 4-hour workshop trying to solve that, but we just had a lot of different optimizations laid out for people, and we just said pick whatever works for you. The way at least we work, or at least I work, is that I like my frameworks like an open heart surgery. Everything ready for me to tweak. And I look at other frameworks, see where they fell apart, and try fix it on my own preemptively.
Okay. Okay. I don't think anyone wants to add something to it. Fine. Then yeah, I think what we can summarize from here is we want more automation in our frameworks. We want the framework to tell us what we should do, use the learnings that we have had since years, provide a better debugging experience, that's always important, and developer experience. And yeah, I mean, use cases, features, and all, definitely. There will never be an end to how many features you want in your framework. But these are the things that actually stand out, because you can always choose a framework because it has some feature and later it gets added to other framework which you rejected, right? So yeah, I mean, it's good to hear different perspectives, what's important for whom, instead of just saying that, hey, here's a list of pros and cons of this framework versus this framework. There are thousands of blogs all over, all over the internet, and we didn't want to get into that, but still talk about something relevant. So thank you, everyone. And I know there has been a delay, so we are really sorry for that. I think, yeah. Thanks.
Thank you. Thank you so much.
Okay, I think, yeah. Okay, looks like it's not raining anymore. I hope so. Otherwise, if I say, bye, everyone will still be sitting here. Okay, so before we wrap up the day, I'd like to thank our sponsors, Pushowl, Rippling, Agora, The Graph, Storyblock, DevRev, Disney Plus Hotstar, Diet, Comet Chat, EPAM, Proximity Works, SyncFusion, Tata 1MG, Geeky Ants, Gumblet, Expedient Group, Saloon, Sprinkler, N26, Zata, OLX Group, Microsoft, Lab49, Medallia, our diversity sponsor, Flight Control, media sponsors, JS Party and Web Dev Samachar, live stream sponsor, Diet, and organizer, Geekabyte. Now, we're going to wrap up the day. I hope you enjoyed day 1 of React India. We see empty seats here, but if you go there, like, it's full. It's weird why, we don't know. But I hope you are here tomorrow early morning at 8:55. That's when we'll be starting. And just like today morning, you will be, you'll have something good tomorrow too. And yeah, I hope you go to the beach now. I think if it's raining, whether it's raining or not, that's one place you can always enjoy. So yeah, I mean, have a good rest of the day.
In Expedia, we believe in new changes and new approaches are generated from the differences we have.
The way that you do work may not necessarily be the way that other people do work, and that's absolutely okay.
Authenticity and being your full self and bringing your personality, your experience, and your thoughts to the table.
When I'm me completely, I work to the best of my ability. I can really relax and give my best to the job that I'm paid to do.
Because we have a team that has different perspectives and different makeups and come from different backgrounds, I think it's super powerful.
People often spend more time with their coworkers than they do their own families. We need to make sure that people feel celebrated for who they are when they show up to work. The Resources Guide project was an initiative to make people feel empowered that they could take on self-education about different identity groups. We want to make sure we're always engaging with people where they are in their learning journey, rather than forcing them to move faster or maybe feel like we're slowing them down in some of these conversations.
As a Black woman, I don't have the choice to ignore the way in which I show up differently in the world and the way in which I'm treated differently because of the color of my skin and who I am and things that are not explicitly within my control. I am a perfectionist and I want it to be absolutely perfect, and the reality is people are not looking for perfection. It can be really challenging when you feel like you're speaking for or representing all Black people or all Black women. I do my best not to allow, the weight of everyone that looks like me to fall on my shoulders every day.
Prior to Expedia, I was a nuclear submarine officer in the United States Navy and definitely had some fearful moments or deer in the headlights moments around showing up to these meetings and being like, which side of the table should I sit on, and do I stand up when my boss comes into the room? When I joined the veterans group 3 years ago, they had a board that was all straight, white American men who had been in military service a long time ago. Now we have military spouses on the board. We have diversity represented that is more reflective of our workforce. The age range has been totally redefined as far as people who just came from the military like myself versus people who served in the military 30 and 40 years ago.
I've been now at Expedia for 8 years, and it's been a true breath of fresh air. In my previous employment, for nearly 7 years, I could not be me, because as much as coming out as queer was not even an option. And it never felt safe to be me when I was there. None of us are just one thing. I'm not just transgender, I'm also disabled because I'm deaf. And that's also an element of who I am. I never really felt like I had to hesitate if any incident happened, like for example, somebody actually misgendering me or using the wrong pronouns talking about me. Knowing the atmosphere, knowing the inclusivity at Expedia Group, knowing I'm surrounded by true allies, I knew with confidence that it was an accident.
Inclusion, I think, is not just an abstract concept. It's a framework that we need for good mental health. So when I lost my sister, I was really depressed. It's like a taboo in Japan to talk about your mental health. Management and my teammates really helped me open up and gradually talk about my feelings.
I think people are people largely, whether they're in an office building in downtown or buried underwater in a submarine.
Not only do people need to be empowered to speak, but their perspectives need to be respected.
We have an approach of always going one step further, rather than just it's good enough. Now, good enough is not good enough. The better is always better.
You don't have to be in the impacted population to be frustrated, outraged, or to just want to be a part of positive momentum and change moving forward.
That's the magic that is happening. Inclusivity in a word. Okay, hang on.
Curiosity is the word I imagine for inclusion.
Can I use more than one word?
Proximity was officially set up in 2019, but most of the foundational work actually happened in the 2 years preceding it. I've been running remote product engineering and design teams for the past 5 years across continents and time zones, and most of the asynchronous workflows followed at Proximity are a result of years of experiments and learning. Our workflows and processes are constantly evolving and getting better to this day. Proximity lies at the intersection of growth and speed, and we've been a 100% remote company from day one. Our specialty lies in tackling complex engineering and design challenges for scale-ups and enterprise companies related to performance, scale, and UX. Why performance, scale, and UX? Well, once a company achieves product market fit of a work in the real world, with over 55,000 hours spent on delivering long-lasting value and substantial results for our customers.
React India. React. React India. React India. React.